Welcome to the Deep Dive. Today, we're going to be exploring data science, and how it's really changing the game for businesses, especially if you're already familiar with relational databases.
Yeah, it's really exciting to think about how you can leverage that knowledge to kind of unlock even more potential.
Absolutely. So let's just break it down. What exactly is data science? And why should businesses even care?
Oh, data science, it's like a detective, for your business. It's the systematic process that takes all that raw data you've got, sifts through it, and extracts these valuable insights, that can help you solve those business problems and make those better decisions.
So it's not just about crunching numbers then. It's about using data to tell a story, right? And to reveal things that may not be that obvious at first glance.
Exactly. And it's a blend of a bunch of different disciplines. You've got statistics, machine learning, and your own domain expertise, all working together to unlock the hidden patterns and connections within all your data.
That makes sense. But why is this such a big deal for businesses today?
Well, just think about it. Businesses are swimming in data now, more than ever before. Like every transaction, every website visit, every social media interaction, it's all generating data. But the real value comes from understanding what that data even means and how you can use it to improve your operations.
So it's like having a gold mine in your backyard.
Yeah.
But you need the right tools and the right expertise to extract the gold.
Yeah, exactly. And that's where data science comes in. It gives you the tools and the techniques to turn that raw data, into actionable insights. Like companies, say Capital One, they made it big by understanding the power of data and using it to tailor their offerings and make strategic decisions.
Okay, I see the potential there. But how does data science actually improve decision-making? Mm-hmm. Is it really that different from traditional methods?
Well, you see, traditional decision-making, it often relies on intuition and experience, which can be valuable, but it's also limited. And data science brings in a level of objectivity and rigor that lets you move beyond gut feelings and make decisions that are based on evidence and insights, derived from your data.
So instead of just relying on a hunch, you're using data to back up your decisions. That sounds a lot more reliable.
Yeah, exactly. Data science helps you uncover hidden patterns and relationships that traditional methods they might miss. For example, you might analyze customer transaction data and discover that customers who buy a certain product are also likely to purchase another, seemingly unrelated item.
That's fascinating. So you could then use that insight to create targeted promotions, right?
Right.
Or even bundle products together.
Precisely. It's all about finding those unexpected connections that can give you a competitive edge.
Okay, I'm starting to see the power here. But can we get specific? What are some real-world examples of how data science is being used by businesses today?
Well, the applications are vast, and they're constantly evolving. Think about those personalized recommendations you see, on e-commerce websites.
Yeah.
That's data science in action. Analyzing your past purchases, your browsing history to suggest products you might like.
That's a great example. It feels almost like magic sometimes, but it's really just some clever data analysis going on behind the scenes. What other areas are being impacted by data science?
Well, think about fraud detection. Financial institutions are using data science, to analyze transactions in real time. They identify suspicious activity and prevent fraudulent transactions from even happening.
That's a huge benefit, especially with the rise of online transactions and the increasing sophistication of those fraudsters out there.
Absolutely. Data science is also helping out telecommunication companies, predict which customers are likely to switch providers, allowing them to proactively offer incentives and retain those valuable customers.
So it's about being proactive.
Yeah.
And preventing those losses rather than just reacting to them. That makes a lot of sense.
Exactly. And data science is even being used to improve healthcare outcomes. Hospitals are using data to predict patient readmissions, optimize staffing levels, and even personalize treatment plans.
Wow, data science is truly making a difference across so many industries. This is really eye-opening.
And we've only just scratched the surface. The possibilities are endless, and as more data becomes available, the potential impact of data science is only going to continue to grow.
I'm already starting to see the potential in my own work with databases. It's exciting to think about how data science can unlock even more insights.
And that's what makes this field so fascinating. It's not just about the technology it's about the human element. Using data to solve real-world problems and make a positive impact.
Well said. This has been an incredible introduction to the world of data science.
Before we go any deeper, though, let's remind you to like, share, and subscribe to The Deep Dive for more great content.
We'll be right back with even more fascinating examples of how data science is shaping the business world. Welcome back to The Deep Dive. Before the break, we were just talking about some of the amazing ways data science is being used, across all these different industries. It feels like we're really just scratching the surface here.
Yeah, it's true. The applications of data science are really incredibly vast. And as we generate more and more data, the potential for insights just grows. And what's really cool is how data science can be applied to what you already know about relational databases.
That's what I'm most curious about. So we talked about using data to make better decisions. But how does that actually work in practice?
Okay, well, let's look at an example that might be familiar to you from your work with databases. So imagine you've got this database, okay, full of customer information, and you want to understand which customers are most likely to respond to, like a certain marketing campaign. So a data scientist would use something called predictive modeling.
Predictive modeling. Okay, that sounds intriguing. How does that work?
Well, it involves building this mathematical model based on like historical data, right? Like past customer responses to similar campaigns. And this model can then be used to predict the likelihood of future responses from your current customer base.
So you're basically teaching a computer to learn from past data and make educated guesses about the future. That's really incredible.
Exactly. And the great thing is that this process, it can be applied to a wide range of business problems. Like you could use predictive modeling to forecast inventory needs, optimize pricing strategies, or even assess the risk of loan defaults.
Wow, the possibilities seem endless. But I imagine that building these models can be quite complex, especially when you're dealing with these massive databases.
Yeah, it can be. But thankfully, there are these powerful tools and techniques out there available to data scientists. And one really important concept is something called feature engineering.
Feature engineering. Okay, I haven't heard that term before. What does it mean?
So feature engineering, it involves like selecting and transforming the most relevant variables from your database. And you'll use these in your predictive model. Think of it like this, okay? You're a chef and you're preparing a dish. You wouldn't just throw all the ingredients into a pot, right? Without even considering how they work together.
So feature engineering is about carefully choosing the right ingredients from your database to create a model that's both accurate and efficient.
Exactly. It's about understanding which variables will have like the most predictive power and then transforming them, in a way that the model can actually understand. For example, you might combine multiple variables into a new one. Or you could even convert categorical data into numerical values.
Yeah, I can see how that would be super crucial for building those effective models. But how do you make sure that those models are actually reliable? I mean, what if they just learn the patterns in the existing data, but they can't generalize to new data?
That's a great question. And it brings us back to a concept we mentioned before, overfitting.
Right, overfitting. That's when a model becomes too tailored to the training data.
Yeah.
And then it doesn't perform well on new unseen data.
Exactly. Think of it this way. If you were to write like a database query that was so specific that it only retrieved records for existing customers, well, it wouldn't be very useful for finding new customers, right?
Ah, I see the connection. It's like creating a query that's too narrow, and then it misses out on potentially valuable data.
That's a great analogy. And just like in database, queries overfitting can be a problem in data science models. If a model is too complex, it might learn all the little quirks and nuances of the training data, including noise and outliers, which leads to poor performance on new data.
So how do data scientists prevent this overfitting then?
Well, there are several techniques, but one common approach is to use something called cross-validation.
Cross-validation. Okay, can you remind me how that works again?
Okay, imagine you're training for a marathon, right? You wouldn't just run the full distance every single day. You'd break up your training into like shorter runs, varying the intensity and the terrain to, prepare for the race.
So you're saying cross-validation is like giving your model a variety of those training scenarios to make sure that it can handle different types of data.
Precisely. So in cross-validation, we divide the data into, multiple subsets. The model is trained on one subset, and then it's tested on a completely different subset. And this process is repeated multiple times with different subsets being used for training and testing.
Oh, okay, I get it. So it's like giving your model a series of practice tests to make sure that it can really generalize its knowledge to any new data.
Exactly. And by evaluating the model's performance on all these different subsets, data scientists can get a more robust estimate of its accuracy. And they can identify potential overfitting issues.
This is really helpful. I'm starting to see how those principles of data science can really be applied to the world of databases. Like a whole new layer of understanding is opening up.
Yeah, it's really fascinating, isn't it? And we haven't even touched on some of the more advanced techniques yet, like clustering and text mining.
I was just going to ask about those. Clustering sounds especially interesting. How does that one work?
So clustering, it's like organizing your sock drawer. You group similar socks together based on like color or their size or their type. Well, in data science, clustering algorithms group data points into clusters based on their similarity.
Oh, so you might have a cluster of customers who frequently buy electronics, another cluster who prefer clothing, and so on.
Precisely. And this information, it can be incredibly valuable for businesses. You could tailor marketing campaigns to each cluster, personalize those product recommendations, or even identify new market segments that you might not have known about.
That's incredible. I'm starting to see how data science can really help businesses make those more informed decisions and gain a deeper understanding of their customers.
And we're just getting started. There's still so much more to explore, in this world of data science. But for now, let's remind our listeners to like, share, and subscribe to The Deep Dive for even more insightful content.
We'll be back shortly to delve into even more fascinating applications of data science. Welcome back to The Deep Dive. We've been on this really fascinating journey exploring, the world of data science and its potential for businesses.
Yeah, and it's really cool to see how data science can help us, make better decisions, move beyond intuition and get to the why behind the what in our data.
Absolutely. So we've talked about predictive modeling and clustering, but I'm really curious about text mining. It sounds like it's straight out of a sci-fi movie.
Well, it might sound futuristic, but it's a reality. Text mining is all about, extracting meaning from what we call unstructured text data. Think about all the texts we see every day, right? Emails, social media posts, online reviews, even, this podcast. It's like a gold mine of information just waiting to be discovered.
So how do you actually mine for insights in all that text? It's not like you can just plug it into a spreadsheet.
That's where natural language processing comes in, or NLP. It's a part of AI, artificial intelligence, that focuses on letting computers understand and process human language.
So it's like teaching computers to read and interpret text just like we do.
Exactly. NLP techniques let data scientists, break down text, identify key themes, and extract sentiment. They can even understand the relationships between different words and concepts.
That's really incredible. So what are some practical ways this is being used in business?
Well, the applications are vast, and they're constantly evolving. But one example is sentiment analysis. Businesses use text mining to see what the public thinks about their brand or products by analyzing things like social media posts and online reviews.
That makes sense. So instead of reading through thousands of comments, you can use text mining to get a quick overview of what customers are feeling.
Exactly. Text mining can also be used for things like market research, identifying trends in customer feedback. You can even use it to try to predict future market behavior.
It sounds like text mining is a game changer for any business that interacts with customers online.
Absolutely. And for someone like you with a background in relational databases, text mining can open up this whole new dimension of analysis. Imagine combining structured data from your database with unstructured text data from like customer reviews or social media. You could really get a much richer understanding of your customers and their needs.
That's a brilliant insight. It's like you're connecting the dots between those different types of data to paint a much more complete picture.
Exactly.
Yeah.
And that's the power of data science. It allows you to see things that you just wouldn't be able to see otherwise.
This has been such an insightful deep dive into the world of data science. I'm already thinking about all the ways I can apply these concepts to my work with databases.
And that's what makes this field so exciting. It's constantly evolving. There's always something new to learn. And the possibilities for innovation are just endless.
Before we wrap up, I want to remind our listeners to like, share, and subscribe to the deep dive, for more thought-provoking content.
And if you found this episode helpful, be sure to share it with your colleagues or friends who might be interested in, exploring the power of data science.
Well, that's all the time we have for today. Thanks for joining us on this deep dive into the world of data science. We hope you learned something new and that you're excited about all the possibilities that data science offers businesses across every industry. Welcome back, everyone, to The Deep Dive. Today, we're going to really kind of unpack this concept of data analytic thinking.
Okay.
So, I think, our listeners are probably very familiar with working with databases day in and day out.
Yeah.
But today, we're really going beyond that, the tables and the queries.
Right.
And, and really kind of getting into how to use data strategically
Yeah.
to make those smarter business decisions.
Exactly. It's really about, taking it to that next level. It's not just about knowing how to query a database or pull a report.
Right.
It's really about starting with the business problem first.
Okay.
So, really understanding what is it that we're trying to solve here.
Yeah.
And then from there, what is the data that we need?
Yeah.
How are we going to analyze it?
Right.
And then finally, what are the actions that we're going to take?
Yeah, that makes a lot of sense. So, I mean, I guess my question is, why is this so important?
Sure.
Like, I feel like businesses, they already, look at reports, they look at spreadsheets all the time.
So, why is this data analytic thinking so crucial?
Well, I think a lot of times those reports and spreadsheets, they really focus on what's already happened in the past.
Okay, yeah.
Right. Data analytic thinking is really taking that data and figuring out, well, what could happen in the future?
Right.
And how do we make better decisions now based on what we think might happen?
Yeah.
So, for instance, let's say you're a retailer and you've noticed that sales for a particular product have declined.
I would try to figure out why that was happening.
Yeah.
Maybe run a sale or something.
Exactly. But with data analytic thinking, you can go a lot deeper than that.
Okay.
Right? We can start to analyze sales data along with customer demographics, maybe some of the marketing campaigns that you've run, even weather patterns,
Okay.
to really understand the root cause of that decline.
Right.
So maybe you discover that, a competitor has launched a similar product at a lower price point,
Okay.
or that sales always dip during monsoon season.
Oh, interesting. And then armed with these data-driven insights, you can actually start to make more strategic decisions.
That makes a lot of sense.
Yeah.
So instead of just sort of reacting to something,
Right.
we can use the data to sort of anticipate
Yeah.
and make better decisions.
Exactly. And that can actually lead to, a whole host of benefits for businesses.
Yeah.
Increased profitability, better customer experiences, even a competitive edge in the market.
Wow. So it really is about moving from just kind of like gut feeling to more informed decision making.
Exactly. Yeah.
Okay. I'm with you. I'm starting to see how powerful this can be.
Great.
But where do we even begin with this?
Yeah.
Is there like a framework or a process that can kind of guide us?
There is, yeah. One of the frameworks that's widely used for data mining projects is called CRISP-DM,
Okay.
and that stands for Cross-Industry Standard Process for Data Mining.
Okay.
And it's really just a roadmap that can help you approach data analysis in a really structured and systematic way.
Yeah. No, a roadmap is a good analogy, especially when we're talking about, going into uncharted territory.
Exactly, yeah.
So how does this CRISP-DM thing work?
So it actually breaks the process down into 6 different key stages.
Okay.
So first and foremost, you really need to understand what that business problem is that you're trying to solve.
Okay.
So from there, you're going to move on and really understand the data itself.
Got it.
So what data do you have?
Okay.
What's the quality of it? What are its limitations?
Yeah.
And then comes data preparation.
Oh, okay.
This is where you're going to actually clean and transform that data to make it suitable for analysis.
So it's not just about jumping straight into the analysis.
Right.
There's a lot of groundwork that needs to happen first.
There is, yeah. And a lot of times that's actually where a lot of data projects go wrong,
Oh, okay.
is they skip these crucial early stages
Yeah.
and they end up with flawed analysis and inaccurate conclusions.
Right. Yeah, you need to have that good foundation. Okay, so after the data preparation, what comes next?
So then you move into the modeling stage.
Okay.
And this is where you're actually going to apply statistical or machine learning techniques to extract insights from that data.
Okay, so this is where things start to get a little bit more technical,
It does, yeah.
like building algorithms and all that kind of stuff.
Yeah. But it's always important to remember the technical aspects are just one piece of the puzzle,
Okay.
right? You always need to tie those insights back to that original business problem
Right.
and make sure they're actionable.
That's a good point.
Yeah.
Yeah, we can't get so lost in the numbers that we lose sight of the bigger picture.
Right, exactly.
Okay, so what comes after the modeling stage?
Next is evaluation.
Okay,
This is where you assess how well your model is performing,
got it.
how accurate those predictions are, and whether it actually addresses that business question.
Okay.
And then finally, deployment.
Okay.
This is where you put those insights into action.
Yeah.
Whether that's implementing a new marketing strategy or optimizing a business process.
Right.
Or developing a brand new product.
Okay, so it's like this full cycle
Yeah.
from understanding the problem all the way to putting the data insights into action.
Exactly.
This is making me think about where data science fits into all of this.
Yeah.
How is it different from this traditional data processing
Right.
that companies have been doing for years?
Yeah, that's a great question. So I think of traditional data processing as really focusing on recording and organizing the data.
Okay.
It's about getting that data in order,
Yeah.
generating reports, tracking key metrics.
Got it.
Data science is about going beyond that and using that data to extract knowledge, to discover patterns,
Okay.
to answer those questions that can drive strategic decision-making.
So it's about finding meaning in the data,
Right.
not just crunching the numbers.
Exactly.
Yeah.
Yeah. It's about understanding why things happen,
Okay.
what might happen next.
Yeah.
And then ultimately making better decisions for the future.
Okay, so it's not just about having the data, it's about knowing how to use it to your advantage.
Right.
Okay, and that brings up another point that you mentioned earlier, thinking of data as a strategic asset.
Yeah.
What do you mean by that?
So just like physical assets like buildings or equipment data
Yeah.
needs to be managed properly and leveraged strategically to unlock its full potential.
Okay.
I mean, think about it. You wouldn't leave a valuable piece of machinery just sitting idle, would you?
No.
Right. You would maintain it,
Right.
optimize its performance,
Right.
use it to create value for your business.
Okay.
Data's no different.
So we need to invest in our data,
Yeah.
just like we invest in other parts of our business.
Exactly.
That's a really interesting way to think about it.
It is.
Yeah.
Yeah. Think about every interaction a customer has with your business. Every transaction, every click on your website
Yeah.
is generating valuable data that can be used to understand their behavior, optimize processes,
Yeah.
and just make better decisions.
Okay, so neglecting our data is really like leaving money on the table, though.
It is, yeah.
We're missing out on all those valuable insights
Yeah.
that could help us improve.
And in today's data-driven world,
Right.
those who really understand how to leverage their data strategically
Right.
are going to have a significant advantage over those who don't.
Okay, so it's not just about collecting the data. It's about using it to create that competitive edge.
Exactly. Yeah.
Wow, this is really eye-opening.
It is, yeah. And the exciting thing is that data analytic thinking is constantly evolving
Yeah.
with new tools and techniques emerging all the time.
Well, this is making me think about how artificial intelligence and machine learning are really changing the way we analyze data these days.
Absolutely.
So we're going to dive into that a little bit more after a quick break.
Sounds great. AI and machine learning are definitely shaking things up.
Yeah.
They can help us analyze these massive data sets that would just be impossible for humans to handle. Right.
If we were doing it manually.
Yeah.
So it's like having this super-powered assistant
Oh, wow.
to help us with all that data crunching.
That sounds incredible.
Yeah.
Can you give me like an example of how AI is actually being used
Sure.
in data analytic thinking today?
Absolutely. So let's say you're an e-commerce company.
Okay.
You can use AI to personalize product recommendations for each customer
Oh, okay.
based on, their browsing history, their past purchases,
Right.
even what other customers with similar profiles have got.
Oh, wow. Yeah, so you're really taking that data-driven personalization to the next level.
Exactly.
I've seen that on shopping websites before.
Right.
Sometimes it feels like they know me better than I know myself.
Yeah, yeah.
But I mean, I'm sure this personalization,
Yeah,
it's got to be driven by like some pretty serious data analysis, right?
it is. These AI algorithms, they can sift through mountains of data
Wow.
to identify patterns and make predictions that we as humans just wouldn't be able to spot on our own.
Yeah.
But it's not just about personalization.
Okay.
AI is being used for fraud detection,
Oh, wow.
risk assessment, predictive maintenance.
Yeah.
I mean, you name it.
So it's like data analytic thinking on steroids.
In a way, yeah. It's
Yeah.
really a powerful tool that can amplify our ability
Right.
to extract those insights from the data
Yeah.
and ultimately make better decisions.
Okay.
But, it's important to remember that AI is not a magic bullet.
Right.
You still need that human expertise to define the problem,
Okay.
to choose the right algorithms,
Right.
and then really interpret those results.
That makes sense. So it's really like a partnership
It is.
between human intelligence and artificial intelligence.
Exactly.
Okay. We've talked a lot about the benefits of data analytic thinking,
Ah.
but are there any downsides?
Yeah.
Any challenges that we should be aware of?
There are. I think one of the biggest challenges is ensuring data quality.
Oh, okay.
So if you're working with inaccurate or incomplete data,
your analysis is going to be flawed
right,
and your decisions could be misguided.
So it's garbage in, garbage out, as they say.
Exactly. Yeah, so data cleansing and preparation are really crucial steps in that data analysis process.
Right.
And they often require a significant investment of time and resources.
Okay. Yeah, that makes sense.
Mhm.
So another challenge I would imagine is data privacy and security.
Absolutely.
As we collect more and more data, we need to be mindful of protecting that sensitive information.
Right.
And making sure that we're using it ethically and responsibly.
Exactly.
That's a crucial point.
Yeah.
We can't just blindly chase data without considering the ethical implications.
Right.
So how can we make sure that data analytic thinking is used for good, not for harm?
Well, it starts with having a really strong ethical framework.
Okay.
And establishing those clear guidelines for data collection, usage, and sharing.
Right.
We need to be transparent about how we're using the data.
Okay.
And we need to give individuals control over their own data.
Right. So it's not just about the technology, it's about the people and the principles
It is.
that are guiding its use.
Exactly. Yeah. Data analytic thinking is powerful.
Yeah.
But like any tool, it can be used for good or for ill.
Right.
It's up to us to make sure it's used responsibly and ethically.
This is making me think about the role of data literacy in all of this.
Yeah.
If we want to use data effectively and ethically, we really need to understand it, right?
Absolutely. Data literacy is becoming increasingly important.
Right.
It's not just about being able to write a chart or understand a statistic.
Right.
It's about thinking critically about data,
Okay.
questioning its sources, recognizing potential biases, and understanding its limitations.
So we need to be savvy data consumers,
It's
not just passive recipients of information.
Yeah. We need to engage with that data, ask the right questions,
Right.
and draw informed conclusions.
This whole conversation is really highlighting the importance of data analytic thinking, not just for businesses, but for individuals as well.
Absolutely.
If we want to navigate this increasingly data-driven world, we all need to develop these skills.
We do. Data is everywhere.
Right.
It's shaping every aspect of our lives.
Yeah.
The more we understand about data and how to use it effectively, the better equipped we're going to be to make informed decisions,
Right.
solve problems,
Yeah.
and just create a better future.
So how can we encourage more people to embrace data analytic thinking?
Yeah.
Where do we even begin?
Well, I think it starts with education.
Okay.
We need to incorporate data literacy into our school curriculums.
Okay, yeah.
And we need to make data analysis tools and resources more accessible.
Right. That's a great point.
Yeah.
We can't expect everyone to become data scientists,
Right.
but we can empower everyone to become like data literate citizens.
Exactly. Yeah.
What else can we do?
Well, we can also foster that culture of data-driven decision-making
Okay.
in our organizations and our communities. We can encourage people to ask those data-driven questions,
Yeah.
to challenge assumptions,
Right.
and seek those evidence-based solutions.
So it's about creating a data-driven mindset,
Exactly.
not just adopting data-driven tools.
Yeah.
That's a powerful idea.
Yeah, it is.
So as we're kind of wrapping up our deep dive into data analytic thinking, what's the one key message that you really want our listeners to take away?
Well, I think data analytic thinking is not just a skill set.
Okay.
It's really a way of thinking, a mindset that
Yes.
empowers us to approach the world with curiosity,
Right.
to seek data-driven answers,
Yeah.
and to make more informed decisions.
Okay.
It's a journey of continuous learning and discovery, and
Yeah.
it's a journey that's open to everyone.
That's a fantastic message to end on. But before we say goodbye,
Yeah.
I want to leave our listeners with one final thought.
Okay.
We've talked a lot about the present and the potential, but what about the future? What does the future hold for data analytic thinking?
Well, it's a rapidly evolving field, that's for sure.
Right. Yeah. The future of data analytic thinking.
Yeah.
It is exciting
Yeah.
and a little bit daunting. What are your thoughts?
Well, one of the trends that we're seeing is this increasing democratization of data
Okay.
and analytics tools.
Oh.
More and more people have access to these powerful tools
Right.
that were once only available to, data scientists.
Yeah. So it's kind of like putting the power of data analysis into the hands of like everyday users.
Exactly. And that's a good thing, right?
Right.
Because it means that more people can actually benefit from these data-driven insights.
Right.
But it also presents some challenges.
Oh, okay.
We really need to make sure that people are using these tools responsibly and ethically,
Yeah.
and that they have those data literacy skills
Right.
to interpret the results correctly.
Right. It's like giving someone a powerful tool without proper training.
Exactly. Yeah, it could be dangerous. That's why data literacy is so important.
Yeah.
It's really the foundation of effective and ethical data analysis.
Okay.
Another trend we're seeing is this rise of real-time analytics.
Oh, real-time analytics. What's that all about?
So it's about analyzing data as it's being generated rather than waiting for, batch processing.
Okay.
So think about tracking website traffic in real time to see how users are interacting with your content,
Right.
or monitoring social media sentiment to see how people are reacting to your brand.
So it's kind of like having this live dashboard that's constantly updating with the latest data.
Exactly. And this allows businesses to react to changes and opportunities much faster than they could before.
That makes sense.
So, imagine a retailer being able to adjust pricing or inventory levels in real time based on, current demand, or a marketing team being able to tailor their campaigns based on real-time customer feedback.
That's incredible.
Yeah.
It's like having your finger on the pulse of your business, at all times.
It is. And that's just one example of how data analytic thinking is transforming the way businesses operate.
Wow.
But, it's not just about speed.
Okay.
It's about using data to make more informed decisions,
Right.
to automate tasks, and to personalize experiences.
This is making me think about how AI is being used to create chatbots
Yeah.
that can answer customer questions.
Yeah.
Or even provide personalized financial advice.
Right, exactly. AI is playing a really important role in data analytic thinking.
Yeah.
And it's only going to become more prevalent in the future.
Right.
We can expect to see AI being used to automate even more complex tasks.
Okay.
To provide those more personalized insights and to help us make sense of increasingly vast amounts of data.
Yeah, it is exciting.
Yeah.
And to be honest, a little overwhelming. How do we even keep up with all these advancements?
It is a constant learning process.
Yeah.
But the good news is that there are so many resources available, both online and offline.
Okay.
From online courses to industry conferences to, communities of data enthusiasts.
Right. So it's about staying curious and embracing that lifelong learning.
It is. The world of data is constantly evolving.
Right.
And so, too, must our approach to data analytic thinking.
Well said. It's been an incredible journey exploring the world of data analytic thinking with you today. Any final words of wisdom for our listeners?
I think data is a really powerful tool.
Yeah.
That can be used to achieve amazing things.
Right.
But it's up to us to use it wisely, ethically, and responsibly.
I couldn't agree more. To all our listeners out there, embrace the power of data. Hone those data analytic thinking skills and use those skills to make a positive impact on the world. And of course, don't forget to like, share, and subscribe to The Deep Dive for more deep dives into fascinating topics. Until next time, keep exploring, keep learning, and keep thinking critically. Imagine a bank running something like 45,000 tests just to decide if they want to launch a new credit card.
Wow.
That's
a lot.
That's the power of data-driven decisions.
Yeah.
That's what took a company like Capital One straight to the top of their industry.
Yeah.
And that's what we're going to be diving deep on today. Data versus intuition. Especially relevant for everyone working with relational databases.
Absolutely.
And of course, thinking about our listeners in India.
Yeah. It's a really fascinating shift that's happening across all sorts of businesses, going from those gut feelings to decisions that are actually based on evidence.
So let's unpack that a little bit. Why are companies moving away from just going with their gut and making more data-driven decisions? What do you think is going on there?
Well, I think it comes down to a few things. The most important is probably that data gives you evidence.
Evidence.
Right? Instead of just having a hunch or, thinking something's going to work, you have a mountain of receipts to back it up.
So you're not just saying, oh, I think this is going to be popular. You can actually point to something and say, no, look, this is why we think it's going to be popular.
Exactly. And you can test it. You can really see if something works.
Yeah.
So, Capital One didn't just randomly start using data. They actually implemented this whole strategy called test and learn, and they were rigorous about it. They A/B tested every single aspect of their business, everything from their marketing campaigns to credit card offers.
Wow.
And that let them hone in on what was working and what wasn't.
Refine those strategies.
Exactly, based on hard data. And that's ultimately what led to their huge success.
It makes a lot of sense. So it's not just about having a hunch, but about testing that hunch and making sure it actually has some evidence behind it.
Right.
And it's also not just about validating your existing ideas, but it seems like data can actually help uncover new opportunities. things that you might completely miss if you were just relying on intuition.
Oh, for sure. Think about how banks use data now to figure out which customers would really benefit from certain loan products. They're looking at past behavior, and they can actually pinpoint who to target
Yeah.
to make their marketing more effective, increase their sales, lower their acquisition costs, all of that stuff.
Wow.
And that kind of precision is just not possible when you're just going with your gut.
So data gives us evidence. Data helps validate our ideas.
Yeah.
Data helps us uncover opportunities. It really seems like just going with your gut could be a recipe for disaster.
Well, I wouldn't say disaster, but it
Okay,
definitely comes with some risks.
Okay, so maybe not complete disaster, but definitely some serious pitfalls.
Mm-hmm.
Can you give us an example?
Well, one of the biggest risks is that you could miss really crucial insights.
Okay.
So let's say you're running an e-commerce business and you start seeing a lot of returns coming from one particular region.
Okay.
Now, if you don't look at the data, you might just think, oh, this is just, a random thing. It'll sort itself out.
Just a blip.
Yeah. But what if it turns out there's like a quality control issue with a specific batch of products that got shipped to that region?
I see.
You need that data to figure that out.
Yeah, that makes sense.
Yeah.
So the data can almost be like an early warning system
Exactly.
that something's off.
Yeah.
But on the flip side, are there ever times when you think relying too much on the data could backfire?
Oh, absolutely. You can definitely go too far. One common problem is something called overfitting.
Overfitting.
So this is basically when you build a model or you come to a conclusion, but you're basing it on a limited set of data that doesn't actually reflect the real world.
So you're making assumptions based on too small of a sample size.
Exactly.
Oh.
Like, let's say you do a test run of a promotional offer.
Okay.
And let's say everyone in that small test group loves it. But then you roll it out to everybody and it bombs because your initial group wasn't actually representative of your whole customer base.
So data analysis can help us to avoid making those kinds of mistakes.
Yeah, especially when you apply it to larger data sets.
It's like you said earlier, you've got to have those receipts. You've got to have the evidence. So it's not about ditching intuition altogether. It's really about finding that balance between our gut feelings and what the data is actually telling us. How do you think organizations can effectively combine those two approaches?
Well, the key is really to recognize the strengths of each approach.
Okay.
So data gives you those hard facts and figures, right?
Mm-hmm.
But experience gives you context.
Context.
Like an understanding of all those little nuances that data might not be able to capture.
Yeah, that makes sense.
So, for example, imagine you're thinking about launching a new marketing campaign, and the data's telling you this is going to be a home run.
Okay.
But your experience tells you, hold on a second, this might not resonate well with a certain segment of our audience.
Interesting. So experience adds that layer of human understanding that pure data analysis might miss.
Right, because data can tell you what's happening, but it can't always tell you why.
Yeah. So how do we actually do this in a practical way? How do we make sure that the decisions we're making are both data-informed and intuitively sound?
Well, it's a process.
A process.
Yeah, it's about constant refinement. So you start with data analysis to see what the trends are, what opportunities are out there. Then you use your experience and your knowledge to interpret those findings, and then you develop a strategy.
Go.
But it doesn't just stop there.
Right.
You have to constantly monitor the results of your decisions, get feedback, and then use that data to refine your approach even further.
So it's like a constant feedback loop.
Exactly. You're always iterating and improving based on the data.
And for those of us working with relational databases, we're in a really unique position to kind of drive that data-driven culture within our organizations.
100%. You're the ones who are building these systems, managing them, and extracting the insights.
Yeah.
You're the ones turning that raw data into actionable information that can actually make a difference.
So it's not just about understanding SQL queries or database design. It's about using those skills to uncover insights that can really drive change.
Exactly. And that brings us to another really important point. What happens when companies just ignore the data and go with their gut?
Well, it's kind of like navigating a maze blindfolded. You might stumble on the exit eventually, but you're going to hit a lot of dead ends along the way.
For sure. Ignoring the data means you're missing out on all those important clues.
Yeah.
Like imagine overlooking a crucial correlation in your customer data. Like what if there's a sudden spike in complaints coming from a certain region?
Uh-oh.
But you didn't notice it. You could be losing valuable customers without even knowing why.
And relying just on intuition can be so misleading, especially when you're dealing with all the complexity of business these days.
Right. It's like assuming that everyone loves spicy food just because your friends do.
Yeah.
You're basing your understanding on a very limited perspective.
Your own personal experience.
Exactly. And that might not be representative of a larger market or a bigger trend. And that's where data analysis can really help you avoid those kinds of mistakes. That overfitting we talked about, basing your decisions on too small of a sample.
Yeah.
You might think you have this, golden gut feeling based on a couple of successes. But the data can help you see whether that intuition actually holds up in the wider world.
So it's not that experience is useless.
Yeah, no, not at all.
It's about finding that right mix.
Yeah, finding that sweet spot where data and experience can work together.
I like that. So how do we actually do that? How do we find that sweet spot? What should organizations be thinking about?
Well, they need to recognize the strengths of both approaches. Data gives you the hard facts, the evidence, but experience gives you that context, the understanding of the market and all the nuances that might not be obvious from the numbers alone.
It's like data is the engine.
Yeah.
And experience is the driver.
Ooh, I like that.
Who knows how to handle that power?
Exactly.
When to speed up, when to slow down, when to take a detour.
And sometimes, data-driven insights can actually challenge your intuitions.
That sounds interesting.
You might think you know something about your customers.
Yeah.
But the data says, no, you're wrong. Think again.
Or you could find out that your gut feeling was spot on.
Right, exactly. It's like getting a reality check.
Yeah.
But one that's based on solid evidence, not just wishful thinking.
And the great thing is you can use that data to keep refining your process.
Absolutely.
Make your decisions even better over time.
Like adding a pinch of salt to perfect the flavor of a dish?
Yeah, you're always adjusting.
Exactly.
Yeah.
Data helps you fine-tune your approach to get the best possible results.
So it's not just about being data aware.
No.
It's about being data driven.
100%. Making data an integral part of everything you do.
From the big picture strategy all the way down to how you execute.
Right. And that's where listeners who work with relational databases come in.
Yeah, they're on the front lines.
They are. They're building, managing, and extracting those insights from this incredible amount of data.
And those insights can really make a difference.
Absolutely. It's not just about understanding SQL queries.
Yeah.
It's about using that knowledge to uncover the stories within the data.
The stories that can change the way things work.
Exactly.
Yeah.
They can change the way you work, the way your team works, even the direction of your whole organization.
That's powerful stuff. And it brings us back to that question we started with.
Yeah.
What about your data? What stories are hiding in your databases?
Right. What if those stories could change the way you do things?
Maybe there's a better way to reach your customers.
Or optimize your processes?
Or even develop a whole new product.
You never know until you start digging.
So keep asking questions.
Keep experimenting.
Keep diving deep into that data.
You might be surprised by what you find.
I think that's a great place to wrap things up today.
Yeah, it's been a great discussion.
So for all our listeners out there, if you enjoyed this deep dive into data-driven decision-making,
share it with someone you know.
Spread the word.
Maybe someone who's still relying a little too much on their gut.
And of course, don't forget to like, share, and subscribe to The Deep Dive for more insightful conversations just like this one. We'll see you next time. Ever wish you had a crystal ball?
Yeah.
To see the future of your business.
Mm-hmm. Who doesn't?
Well, what if I told you already have something even better?
Better than a crystal ball. I'm intrigued. Tell me more.
Data. We're diving deep today into how to turn everyday business questions, the ones that keep you up at night.
Oh, yeah.
We're going to turn them into powerful data mining tasks.
Okay.
Ones that can unlock hidden insights.
I like the sound of that.
So if you're comfortable with the basics of databases, tables and columns,
right,
get ready to level up your data game.
It all starts with a clear business problem.
Okay.
Let's say you're running a mobile phone company here in India.
Okay, great example. Yeah.
One big question you might have is how can we reduce customer churn?
Yeah, that's a big one. Nobody wants to see people switching to other providers.
Right, exactly.
So how do we take that worry, that churn, and turn it into a data mining task?
Well, it's like translating a problem, from one language to another.
Yeah.
In this case, we're moving from the language of business to the language of data.
Interesting.
So we can rephrase that question as, can we predict which customers are most likely to churn?
Gotcha.
And that is a classic data mining task called classification.
Ah, okay. So we're putting customers into categories, like the ones who are going to stay and the ones who might leave.
Exactly.
But wouldn't it be even more useful to know not just a yes or a no, but how likely they are to churn, like a probability score.
You're absolutely right. A numerical prediction gives you more nuance, right?
Yeah.
Helps you prioritize your efforts. So you might focus your retention strategies on the customers with a high probability of leaving.
Okay, so that's classification. For predicting categories, what are some other common data mining tasks?
Well, imagine you're launching a new data plan.
Okay.
You might wonder, how much will customers be willing to pay?
Yeah, that's a good question.
This calls for regression, which predicts a numerical value. In this case, we're trying to estimate the price point that will attract the most customers.
So it's like using the data to find the sweet spot
Right.
between like affordability for the customer
Yeah,
and profit for the company.
exactly.
Fascinating.
Hey.
Now, I'm also curious about those natural groupings you mentioned earlier. Can you give an example of that?
Sure. Let's say you're running an online marketplace,
Yeah.
like Flipkart or Amazon.
Right.
You might notice that some customers consistently buy electronics.
Yeah.
Others focus on fashion. And yet another group just loves buying groceries.
Right. Different types of shoppers.
This is where clustering comes in.
Okay.
It groups similar data points together based on their characteristics.
So without even telling it, the algorithm can figure out these different shopper personas
Exactly.
just from their buying patterns.
Right.
That's incredible.
And these clusters can then inform marketing campaigns, product recommendations, even inventory management.
All right, so we've got these powerful tasks: classification, regression, and clustering. Is there a way to categorize the types of methods we use in data mining?
There is. One key distinction is between supervised and unsupervised learning.
Okay.
Think of supervised learning like having a teacher guiding you.
Right.
You have labeled data, meaning you already know the outcome you want to predict. And you use that to train the algorithm.
So like in our churn example, we would use data from past customers who either left or stayed
Exactly.
to train the algorithm to predict future churn.
Yes.
Gotcha.
But with unsupervised learning, there's no teacher and no labeled data.
All right.
It's more like exploring a new city without a map.
Oh,
The algorithm is looking for patterns and structures in the data without any preconceived notions.
so it's like letting the data speak for itself and reveal its hidden stories. That's really cool.
Exactly.
So it sounds like choosing the right data mining task and approach is like the first crucial step in solving any business problem.
Absolutely. It's all about understanding the problem, identifying the right tool for the job, and letting the data guide you toward informed decisions.
This is eye-opening stuff. We've barely scratched the surface, though. If you're enjoying this deep dive into data mining, be sure to like and share this episode with your fellow data enthusiasts.
Please do.
And don't forget to subscribe to The Deep Dive for more insightful journeys into the world of data. We'll be back soon with part 2, where we'll explore some specific data mining techniques.
Stay tuned. Welcome back to the deep dive. In the first part, we talked about translating business problems into data mining tasks.
Right.
Now, let's roll up our sleeves and delve into some specific techniques
Okay.
that can help you uncover those valuable insights.
I'm ready. I'm ready to get my hands dirty with some data. Where do we start?
Let's begin with a technique called tree induction.
Okay.
It's a supervised method used for both classification and regression.
Okay.
Imagine a tree with branches that lead to different outcomes based on a series of questions.
Right.
That's essentially how tree induction works.
And so it's like those choose-your-own-adventure books.
Exactly.
Where each choice takes you down a different path.
That's a great analogy.
Yeah.
At each point, the algorithm asks a question about the data. Like, is this customer's monthly usage above a certain threshold?
Yep.
And depending on the answer, it goes down a specific branch.
Gotcha.
Eventually, it reaches a leaf node, which represents the final prediction or classification.
I see. So it's a step-by-step process of narrowing down the possibilities.
Right.
Could you give us a real-world example of how this works here in India?
Absolutely. Let's say you run a lending platform like Lending Cart or Indamoney.
Okay.
You want to assess the creditworthiness of loan applicants?
Yeah.
Tree induction can analyze factors like income, employment history, credit score to predict the likelihood of repayment.
So it's like having a data-driven loan officer.
Yes.
Who can assess risk based on a series of like data-backed questions.
Exactly.
But you mentioned tree induction can also be used for regression. How does that work?
Remember, regression is all about predicting a numerical value.
Right.
Let's say you're a farmer trying to estimate your crop yield for the upcoming season.
Well,
A regression tree can analyze historical weather data, soil conditions, even market prices to predict your potential harvest.
Wow, that's really powerful.
It is.
So tree induction can tackle both classification and regression tasks,
Right.
depending on the type of problem you're trying to solve.
Exactly.
Are there other techniques that are commonly used in data mining?
There are many.
Okay.
Another popular method is logistic regression,
Okay.
a statistical technique specifically for classification problems.
Okay.
Don't let the word regression fool you. It's all about predicting categories, not numbers.
Okay. I'm intrigued. How does logistic regression work?
Right.
And how is it different from tree induction?
Well, imagine you're an e-commerce company trying to personalize product recommendations for your customers.
Okay. Yeah.
Logistic regression can analyze a customer's browsing history, purchase patterns, even their demographic information to predict the probability of them buying a particular product.
Okay.
It then recommends products with the highest probability of purchase.
So it's like a data-driven salesperson
Exactly.
who can anticipate what a customer might want based on their past behavior
Yes.
and preferences.
Yeah.
But how does it differ from tree induction?
While both are used for classification, they approach the problem differently.
Okay.
Tree induction creates a series of decisions based on specific thresholds.
Uh-huh.
Logistic regression, on the other hand, uses a mathematical formula to calculate the probability of belonging to a particular category.
I see. So it's about choosing the right tool for the job
Exactly.
based on the nature of the data and the type of problem you're trying to solve.
And there are many other data mining techniques out there.
Oh, wow.
Some are more complex, like neural networks, which are inspired by the human brain.
Wow.
Others are more specialized, like association rule mining, which helps uncover interesting relationships between different variables in large data sets.
It sounds like there's a whole toolbox of techniques out there waiting to be explored. I'm eager to learn more about these different approaches.
We'll delve into those in our next segment. But for now, if you're finding this deep dive into data mining techniques helpful, don't forget to like and share this episode.
Yes.
And make sure to subscribe to the deep dive for more insightful explorations into the world of data. We'll be back soon to uncover the mysteries of unsupervised learning.
Stay tuned. Welcome back to the deep dive.
Yep.
So far, we've been focused on supervised learning,
Right?
where we have labeled data to, guide our predictions.
Yeah.
But now we're venturing into the world of unsupervised learning,
Yes.
where the data itself reveals its hidden structures.
It's like exploring a jungle
Oh, okay.
without a map, letting the terrain and the wildlife guide your discoveries.
I like that.
We're not telling the algorithms what to look for.
Right.
We're asking them to find those hidden gems within the data.
Sounds exciting. You mentioned clustering as a key unsupervised technique. Can you remind us how that works?
Absolutely. Think of it like sorting a basket of colorful beads
Okay.
without any labels.
Right.
You might group them by color, size, or even the material they're made of.
Uh-huh.
Clustering algorithms do the same with data,
Okay.
grouping similar data points together based on their characteristics.
So it's like a data-driven sorting hatch,
Precisely.
figuring out which group each data point belongs to.
And one of the most popular clustering algorithms is k-means clustering.
Okay.
You specify the number of clusters you want, the k in k-means,
Right.
and the algorithm tries to find the best way to divide the data into those groups.
Okay, so we tell it how many groups we want, and it figures out how to divide the data
Exactly.
based on similarities.
Yes.
What are some real-world examples of how this works in India?
Imagine your streaming service, like Hotstar or GeoCinema.
Yeah.
You want to recommend movies and shows that your users will love.
Right.
K-means clustering can analyze viewing patterns, genre preferences, even user ratings
Okay.
to group similar viewers together.
Got it.
Then you can recommend content that's popular within each cluster.
It's like creating personalized channels for different types of viewers.
Exactly.
Without them even having to, lift a finger. Brilliant. Are there other applications of clustering in different industries?
Oh, definitely. Let's say you're a retail chain with stores all over India.
Okay.
You can use clustering to analyze sales data, customer demographics, even location-specific factors to identify different types of stores. This can help optimize inventory, tailor marketing campaigns, even decide where to open new locations.
So clustering can help businesses understand their customers.
Yes.
their products, and even their operational landscape.
Exactly.
It's like having a data-powered magnifying glass
Yeah.
to see the finer details of your business.
And the best part is clustering is just one of many unsupervised learning techniques.
Oh, wow.
There are others like dimensionality reduction,
Okay.
which simplifies complex data, and anomaly detection,
Right.
which helps identify unusual patterns that might indicate fraud or system errors.
This deep dive into data mining has been truly eye-opening.
Mm.
We explored how to translate those business problems into data mining tasks. We've learned about supervised and unsupervised learning techniques, and we've seen how these approaches are being used across diverse industries in India and beyond.
It's been a pleasure unraveling these data mysteries with you.
Likewise.
Remember, data is a powerful resource waiting to be explored.
Absolutely.
And by understanding these data mining techniques, you can unlock valuable insights. Insights that drive better decisions and propel your business forward.
If you enjoyed this deep dive into the world of data mining, be sure to like and share this episode with your fellow data enthusiasts. And don't forget to subscribe to The Deep Dive for more insightful explorations into the world of data. Until next time, keep exploring and keep learning.
Welcome back, everyone, to The Deep Dive. This time, we're going deep into data science.
Sounds exciting.
It is. Now, we know you guys are familiar with relational databases already,
Of course.
but today, we're going way beyond that.
Okay, I'm ready.
We'll be looking at how to uncover those hidden patterns in data. And we'll discover how businesses use historical data to make predictions.
Powerful stuff.
It is. And then we'll demystify lift.
You lift.
Yeah, we'll get to that.
Sounds good.
All of this with a special focus on the Indian business landscape.
Okay, let's get started.
All right, first up, what is pattern discovery in data science? I feel like there's got to be more to it than just what it sounds like.
Well, you can think of it like being a data detective, right?
Yeah, I like that.
You're digging through all this information,
Right.
not to, solve crimes or anything,
Right.
but to find those hidden relationships and trends in data sets.
So we're talking about more than just simple correlations, right?
Exactly. It's not just about seeing what things happen together.
Gotcha.
Pattern discovery is about going deeper.
So understanding the why.
Yes, exactly. Why are these patterns happening?
Okay. So it's kind of like when Netflix recommends something totally unexpected but somehow makes sense.
Yeah. It's like that, but for business.
Uh-huh.
Like, say, a telecom company here in India wants to figure out why they keep losing customers.
Okay, yeah. That's a real problem.
Right. Pattern discovery might show that, users with a certain data plan are more likely to switch providers.
Oh, interesting.
Or maybe those who call customer service a lot.
Huh.
These patterns can give you some real actionable insights.
Makes sense. And it's not just about holding on to customers, though, is it?
No, not at all. Think about, say, Flipkart, an e-commerce giant.
Yeah.
They could use pattern discovery to predict, how demand for certain products might change.
So they can manage their inventory better.
Exactly.
Right.
Or imagine financial institutions.
Right.
They can use it to stop fraud, catch those transactions that just seem off.
Wow. It's like having a sixth sense for your business. It is. So businesses are using this to understand all sorts of things.
Definitely.
But how do they actually use historical data to make predictions?
Well, it's all about learning from experience.
Okay.
Just like, we learned that dark clouds probably mean rain.
Right.
Businesses use historical data to make these predictive models.
Oh, okay. Interesting.
It's like they feed tons of data into these algorithms, and then the algorithms learn.
So they learn to see patterns.
Yes. And then use those patterns to forecast what might happen in the future.
It's like teaching a computer to see the future.
In a way, yeah. Like Capital One, the credit card company in the U.S.,
Right.
they totally changed their business with a data-driven strategy.
Oh, how so?
They used historical data to target customers with these personalized offers.
Smart.
Yeah, and it was a game changer for them.
So they're not actually seeing the future, but they're getting pretty close.
Pretty close, yeah.
Now, what about those specific techniques they use? Like, I've heard of things like regression and classification.
Right. So regression is all about predicting a continuous variable.
Like a specific number.
Yeah. Like how much revenue a company might make next quarter.
Okay.
Or think of an e-commerce company in India, right?
Yeah.
They could predict their sales based on website traffic and marketing spend. That's regression.
Got it. So it's all about the numbers. What about classification?
Classification is about categorizing data.
Okay.
So a bank could use it to predict, which loan applicants are high risk.
Ah, based on their past financial history.
Exactly.
So it seems like any business in any industry here in India could use their historical data to make some powerful predictions.
Absolutely.
Forecasting sales, understanding customers,
Yeah.
even predicting those market trends.
Exactly.
It's pretty amazing.
It is. And honestly, we're just scratching the surface here.
Oh, really?
As we get more data and our tech gets even better, the possibilities are only going to grow.
This is getting super interesting. But before we get too ahead of ourselves, let's talk about this thing called lift. It's not about weightlifting, is it?
Uh-huh. No.
So what does it mean in the world of data?
Well, it basically measures how much more likely two things are to happen together than you'd expect just by chance.
So it's about finding connections that aren't just random.
Yeah. It's about finding those meaningful connections.
Okay, give me an example.
All right. Imagine a supermarket, right?
Yeah.
They look at their data and find that people who buy diapers also tend to buy beer.
Wait, really? Diapers and beer, what's the connection there?
That's where Lich comes in.
Uh-huh.
It helps figure out if that connection is actually meaningful or just a coincidence.
Okay.
In this case, the lift would probably be pretty high.
So there's actually something there. It's not just random.
Right.
Fascinating.
Right.
But how does understanding lift actually help businesses?
It helps them focus on the patterns that matter.
Oh.
By understanding lift, they can avoid those misleading correlations and focus on the ones with real business value.
I see.
Let's go back to Flipkart, for example.
Right.
Let's say they see that customers who buy a certain phone also often buy a specific screen protector.
Okay.
That pattern likely has high lift, and they can leverage that.
So it's like a data magnifying glass.
Yes. You're zooming in on those most impactful patterns.
It seems like lift is really important to make sure those insights are actually valuable,
Absolutely.
especially for marketing and sales, right?
You got it. It's crucial for things like marketing. Lift can actually tell you how well a campaign is doing.
Oh, really?
Yeah. Like if you're targeting a specific group of customers with an ad,
Uh,
Lift can tell you how much more likely they are to respond to it compared to, just a random group.
okay, so lift helps separate the real deal from those misleading correlations.
Exactly. It's like filtering out the noise.
So you can really see what's driving results.
Excellent.
It's amazing. We've covered pattern discovery, predictions using historical data, and this fascinating lift. This deep dive has been incredible so far,
It has.
and we're just getting started.
There's so much more to explore.
We'll be back in a flash to delve deeper into the world of data science. Stick around.
We're back and ready to dive even deeper into data science. We've talked about how businesses use historical data to make predictions,
Uh-huh.
but now let's add in another layer.
Okay, what's that?
Probability.
Probability. Oh boy, that takes me back to math class.
Haha, don't worry. We won't be doing any equations here.
Okay, good.
Just think of probability as a way to measure uncertainty.
Uncertainty. Okay.
It helps us answer the question, given what we know, how likely is something to happen?
So instead of saying something will happen, we're saying how likely it is.
Exactly. It's more nuanced.
Which makes sense because the business world is complex.
It is, and that nuance is super valuable for businesses.
Okay.
Instead of just saying a customer will or won't churn,
Right.
we can use probability to say this customer has a 60% chance of churning.
So it's like a risk assessment, but based on data.
Yeah, exactly.
Pretty cool. Right.
It is. But how do we actually calculate those probabilities?
Well, that's where some key concepts come in, like Bayes' rule.
Bayes' rule. I've heard of that.
It's basically a way to update our beliefs about something as we get new evidence.
Okay, break that down for me.
Imagine you're a doctor, right?
Okay.
You have an idea what's wrong with your patient based on their symptoms.
Uh-huh.
But you also order some tests,
To get more information.
right? Bayes' rule lets you combine those test results with what you already know.
So you can make a more accurate diagnosis.
Exactly.
So it's like, a detective gathering clues and refining their theory.
Yes. Perfect analogy. And in data science, we use Bayes' rule to keep refining our predictions.
As we get more data.
Exactly. It's all about adapting, learning. Okay, I'm starting to get it. Now, we keep talking about these models. What exactly is a model in this context?
A model is like a simplified representation of something complex.
Okay.
It captures the key relationships in the data.
Helps us make sense of it all.
Yes, it's not an exact replica of reality, but it helps us understand the most important parts.
Okay.
And just like there are different types of maps,
Uh-huh.
there are different types of models.
So some are better for predicting the future.
Right. And others are better for understanding relationships within the data.
So choosing the right model is important.
Absolutely. It's not one size fits all.
Gotcha.
Some popular ones are decision trees, support vector machines, neural networks.
Wow. Getting pretty technical here.
Yeah, it can get complex, but each model has its pros and cons.
So we have data, we use probability to make predictions, and we build these models to help us understand it all.
That's the gist of it.
It's a pretty powerful combination.
It is. And as we keep exploring data science, we'll see even more exciting stuff.
Can't wait.
But the stuff we've talked about today, these are the core principles.
The foundation.
Exactly.
This has been awesome. We've talked about probability, Bayes' rule, and choosing the right model.
A lot of ground covered.
It has.
Aye.
But hold on tight, because we're going to explore an even more powerful concept next. And we're back, ready for the final part of our data science deep dive.
Let's do it.
We've covered some pretty complex stuff already, but I have a feeling there's more to come.
There is. We've talked about these individual models, right?
Uh-huh.
But in the real world, data scientists, they often combine these models.
Oh, okay. Why would they do that?
They get even better results.
Makes sense.
That's where ensembles come in.
Ensembles, what are those?
Think of it like a super group of models.
A supergroup, like a band.
Yeah, like a band of models all working together.
To make predictions.
Exactly. It's like having a team of experts, right?
Well, okay, I like that analogy.
Each with their own perspective.
So instead of one model trying to do it all,
Right.
we have a whole team collaborating.
Yeah.
I bet that leads to some really cool insights.
It does.
So how does this work in practice? Do all the models have equal weight?
Well, there are different ways to combine their predictions.
Okay.
Sometimes they kind of vote.
They vote on the most likely outcome.
Exactly. Sometimes we average their predictions.
Okay.
And sometimes we give more weight to certain models that, have been more accurate in the past.
So some models are more trusted than others.
You could say that.
It's like a democratic system for data.
Uh-huh. Yeah.
And I'm guessing this whole ensemble approach makes predictions more accurate overall.
You got it. It often reduces the risk of overfitting.
Overfitting.
That's when a model focuses too much on the specific data it was trained on.
Oh, okay.
So it doesn't work as well with new data.
You can't generalize.
Right. Ensembles help with that. They create models that are more, robust.
More reliable.
Exactly.
So this is like the Avengers of data science, assembling to solve the toughest problems.
I love it.
But with all this talk about models and ensembles, it's easy to forget about the real world.
Yeah, you're right.
How are these techniques being used to solve real business problems?
Well, data science is transforming industries all over the globe, and India is no exception.
Okay.
From those personalized recommendations you see on Flipkart and Amazon
Uh-huh.
to those fraud detection systems used by banks. The
Right.
applications are everywhere.
So we touched on this before, but let's say you're a big retail company here in India.
Okay, yeah.
How could you use these data science techniques?
Oh, so many ways. You could analyze what customers are buying.
To see what they might buy next.
Yes. To identify cross-selling opportunities.
Smart.
You could create those targeted promotions.
Based on what?
Their preferences, their buying patterns.
Right.
You could even personalize the whole shopping experience.
Wow.
From product suggestions to discounts.
So you're giving customers what they want before they even know they want it.
Pretty much. And it goes beyond just customers, too.
What else can it do?
Data science can help streamline operations like logistics.
Sure.
It can even predict equipment failures.
So you could fix them before they become a problem.
Exactly.
This deep dive has been incredible. We've explored so much.
We have.
From pattern discovery to predictive models.
Ensembles, real-world applications.
It's clear that data science is a game changer.
It is.
And the businesses that embrace it are going to be the ones who succeed.
Definitely.
It's been a pleasure exploring all this with you.
Likewise.
And to our amazing listeners, thank you for joining us on this deep dive. We hope you've learned a lot, and maybe you've even developed a new appreciation for the power of data science.
Hopefully.
If you enjoyed this episode, don't forget to like, share, and subscribe.
Spread the knowledge.
We'll be back with more fascinating deep dives in the future. Until then, keep exploring, keep learning, and keep those data-driven questions coming. Welcome to our deep dive all about machine learning. Specifically, we'll be focusing on supervised and unsupervised learning. Now, you guys already know your way around relational databases, so you have a great foundation for getting this. So let's get right to it. What makes these two approaches so different?
It really all comes down to one thing: labeled data. With supervised learning, we're basically giving the algorithm data that's already labeled. Think of it like giving it a bunch of examples, but with all the right answers already there. The algorithm then, well, it learns to see the patterns and connections between what the data looks like and what those labels are.
So it's like teaching a kid, like a small child, to name different fruits. You point at an apple and say apple, then you show them an orange and say orange.
Exactly. The kid learns to connect how the fruit looks with its name. Just like that, in supervised learning, the algorithm uses those labeled examples to learn how to guess the right label, even for new data it's never seen before.
That makes a lot of sense. So like if a business wanted to predict which customers are going to cancel their subscription, we usually call this churn, they could use supervised learning for that, right?
Definitely. They would give the algorithm all their past data on customers, including, both the ones who left and the ones who stayed. And from that, the algorithm would try to figure out what are the patterns, the things that best predict if someone's going to churn or not.
So things like how often they're using the service, how long they've been a customer, maybe even if they've contacted customer service a bunch recently, stuff like that.
Exactly. And once it's learned from all that data, it can then try to predict the chances of churning, but this time for the current customers they have.
Okay, interesting. So that's supervised learning. Now, how does unsupervised learning fit into all of this? It doesn't use labels, right?
Right, no labels. With unsupervised learning, we're basically giving the algorithm a bunch of data, but this time without telling it the answers beforehand. So its job now is to just explore that data, try to find any hidden structures, patterns, or relationships in it. Imagine giving a kid a basket of different fruits, but without telling them what each fruit is, and then asking the kid to group similar fruits together.
Got it. So instead of trying to predict a specific outcome, based on examples with answers, it's more about finding the natural groupings or clusters within the data itself.
Yeah, that's it. It's all about exploring and discovering what's in the data.
Okay, can you give us a business example where unsupervised learning is really useful?
Sure, let's say you have an online store, like an online retailer, and they want to understand their customer base better. They could use this unsupervised learning to, segment their customers into different groups based on how they buy things. So, for example, the algorithm might find a group of customers who always buy electronics, another group who mostly buy clothes, and then another one that's all about home goods.
So even though the store didn't tell the algorithm to create those specific categories, it figured them out on its own, just by looking at the buying patterns.
Right. That's what's so powerful about unsupervised learning. It can show you hidden insights and structures that you might not have even thought to look for.
Okay, this is fascinating. So the main difference is whether you're asking the algorithm to predict something specific using labeled examples, which is supervised learning, or to find hidden patterns and structures in data without labels, which is unsupervised learning.
Exactly. And each approach is good for different kinds of problems, which we'll get into next.
Okay, it's all starting to come together now. Let's move on to those different types of business problems. Like, what kind of situations would you use supervised learning for?
Well, anytime you're trying to predict something using past data, supervised learning is a great tool to use, like we talked about earlier, predicting if a customer is going to cancel their subscription.
Right, using those patterns to spot the customers who might be thinking about leaving.
Yeah, but it's not just limited to that. You could use it to predict things like, will someone applying for a loan pay it back or not? Is a transaction fraudulent? Even things like what the price of a certain stock might be tomorrow.
So you're using historical data to build a model that can forecast, predict what's going to happen in the future.
That's the main idea. And the great thing about supervised learning is that it can also help you understand why those outcomes are happening, like what's driving those predictions.
Oh, I see. So it's not just telling you, will this happen, but also, why might this happen?
Yep, exactly. For instance, in the loan example, the model could tell you that a person's credit score, how much money they make, and their job history are the most important things to look at when predicting loan defaults. That kind of information is super valuable for, making better decisions when giving out loans.
Okay, so supervised learning is all about making predictions and understanding what's behind them. What about unsupervised learning then? What types of problems is it really good at solving?
Unsupervised learning is best when you're trying to uncover hidden patterns and structures in your data. It's like a powerful exploration tool. And it's great for things like customer segmentation. Remember, we talked about that earlier with the online retailer example.
Right, grouping customers based on how they buy things without telling the algorithm what those groups should be beforehand.
Exactly. But you can use it to group all sorts of things, not just customers. For instance, let's say in healthcare, they could use unsupervised learning to identify different subtypes of diseases based on, symptoms and medical records of patients.
Wow, that's really powerful. Are there any other business problems where unsupervised learning can give us valuable insights?
For sure. Another popular use is what we call market basket analysis.
Okay, I've heard of that, but I've never really understood it. Can you explain it a bit more and how unsupervised learning comes in?
Imagine a supermarket looking at all its sales data. Unsupervised learning can help them discover interesting relationships between items that are often bought together. Like, for example, they might find out that customers who buy diapers also tend to buy beer.
Wait, diapers and beer. That's a strange combination.
It is, right. But this seemingly weird pairing is actually a classic example of what market basket analysis can find. It shows how unsupervised learning can reveal these unexpected patterns that you wouldn't notice just by looking at the data.
So understanding these hidden connections can help the supermarket arrange their products better, create targeted promotions, and ultimately sell more.
Exactly. Unsupervised learning helps them see those connections and make smarter decisions for their business.
This is really starting to make sense.
Yeah.
So supervised learning is about predictions and the factors behind them, and unsupervised learning is about uncovering hidden patterns in the data.
Precisely. And each one is suited for different kinds of problems, which we'll dive deeper into next.
Okay, I'm ready for that. So let's move on to some real-world applications of all this.
Sounds good. Let's explore some fascinating examples of how these techniques are being used right now. Let's kick things off with a real-world application of supervised learning that I'm sure everyone here can relate to, spam filtering.
Oh yeah, spam filtering, that's definitely something we deal with every single day. So how does supervised learning actually help keep all those annoying spam emails out of our inbox?
Well, think of it this way. You're basically training an algorithm to spot spam. You give this algorithm a huge data set of emails, but they've already been labeled, marked as either spam or not spam.
So basically, the algorithm learns from those examples, those labeled emails, to figure out what makes a spam email a spam email.
Exactly. It might notice that spam emails often use certain words, like free or guaranteed, or it might pick up that they come from weird email addresses.
And then using all that, it can flag incoming emails and say, hey, this looks like spam, and keep them out of our inbox.
Exactly. That's the beauty of supervised learning in action. It's always learning, always getting better at spotting spam based on the data you feed it.
That's super cool. Now, switching gears to unsupervised learning, you mentioned customer segmentation earlier. Can you walk us through a real-world example of how that works?
Of course. Let's say we have a music streaming service, like a Spotify. They have millions of users, and all these users have different tastes in music, different listening habits.
Right. So how do they use unsupervised learning to make sense of all that data, all those different preferences?
They can use something called clustering. It's an algorithm that groups users together based on how similar their listening patterns are. So you might end up with one cluster of users who mostly listen to pop music, another group that's all about rock, and another one for, say, classical music fans.
I see. And once they have these groups, what do they actually do with them?
That's where it gets really interesting. They can use that information to give each user a more personalized experience. For example, recommending new artists or playlists that fit their specific cluster. They can even target those groups with special promotions or ads that are more likely to resonate with them.
So it's all about using those hidden groupings to make things more engaging, more relevant for each user.
Exactly. And that's just one way unsupervised learning is being used. You see it all over, personalizing all kinds of services and products in tons of different industries.
It's amazing to see all these different ways it's being applied. I'm still thinking about that market basket analysis you mentioned before, the diapers and beer example.
Yeah.
That was pretty surprising. Do you have another real-world example of how that technique is being used?
Of course. Let's picture an online clothing retailer. They could use market basket analysis to, figure out if customers who buy a certain dress also often buy a matching handbag.
Oh, I see. So they're not just buying the dress, they're buying the whole look.
Precisely. And this is valuable information for the retailer, right? They can then use that knowledge to recommend those handbags to people who are looking at that dress, or they could bundle the dress and handbag together in a promotion. Heck, they might even rearrange their store layout to put those items closer to each other.
That's pretty clever. By understanding those buying patterns, they can boost their sales and also make the shopping experience better for their customers.
Exactly. Market basket analysis is all about finding those hidden associations that lead to smarter business decisions and happier customers.
This is seriously eye-opening. I'm starting to see the real power of both supervised and unsupervised learning.
It's fascinating stuff, for sure. And we've only scratched the surface here. There are so many more applications out there.
Well, before we move on, I'm curious about something you mentioned before, fraud detection. You talked about it briefly, but can you tell us a bit more about how supervised learning is used to, like, fight fraud?
Definitely. Fraud detection is a super important use of supervised learning, especially in areas like finance and e-commerce. Let's imagine a credit card company. They want to be able to catch fraudulent transactions as they're happening in real time.
That sounds really challenging. How does supervised learning help them do that?
Well, they start by training a model on a ton of data from past transactions. Each of those transactions would be labeled as either fraudulent or legitimate. And what the model does is it learns from that data to pick up on the patterns, the red flags, that might point to a fraudulent transaction.
So what kind of patterns would it be looking for?
Anything that seems out of the ordinary, like maybe a sudden huge increase in spending or transactions happening in a location that doesn't make sense for that customer, or even a bunch of transactions happening super quickly from different stores.
So it's basically learning to recognize suspicious behavior based on what it's seen in past cases of fraud.
You got it. And once it's been trained, it can analyze new transactions as they come in. And if it sees any of those red flags, it can raise an alert right away.
That's incredible. It's like having a super smart detective constantly on the lookout for any signs of fraud.
That's a great analogy. And that ability to detect fraud in real time is super important for, protecting businesses and customers from losing money.
This has been such a fascinating look at how supervised and unsupervised learning are being used in the real world. It's amazing how they're solving all sorts of different problems across so many different industries.
It really is. And the coolest part is it's still early days. We're just starting to tap into the potential of these techniques. And, the really exciting part is that this whole field is still evolving so rapidly. There are so many amazing advances happening all the time in both supervised and unsupervised learning.
That's what makes the tech world so fascinating, right? It just keeps pushing boundaries, always something new to discover. So what are some of those cutting-edge trends that have you excited these days?
Well, one area that's just exploding right now is deep learning. It's like a specialized area within machine learning where you use these artificial neural networks and they have all these different layers to learn really complex patterns from massive amounts of data.
Deep learning, neural networks, those sound intense. Can you break that down for us? Explain it in a way that's easier to grasp.
Sure, think of it this way. You know how the human brain has all these interconnected neurons? Well, deep learning models are kind of inspired by that. They're made up of layers, and these layers are full of interconnected nodes that process and pass information back and forth.
So it's like trying to mimic the way our brains learn, basically.
In a sense, yeah. And because of that, these deep learning models can learn really, really complex patterns from all kinds of data images, text, even audio.
Wow, that's impressive. So how does deep learning actually fit into all this with supervised and unsupervised learning?
So in supervised learning, deep learning is what's powering things like self-driving cars, for example. The models learn to recognize objects, understand the road conditions, even make decisions about how to drive. And then in unsupervised learning, you see it being used for stuff like generating super realistic images and videos, or even composing music.
That's mind-blowing. Sounds like something straight out of science fiction. Any other big trends on the horizon that we should keep an eye on?
Definitely. One really important one is the push for explainable AI, which is also called XAI. See, the problem is, as these machine learning models get more and more complex, it becomes harder to understand how they're actually making their decisions.
Right, and that makes sense, especially when you're using these models for really important things like healthcare or finance.
Yeah.
You got to be able to trust the decisions they're making, right?
Exactly. That's where XAI comes in. It's all about finding ways to make the so-called black box models more transparent, more interpretable.
So it's not just about getting the right answer, but also about understanding why the model gave that answer.
Exactly. We need to be able to look inside and understand the reasoning behind those predictions. That's crucial if we want to trust these models and make sure they're being used responsibly.
Makes sense. It sounds like we're heading towards a future where AI is not only super powerful, but also more understandable, something we can actually trust.
Absolutely. And with all these advances in deep learning and XAI, it's just going to open up even more possibilities for both supervised and unsupervised learning. I think we're going to see some really incredible and impactful applications in the years to come.
This has been such a great deep dive into the world of machine learning. We've covered so much, from the basics of supervised and unsupervised learning to all those real-world examples and even what the future might hold. I feel like I have a way better understanding now.
It's been awesome exploring all this with you. It's always exciting to talk about machine learning and the potential it has to solve complex problems, really shape the future.
And a huge thank you to you for sharing your expertise with us. It's been incredibly insightful. And all our listeners out there, if you found this deep dive valuable, don't forget to like, share, and subscribe to our channel for more explorations just like this one. Until next time. All right, so today we're taking a deep dive into the world of predictive analytics.
Sounds exciting.
It is.
Yeah.
So you already know your way around a database, right?
Yeah. I mean,
Yeah.
That's the foundation.
It is. But now we're talking about using that data to predict the future.
Right.
It's kind of like,
Mind reading.
it is, but like a...
Almost
Here.
for businesses, right?
Exactly. It's like having a crystal ball, but instead of magic, we're using data.
I like that.
Yeah.
So let's say a business wants to know, which customers are about to jump ship or which products will be a hit.
Right.
How do they even begin to do that?
Well, it all starts with something called predictive modeling.
Okay.
So we take historical data, we find those hidden patterns and trends, and then we use that information to make educated guesses about what might happen in the future.
So it's basically teaching a computer to read tea leaves. But instead of tea leaves, it's sales figures and customer data. Exactly. Yeah. It's like you're giving the computer all this information about the past, and then you're saying, hey, based on this, what do you think's going to happen next?
Okay, that makes sense, but let's break it down a little further.
Okay.
What are the key ingredients that make this prediction thing actually work?
Sure. So one of the most important things is to find what we call informative attributes.
Informative attributes.
Yes. And these are basically pieces of data that are strongly connected to whatever it is that we're trying to predict.
Okay, so give me an example, something relatable.
Sure. Let's say a mobile phone company wants to predict which customers might switch to another provider.
Okay, yeah.
Now, some obvious attributes might be things like the cost of their current plan or how often they call customer service with complaints.
Right.
But, a really informative attribute might be something like how often they use their phone's hotspot feature.
Interesting.
Yeah, because if they're constantly using their hotspot, it might mean that they're not happy with their data plan and they're looking for more data. So it's like those little clues, those little hints.
Exactly.
That can reveal a bigger picture.
Yeah, you got to dig a little deeper sometimes to find those really insightful patterns.
I like that.
Yeah.
So the more we can pinpoint these really, informative attributes, the more accurate our predictions become.
Exactly. And that's where the magic really happens, is using that knowledge to make better decisions for your business.
So how are companies actually putting this into action?
Oh, in so many ways.
Give me some examples.
Let's start with marketing.
Okay.
Imagine being able to personalize your marketing messages for each customer based on their predicted behavior.
Okay.
That's the power of predictive analytics in marketing.
So instead of sending out those generic mass emails,
Right.
you can actually tailor your messages to each person.
Exactly. You can personalize your offers, recommend products that they're actually interested in, and even figure out the best time to reach them.
So it's like you're having a one-on-one conversation
Yeah.
with each customer instead of just shouting from the rooftops.
Exactly. That's much more effective.
It is.
Now, but it's not just about marketing, right?
Oh, no.
Predictive analytics is changing the way businesses operate behind the scenes as well.
Absolutely.
So let's talk about operations.
Yeah. So in operations, imagine being able to predict the demand for your products.
Okay.
Or, optimize your inventory levels to make sure you don't have too much or too little stock.
That sounds like a dream for any business owner.
It is, especially, in a fast-paced market like India.
Yeah, where things are constantly changing.
Exactly. So by analyzing their past data, businesses can get ahead of the curve. They can make sure they have the right products available at the right time.
Which means happier customers.
Of course.
And a healthier bottom line.
Exactly.
So we've established that predictive analytics is pretty amazing.
It is.
But how are these predictions actually made?
Right.
What are some of the techniques that data scientists use to pull this off?
So there are a whole bunch of different techniques. each with their own pros and cons.
Lay it on me.
Lay it on me. Okay, so let's start with one that's easy to visualize.
Okay.
It's called tree induction.
Tree induction.
Yeah. So imagine like a decision tree.
Okay.
Like a flow chart.
Okay.
Each branch represents a different attribute, and then each leaf represents a possible outcome.
Okay, so sticking with the telecom example,
Sure.
a branch could be like data usage,
Uh-huh.
and then the leaves could be like high usage, moderate usage, low usage.
Exactly. And then you can see, which paths on that tree lead to the outcome you're interested in, like customer churn.
Okay, that's pretty straightforward.
Yeah, it's a really visual way to see how different factors can influence the prediction.
I like that. But what about when things get a little more complex?
Yeah.
You can't always simplify everything into a neat little flowchart.
True. That's where regression analysis comes in.
Regression analysis.
Yeah. So this one uses mathematical formulas to find relationships between different variables.
Okay, so give me an example of that.
Sure. Think about trying to predict a cricket team's score.
Okay.
Based on factors like the batsman's form, or the pitch conditions, or the weather even.
Okay.
So regression analysis helps us understand, how much each of these factors contributes to the final score.
So it's like finding a mathematical equation
Right.
that best describes that relationship
Exactly.
between all those different factors
Yeah.
and the outcome.
And there are different types of regression, linear regression, logistic regression, all sorts of fancy names.
Fancy.
Yeah. But basically, they all help us understand how different variables relate to each other.
Okay, that sounds really powerful, but also pretty complex.
It can be.
Is there a technique that's a bit more intuitive?
Absolutely. Yeah, there's one called nearest neighbor reasoning.
Nearest neighbor reasoning.
Yeah, so imagine you're trying to predict whether a new restaurant in your neighborhood is going to be successful.
Okay, I like this example.
Yeah, so with nearest neighbor reasoning, we look at similar restaurants that have already opened, maybe in your city or other similar neighborhoods.
Okay.
And we'd consider things like the type of cuisine, the price point, the location, and see how those restaurants did.
Right.
If those similar restaurants were successful, then there's a good chance that this new one will be too.
So it's kind of like judging a book by its cover.
Uh-huh.
But instead of the cover,
Right.
we're looking at similar books that have already been read.
Exactly. It's all about finding patterns in past data to help us make better guesses about the future.
I like that. So we've got these different techniques.
Yeah.
Tree induction, regression analysis,
Yeah,
nearest neighbor reasoning.
it's a whole toolkit.
It is.
Yeah.
Data science is fascinating.
It is. It's amazing what you can do with data these days.
It really is. And it's clear that, data scientists are using all these different tools and techniques
Yeah.
to uncover these hidden insights and make predictions about the future.
And the key is to choose the right tool for the job. Some techniques work better for certain types of problems than others.
Makes sense. So we've explored all these powerful techniques, but at the end of the day, it's not just about the technical wizardry, right?
Right. It's about using these insights to actually make real-world decisions.
Yeah. So how does a company actually translate these predictions into action?
Well, think about it this way. One of the biggest advantages of predictive analytics is the ability to personalize customer experiences.
Okay. How so?
So by understanding individual preferences and behaviors, businesses can tailor their products and their services and even their marketing messages to create a more engaging and satisfying experience for each customer.
So it's all about moving away from that one-size-fits-all approach.
Exactly. It's about creating a more personalized and customer-centric model.
Yeah. And that makes a lot of sense, especially in a diverse market like India.
Absolutely. And, predictive analytics can also help businesses identify potential risks and opportunities.
Give me an example.
Sure. So by analyzing market trends and competitor data, businesses can anticipate changes in demand.
Yeah.
They can identify emerging markets or even spot potential disruptions before they occur.
So it's not just about reacting to what's already happened. It's about proactively shaping the future.
Exactly. It's about making informed decisions based on data-driven insights. And this proactive approach is becoming increasingly important in today's rapidly changing business environment.
Yeah, companies that embrace predictive analytics are going to be more agile, more adaptable, and more resilient in the face of uncertainty.
Exactly.
This has been an incredible deep dive into the world of predictive analytics.
It has.
We've learned how businesses can use data to forecast the future, streamline their operations, and make smarter decisions across the board.
And as we wrap up, it's clear that predictive analytics isn't just a buzzword. It's a game changer for businesses of all sizes.
Absolutely.
As data becomes more abundant and technology continues to advance, the possibilities are truly limitless.
So to our listeners, if you're looking to gain a competitive edge and make smarter decisions, predictive analytics is definitely worth exploring.
I agree.
And don't forget to like, share, and subscribe to The Deep Dive for more insightful explorations into the world of data and technology. Welcome back to The Deep Dive. You know, we love to dig into topics that help you really squeeze every drop of insight out of your data. And today we're going to focus on something that's especially relevant for folks who live and breathe relational databases. If that's you, you're in the right place. We know there are tons of you over in India who fit that bill. So let's talk predictive modeling and feature selection. These are powerful techniques that can give you a real advantage.
You know, it's amazing how much predictive modeling has taken off in the business world. It's everywhere. Basically, we're using data to make predictions about the future, predicting things like customer churn, trying to forecast sales or assess risk. All these things can be tackled with predictive modeling.
So like we've got a crystal ball, but instead of magic, we're using data and algorithms. It's like core data science work, right? What makes it so central?
Absolutely. Predictive modeling is the heart and soul of data science because it helps businesses go beyond just understanding the past. They can actually anticipate what's coming next, and that lets them make smarter decisions based on real data.
Right, so it's about being proactive instead of reactive. I like that. Okay, so let's say we've got this massive database packed with information about our customers. Where do we even start? How do we figure out which pieces of data are actually the important ones for making those predictions?
Well, that's where feature selection steps in. It's kind of like being a detective, you know? But instead of a crime scene, you're sifting through this mountain of data, looking for those key attributes that'll give you the most accurate predictions. You don't need every single bit of information, just the stuff that really moves the needle.
Yeah, finding the signal in all the noise. That makes a lot of sense. Not only would it make our models more accurate, but also more efficient. No wasted time or resources on data that doesn't really matter. But how do we actually find those golden nuggets?
There are a few techniques out there, and one of the most powerful is information gain. It's a way to measure how much information a particular attribute gives us about the target variable we're trying to predict.
Okay, can you give me an example? Let's stick with that customer churn thing we were talking about. How would this information gain idea help us there?
Sure. So imagine one attribute in your database is how often a customer buys something on average, their purchase frequency. Now, if you look at the data and see that customers who buy more frequently are a lot less likely to churn, then boom, average purchase frequency would have high information gain.
So it's like finding a key piece of the puzzle. That attribute gives us valuable insight into why some customers stick around and others don't. But what if we have several attributes that seem important? How do we choose?
Well, information gain helps us rank those attributes based on how informative they are. It's like creating a hierarchy of clues. The ones with the highest information gain go straight to the top.
So we're basically using information gain to prioritize, focusing on the attributes that are most likely to give us accurate predictions. It's starting to feel like a really strategic process. Now, one of the things you mentioned was tree induction. How does that fit in here?
Tree induction is a really cool technique. It's great for creating models that are both accurate and easy to understand. It basically splits the data into smaller and smaller subsets based on the values of different features.
Okay, so I'm picturing this like a family tree, but instead of people, we've got segments of customers. Each branch represents a different predicted probability of churn.
You're getting it. Each split in the tree is based on a specific feature, and it breaks the data into groups that are more and more similar in terms of how likely they are to churn.
Gotcha. So let's say the first split is based on average purchase frequency, high versus low. That divides our customers into two branches. Then what?
Then within each of those groups, the tree might split again based on another informative feature, maybe average order value or how many times they've called customer support.
So we're kind of following a path through the tree, each split getting us closer and closer to predicting whether a customer will churn or not. This is really cool.
And what's great about tree induction is that it's really visual. Easy to interpret. You can literally follow those splits and see how the model is making its decisions.
Yeah, it's like having a roadmap to help you understand those crucial insights about your customers.
You got it. And this method, what we call supervised segmentation, lets us tailor our approach to each customer segment based on their unique characteristics and predicted behavior.
Yeah, and that kind of segmentation can be super valuable for businesses. Instead of treating all your customers the same, you can really tailor your marketing. You know, like campaigns and loyalty programs, even product development based on what each segment needs and how they behave.
Okay, I see where you're going with this. This combo of feature selection and tree induction is pretty powerful. We're zeroing in on the most informative attributes, then using them to build a model that can actually make predictions. And then we can segment our customers based on those predictions. But how do we know if the model's doing a good job? What are we measuring here? That's a great question. It's tempting to just focus on accuracy, like how often does the model get it right? But in real life, it's rarely that simple. We need to look at the consequences of different types of errors, too.
Okay, break that down for me. What if our model predicts a customer will churn, but they actually don't?
That's what we call a false positive. And in that case, we might end up wasting resources trying to keep a customer who is never going to leave, like throwing discounts and special treatment at them when they didn't really need it.
Makes sense. And on the flip side, if it predicts a customer won't churn, but they do, that's a false negative, right? What happens then?
Exactly. And that's usually a bigger problem because
Yeah.
now we've lost a valuable customer. We didn't even see it coming. We missed the chance to step in and maybe save the relationship.
So it's not just about getting it right. It's about understanding what each kind of mistake costs us, finding that balance.
Exactly. You got to weigh the cost of those false positives against the false negatives.
Mm-hmm.
Maybe losing a customer costs you 10 times more than the resources you'd spend on a false positive. That kind of cost-benefit analysis helps you tweak your approach and pick a model that minimizes your overall losses.
It's like a strategy game, you know? Trying to predict your opponent's moves and making the best decisions based on the risks and rewards.
Yeah.
But beyond accuracy and costs, what else should we be thinking about when we're evaluating these models?
Another big one is generalization. We want our models to make accurate predictions not just for the data we used to train them, but for new data they've never seen before.
Right. They need to be adaptable, not just memorizing the answers, but actually able to apply what they've learned to new situations.
Exactly. That's where overfitting comes in. It's when a model gets too cozy with the training data, starts picking up on noise and random patterns that aren't really representative of the big picture.
So it's like cramming for a test by only studying the past papers. You might ace those questions, but what about the new ones? How do we keep our models from falling into that trap?
One common technique is to split the data. You use one part to train the model, and then you test it on another part that it's never seen before.
Like giving it a practice test with fresh material. If it does well on that, we can be more confident it's not just memorizing stuff. Anything else we can do to prevent overfitting?
Absolutely. Cross-validation is another powerful technique. It's like giving the model multiple mini-tests to see how it performs on different chunks of the data.
So instead of one practice exam, we're giving it several with different questions each time. That gives us a better idea of how well it can generalize.
Exactly. And besides all that, we also have to think about how complex our models are. Sometimes a simpler model that's easier to understand actually performs better than a really complex one that's more likely to overfit.
So it's not always about using the fanciest algorithms. Sometimes simpler is better.
Right. It's all about finding the right balance between complexity and generalization.
Gotcha. This is all making a lot of sense. We've talked about accuracy costs, different types of errors, and the whole generalization thing.
Yeah.
Are there any visual tools that can help us understand and evaluate these models? Something that gives us a clear picture of how they're performing?
Visualization is super helpful here. One of the most common tools is the ROC curve. Stands for Receiver Operating Characteristic.
ROC curve. Okay. How does that help us visualize things?
Imagine a graph. The x-axis shows the false positive rate, so how often the model incorrectly predicts a positive outcome. And the v-axis shows the true positive rate, so how often it gets it right. The ROC curve basically plots those two rates for different thresholds of the model's predictions.
So it's like a visual representation of that trade-off between being too cautious and missing some positive cases versus being too aggressive and getting more false positives.
You got it. The best ROC curve would hug the top left corner of the graph, meaning you've got a high true positive rate and a low false positive rate. The further the curve strays from that ideal, the less accurate the model is.
This is really helpful. So we can use this ROC curve to compare different models and see which one strikes the best balance, like a scorecard for our models.
Exactly. And there are other visualizations too, like lift charts. They help us see how much better our model is doing compared to just random guessing.
So it shows the lift, the added value our model brings to the table. This is fascinating. We've covered a lot of ground here, from picking features to building and evaluating these models. Anything else we should touch on before we wrap things up?
There's one more crucial piece we haven't talked about: domain knowledge.
Domain knowledge, you mean really understanding the specific business problem we're trying to solve.
Exactly. It's not enough to just have the technical skills. You need to understand the ins and outs of the business, the industry, even the cultural context you're working in.
So going back to our customer churn example,
Mm-hmm.
we'd need to talk to customer service reps. marketing folks, even the customers themselves, really understand what's driving churn in the real world. Maybe there are certain cultural things in India that influence customer loyalty.
You nailed it. Domain knowledge helps you make smart decisions about which features to pick, which modeling techniques to use, and most importantly, how to interpret the results in a way that makes sense for the business.
It's like having a translator to bridge that gap between data science and business decisions.
Precisely. And when you combine that technical expertise with domain knowledge, that's when you can really unlock the power of predictive modeling and make a real impact.
This has been so insightful. I feel like we've really gotten a grip on the power of data here.
Yeah, it's been great. We went from the basics of predictive modeling and feature selection all the way to those more advanced techniques, building the models, evaluating them, figuring out what they're telling us.
And that whole piece about business context really stuck with me. The domain knowledge is key.
It's not enough to just have the technical chops. You got to understand what the business is all about.
Makes sense. I'm already thinking about how I can use these ideas in my own work.
Awesome. And as you start playing around with these techniques, just remember, it's a process. You'll try things out, make mistakes, learn and refine as you go.
So it's not about finding the perfect model on the first try. More about constantly learning and getting better.
Exactly. And as you dive deeper into this, you'll find tons of tools, libraries, and resources to help you along the way.
It's like a whole community of people who are passionate about data.
It is, and you'll quickly realize there's always more to learn. Predictive modeling and feature selection are always evolving.
So you got to stay curious and keep up with the latest and greatest.
Absolutely. And as you gain experience, you'll start to develop your own intuition. You'll see patterns in data that others might miss. You'll anticipate challenges and find creative solutions.
It's like becoming a data detective.
Exactly.
This has been such an inspiring deep dive. I feel like I have a whole new perspective on data now.
Glad to hear it. And remember, the best way to learn is by doing. Grab your data, start experimenting, and see what you discover.
To all you data enthusiasts out there, especially in India, working with those relational databases every day, dive into this world of predictive modeling and feature selection.
It's challenging and rewarding, and it can totally change how you make decisions.
And if you enjoyed this deep dive, be sure to like, share, and subscribe to The Deep Dive for more insightful explorations of the data universe.
Until next time, keep diving deep.
Welcome back to The Deep Dive. Today we're going to be talking about something that's super important if you're working with data, and especially if you're familiar with databases already.
Right.
Model fitting and overfitting.
Yeah, and thinking about it, like if you're building a model to predict customer churn, that can be so valuable. But what if your model gets a little bit too good at predicting churn for your current customers and then fails miserably when you use it for new data?
It's like it learned the wrong lesson somehow.
Exactly.
Yeah. So how do we make sure that our models are actually giving us real insights and not just memorizing the data?
Yeah, it's like studying for a test and just memorizing the answers to last year's exam.
Yeah.
You might do well on that exam, but you won't really understand the material.
Or generalize it.
Exactly.
Yeah. Okay, so let's take a step back before we even talk about overfitting.
Okay.
How do we even fit a model to data in the first place? What's going on behind the scenes when we're trying to capture patterns and make these predictions?
So at its core, a model is just a representation of a real-world phenomenon.
Right.
It could be a mathematical equation, a decision tree, or a complex neural network. The goal is to create a simplified version of reality that helps us understand and predict how things work.
It's kind of like building a blueprint.
Exactly.
But instead of for a building, it's for your data.
And just like a blueprint needs accurate measurements, our model relies on finding these informative attributes within the data.
Okay.
So these are the variables or the columns in your database that actually have a relationship with what we're trying to predict.
So it's not about just using all the data. It's about finding the data points that are actually giving us insights.
Think of it like if you're trying to predict customer churn variables like their purchase history, their engagement levels, their feedback could be very informative.
Sure.
But their favorite color, probably not so much.
Yeah, you got to find the signal from the noise.
Yeah.
So let's talk about overfitting then.
Yeah.
How does a model become overfit, and why is that such a problem for us?
So overfitting happens when a model focuses too much on the specific details of the data it was trained on.
Okay.
It's essentially memorizing the training data instead of learning the underlying patterns.
So it's just memorizing those answers from last year's test.
Exactly.
And not actually learning the material.
And while an overfit model might perform really well in the training data, it often fails to generalize to new unseen data.
Okay.
And this is because it's become too attuned to the quirks and nuances of that training set, which may not be representative of the real world.
And that's a huge problem if we're using these models to make important decisions.
Absolutely. Imagine using an overfit model to predict customer churn. It might look amazing when you test it on your existing customer data, but when you apply it to new customers, the predictions could be way off.
And then you're making decisions based on bad information. So how can we avoid falling into that overfitting trap? What are some things we can do to make sure that our models are really learning and not just memorizing?
There are a couple of techniques that we can use, and often they work best in combination. One approach is to control the complexity of our models.
So keep it simple, stupid.
Right. In many cases, yes. A simpler model with fewer parameters is less likely to get bogged down in the tiny little details of the training data.
Okay.
It's like choosing a concise, straightforward explanation instead of a really convoluted, overly complex one.
I like that analogy.
Yeah.
Are there other ways to prevent overfitting besides just trying to keep things simple?
Yeah. Another really powerful technique is called cross-validation.
Okay, cross-validation. I've heard of that, but I don't really know what it is. What is that?
So it involves splitting your data into multiple subsets.
Yeah, okay.
You use some of those subsets for training your model and the remaining subsets for testing.
Okay.
This lets you see how well your model performs on data that it hasn't seen before, giving you a much more realistic picture of its performance.
So it's like giving our model a bunch of pop quizzes during training to make sure that it's not just cramming,
Exactly.
but that it's actually learning the material.
And this helps us understand how well our model will generalize to new data.
Awesome. So are there any other tools that we have in our tool belt to fight against overfitting?
Yeah, there's another important technique called regularization. It's like adding a penalty for complexity during the model training process.
A penalty, like give the model detention for being too complicated.
You could think of it that way. Regularization encourages the model to find this balance between fitting the training data well and staying relatively simple.
So it's like nudging the model toward finding those general patterns instead of getting lost in the noise.
Right. It helps make sure that the model doesn't overemphasize any particular feature or quirk in the training data.
I see.
And this leads to a more robust model that can handle new data effectively.
Yeah, that makes a lot of sense. All this is really fascinating, and I think our listeners are starting to see how complex and important this whole idea of model fitting is.
Yeah.
But before we go too deep down the rabbit hole, let's maybe switch gears a little bit and talk about a specific type of model that's used all the time in data science. Logistic regression.
Yes.
I know you're familiar with this one. What are the key ideas behind logistic regression?
So logistic regression is particularly helpful when we're trying to predict the probability of something happening.
Okay.
So like a customer churning or a loan defaulting.
Sure.
It takes a set of input variables and uses a special mathematical function to transform them into a probability score that's between 0 and 1.
So instead of just saying, yes, this will happen or no, this won't happen, it gives us more of a
Exactly.
nuanced
It's a probability.
view of how likely it is to happen. That
Exactly.
seems super useful.
It is, and it's
Yeah.
used in a wide variety of fields. Marketing, finance, healthcare, social sciences. It's very adaptable.
Very cool. So this all ties back to building these reliable models that can help us understand and predict the world around us.
Right.
But before we get into the weeds of logistic regression, I want to talk about one other really important aspect of model evaluation,
Okay.
the holdout set.
Yeah.
Can you explain what a holdout set is and why it's so important?
A holdout set is a portion of your data that you keep completely separate during model training.
Okay, so we train our model, we cross-validate it, but then we have this
It's like a secret weapon.
hidden data
Yeah.
that the model hasn't seen. Why is that so important?
Because it lets us get a completely unbiased assessment of how our model will perform in the real world.
So we're really putting it to the test with data that's totally fresh.
Exactly. It's the best way to figure out if our model is truly generalizing or if it's fallen into that trap of overfitting.
It's like the final exam to see if it really knows its stuff.
Exactly.
This evaluation on the holdout set gives us the most realistic assessment of how the model will perform once it's out in the wild.
Exactly.
Very cool. So this has been a really great discussion so far. We've talked about model fitting, overfitting, logistic regression, and the holdout set. But before we wrap up for today, are there any other key takeaways that our listeners should keep in mind when they're trying to build these reliable models?
Yeah, I think it's really important to remember that data science goes beyond just building these fancy complex models.
Okay.
It's about understanding the data, selecting the right tools for the job, and continuously evaluating and refining our approach.
Right. It's not just about the model, it's about the whole process.
Exactly.
Well, that brings us to the end of our deep dive for today. We've covered a lot of ground, and I think our listeners have a lot to think about. A big thanks to our expert for sharing their knowledge.
It was my pleasure. Always enjoy these conversations.
And to all our listeners out there, don't forget to like, share, and subscribe for more deep dives into the world of data. Until next time, keep exploring, keep questioning, and keep learning.
Welcome back to the Deep Dive.
So we've talked about model fitting and why overfitting is something we really want to avoid.
Yeah.
And before the break, we started talking about logistic regression.
Right.
And how it's used to predict these probabilities.
Mm-hmm.
And you mentioned it uses a special mathematical function. Can you unpack that a little bit more for our listeners?
Sure. So imagine you have a straight line on a graph that represents like a simple relationship in your data.
Okay.
What logistic regression does is it takes that straight line and uses what's called a sigmoid function to introduce a curve to it.
Interesting. So what's the significance of that curve?
That curve is what lets us translate the output into a probability.
Okay.
So the sigmoid function essentially squishes the output of the straight line
so
that it always falls between 0 and 1.
I see.
And that becomes our probability score.
So if the output is like 0.6, we would interpret that as a 60% probability of that event happening.
Exactly.
Okay. And you were saying that logistic regression is pretty versatile. It's not just for predicting customer churn.
Right. It's used in so many different situations. Like you can assess credit risk with it, gauge the likelihood of someone clicking on an ad.
Oh, wow.
Even medical diagnoses.
So many applications.
Yeah, it's very adaptable.
It seems like it'd be a pretty fundamental tool for any data scientist to have in their toolbox.
Yeah, for sure.
So let's go back to that secret weapon that we were talking about before the break, the holdout set.
Yeah.
How do we actually use the holdout set in practice?
So the process involves dividing your data into two sets.
Yeah.
Your training set and your holdout set. Typically, you might use like 80% of your data for training and reserve the remaining 20% as your holdout set. Now the model gets trained on that 80%. You fine-tune the parameters, you do class validation, all those good things.
Okay.
But during this whole training phase, the holdout set is kept completely hidden from the model.
So it's like we're putting our model through boot camp with the training data.
Exactly.
And keeping the holdout set is a totally fresh challenge.
Yeah, that's a great way to put it.
And then once the model's done with its training, what do we do with that holdout set?
That's when we unleash the model on the holdout set.
Okay.
We feed it this brand new data that it's never seen before and see what predictions it makes.
Right.
And because we already know the actual outcomes for the holdout set, we can compare the model's predictions to reality.
Oh, so it's like the final exam.
Exactly.
Where we see if the model really understands the concepts or if it was just memorizing stuff.
Exactly. And this evaluation with the holdout set gives us the most realistic assessment of how our model will actually perform in the real world.
But what if the model doesn't do so well on the holdout set? What do we do then?
That's a really important point. If the model struggles on the holdout set, it means we need to go back and rethink our approach.
Okay.
We might need to adjust the model's complexity, try different features, or even consider a completely different type of model.
Yeah.
The feedback from the holdout set is super valuable for making our model better and more robust.
So it's not just a one-time test. It's a tool that helps us along the way as we're building the model.
Exactly. It makes sure that our models are reliable and can be generalized to new data. It's like insurance against building a model that looks good on paper, but doesn't work in the real world.
This has been really eye-opening. I feel like we've uncovered a lot about model fitting, overfitting, and the importance of things like the holdout set.
Yeah.
So before we wrap things up, are there any other important takeaways our listeners should remember when it comes to building these reliable models? It's been a really fascinating deep dive into the world of models, and I think we've given our listeners a lot to think about.
Yeah, definitely. And, I think it's important to remember that data science, it's not just about building these fancy, complex models.
Right.
It's about understanding the data, choosing the right tools, and constantly evaluating and refining what we're doing.
Right. It's about the whole process.
Yeah, and making sure we can communicate our findings clearly.
Yeah, that's a really good point. Being able to explain your model and your results in a way that makes sense.
Exactly.
That's just as important as the technical stuff.
It is, because if you can't communicate your findings, even the most brilliant model could fall flat.
Nobody will understand it.
Exactly. Transparency is key to building trust and making sure these data insights are actually used.
Right. It's about making those complex ideas accessible.
Yeah.
So before we let our listeners go, I have one final thought-provoking question for you.
Okay.
Imagine a world where every data-driven decision was based on models that were rigorously tested with these holdout sets. What kind of impact do you think that would have?
That's a great question. I think it would really change the way we make decisions.
Uh-huh.
We would see fewer costly mistakes from bad models
Right.
and more trust in data-driven insights. It would make the whole data science field more accountable and rigorous.
It's a pretty compelling vision.
Yeah.
A world where data helps us make smarter decisions.
Exactly. And by using these rigorous evaluation techniques like holdout sets, we can make that vision a reality.
I love it. Well, that brings us to the end of our deep dive today.
It does.
We've explored model fitting, the dangers of overfitting, and the power of logistic regression and the holdout set. A huge thank you to our expert for joining us and sharing their expertise.
My pleasure. Always a great conversation.
And to all of our listeners out there, don't forget to like, share, and subscribe for more deep dives into the world of data. Until next time, keep exploring, keep questioning, and keep learning. All right, so we're diving into something pretty crucial today. I mean, we all work with relational databases, right?
Yeah.
So we get how vital it is to make sure our classification models are actually, working out there in the real world.
Absolutely.
And that means going beyond just building them. We need to figure out how to truly evaluate their performance and make sure they're solving the problems we're throwing at them.
Yeah.
So to help us with this, we've got our expert guide here. What's the first thing that comes to mind when we talk about evaluating these models?
Well, for a lot of people, the first thing they think of is accuracy.
Mm-hmm. Okay.
Like, how often does the model get it right?
Yeah, that makes sense.
Yeah.
It's easy to understand, which is always good.
Yeah.
But is accuracy always the best way to judge how well a model's performing?
See, that's where it gets interesting. Just looking at accuracy can be, misleading, especially if you're working with data sets that are imbalanced.
Imbalanced, okay.
Yeah. Like, think about fraud detection. Thankfully, fraudulent transactions are pretty rare. But imagine you've got a model that says, hey, I've got 99% accuracy.
Okay, it sounds impressive.
Sounds great, right? But if fraud only happens 0.1% of the time, that model could just be predicting not fraud for everything.
Oh, I see the problem.
Not really helpful.
Yeah, not very helpful at all. So high accuracy score, it doesn't tell the whole story. What's a more reliable way to evaluate these models then, if we can't just rely on accuracy?
So this is where we bring in the confusion matrix.
Confusion matrix.
Yeah. It's a really, really useful tool for visualizing how our model's actually doing across all the different types of predictions.
Confusion matrix. That sounds a little intimidating.
Oh, it's not as bad as it sounds.
Okay.
Really, think of it like a table compares what the model predicted to what actually happened.
Okay.
And this table, it doesn't just tell us how many times the model got it right. It also breaks down the different types of errors it's making. For example, it shows us, how many times it correctly predicted a positive case.
Okay.
That's what we call a true positive.
Gotcha.
And it shows us how often it incorrectly predicted a positive case when it was actually negative. So a false positive.
So instead of one single number for accuracy, the confusion matrix gives us a more detailed look at what the model's good at and where it's, struggling.
Absolutely. So let's say you've got two models for predicting whether a customer's going to, leave.
Okay.
Churn, yeah. Both of them have 80% accuracy.
Okay, so on the surface, they seem the same.
Exactly. They look the same. But then we look at their confusion matrices.
Okay.
One might be great at spotting the customers who are actually going to leave, but it also might falsely flag a bunch of loyal customers.
Right.
As likely to churn. And that could lead to, a bunch of interventions that you don't need.
Yeah, that's not good.
On the flip side, the second model might not be as sensitive, so it doesn't catch all the churners, but it does a better job of avoiding those false alarms.
So which model is better then?
Well, it depends, right?
What?
On your business goals and what it costs for each type of error.
Wow. So even though they have the same accuracy overall, their impact could be completely different.
Yeah.
The confusion matrix really is revealing those hidden differences, the things that are behind that single accuracy number.
Exactly. And this brings us to something really important. You have to think about the specific application when you're evaluating a model. What works for one thing might be totally wrong for another.
Right. It's not one size fits all.
No.
So how do we choose the right evaluation metric then? based on the application on the context.
Okay, so this is where expected value becomes super powerful.
Expected value, all right.
It lets us move beyond just accuracy and start thinking about like the costs and benefits of different model outcomes.
Costs and benefits. So we're bringing in the business side of things here.
Exactly. Expected value looks at the gains and losses that come with each prediction. Like incorrectly approving a high-risk loan, that could cost a bank a ton of money.
Yeah, for sure.
But, incorrectly recommending a product to someone shopping online, well, maybe that just means their experience isn't quite as personalized.
So a false positive in one situation is not the same as a false positive in another.
Exactly. And by figuring out the cost and benefits for your specific application, you can pick the model that actually maximizes profit or minimizes loss, even if it doesn't have the highest overall accuracy.
That makes a lot of sense. It's like we're moving away from just looking at the data and taking a more holistic view.
Yeah.
That includes what's happening in the real world, the business implications.
Right.
Can you give us an example of how this works in practice?
Yeah.
How can expected value actually help us make better decisions?
Okay, let's go back to predicting customer churn.
Okay.
Imagine you've got a model that's got to decide whether to give a customer a special incentive to try and keep them.
Yeah.
Expected value can help us figure out which customers would actually benefit the most from that offer.
So we're not just looking at how the model's doing overall.
No.
We're looking at how it does for each customer.
Exactly. For each customer, we're estimating two things: the probability of them churning if we offer the incentive, and the probability of them churning if we don't. And then we also need to factor in the cost of the incentive itself and how much revenue we might lose if they do churn.
So it's a balancing act, basically.
It is.
We're weighing the benefits of keeping a customer against how much the incentive costs.
Right. Let's say the incentive costs $50. If a customer's likely to churn and we don't do anything, we might lose $500 in future revenue. But if we offer the incentive and they stay, we've saved $450. On the other hand, if they were going to stay anyway, offering the incentive is just wasting $50.
So the model needs to be able to spot the customers where the potential gain is bigger than the cost.
Exactly. And this is where our confusion matrix comes back in.
Oh.
Remember how it breaks down the different types of predictions? We can use that info to estimate those probabilities, like the probability of customer churning even after they get the incentive.
Okay, so we're using the confusion matrix to help us calculate expected value.
Yeah.
And those calculations help us decide which customers to target. It feels like it's all coming together. We start with accuracy, then we look at the nuances with the confusion matrix, and now we're using expected value to connect those insights back to the business and make smarter choices.
Exactly. It's a journey from data to information to insights that actually make a difference for the business.
I like that. We've covered a lot, and I'm already feeling like we've learned some really valuable things. Before we move on to dive even deeper into expected value in the next part of our deep dive, what stands out to you so far? What's resonating the most?
I think what's really cool about expected value is it changes how we think about models.
Mm-hmm.
It's not just about finding the most accurate one anymore.
Right.
It's about picking the model that actually works best for your specific business goals.
It definitely feels a lot more strategic.
Yeah.
Like we're going beyond just the technical stuff.
Exactly. When you clearly define those costs and benefits for your specific problem, you're basically creating a custom evaluation metric just for your needs.
Okay. I get the importance of expected value, but how do we actually use it? Can you walk me through like a real world example, how we'd use it during the evaluation process?
Sure. Let's go back to that customer churn prediction example.
Okay.
Say we have a model and it needs to decide whether or not to offer a customer a special incentive.
Okay, to try and keep them from churning.
Yeah, a retention incentive. Expected value can help us decide which customers would really benefit from that offer.
So we're not just looking at the overall performance of the model.
Nope.
We're looking at how it performs for each individual customer.
Exactly. For each customer, we'd estimate two things: the probability of them churning if we offer the incentive, and the probability of them churning if we don't. And then we also have to factor in the cost of that incentive, and how much revenue we might lose if they do actually churn.
So there's a lot to balance. We're weighing the benefits of keeping a customer against the cost of that incentive.
Right. Let's say the incentive costs like $50.
Okay.
If a customer is likely to churn and we don't offer it, we might lose $500 in the future.
In revenue, yeah.
But if we offer the incentive, we saved $450. But on the other hand, if they were going to stay anyway, offering the incentive was a waste of $50.
So the model needs to be smart enough to find those customers where the game is worth it.
Exactly. And this is where our confusion matrix comes back into the picture.
Oh.
Remember how it breaks down all those different types of predictions? We can use that information to estimate those probabilities. Like, what's the probability of a customer churning even after they've gotten the incentive?
So we're using the confusion matrix to inform our expected value calculations.
Yeah.
And then those calculations help us make those strategic decisions about which customers to target.
You got it. That's what makes this so powerful. Expected value doesn't just tell us, hey, this is a good model. It tells us how to use that model to get what we want, to achieve those business goals.
We're not just building models. We're building decision-making systems. It feels like there's a lot to think about with expected value, though. Is there anything else we need to keep in mind? It does feel like expected value kind of opens up like a whole new way of thinking about models. Anything else we should keep in mind as we're, actually using this?
One thing to remember is expected value. It isn't like a magic bullet. It's not one size fits all. You have to adapt it to the problem you're trying to solve.
That makes sense. I can imagine how we'd use it for, say, predicting stock prices would be totally different from how we'd use it for predicting customer churn.
Exactly. The costs and benefits, the probabilities, even what we consider a success, it all changes depending on the problem.
So how do we actually customize this expected value framework for different applications? Like, where do we even start?
You got to start by being really clear about your business objectives. What are you actually trying to do with this model? What are the key performance indicators that really matter?
Okay, so we have to think beyond the model itself. Think about how those predictions will actually be used.
Exactly. And this often means, data scientists and business stakeholders have to work together.
Oh, okay.
Data scientists have the expertise in, building and evaluating models. But the business people, they understand the real-world consequences.
It sounds like it's got to be a real partnership. Data science brings the tools, and the business expertise guides how we use them.
Exactly. And that partnership is key to making sure that our expected value framework is really lined up with what the business needs.
This whole deep dive into evaluating models has been really insightful. We started with accuracy, then we looked at the confusion matrix and all those nuances, and now we've got this powerful framework of expected value to help us make better decisions. As we wrap up, what's the one key takeaway you want our listeners to walk away with today?
I'd say if we zoom out a bit, evaluating how our model's doing isn't just a technical box we check. It's absolutely essential to make sure that our data science projects are actually delivering real value for the business.
Right.
By understanding the context, using tools like the confusion matrix, and really embracing that expected value framework, we can make sure our models aren't just accurate, they're actually making a difference.
That's a great takeaway. So next time you're building a classification model, don't just stop at accuracy. Dive deeper, look at the context, use expected value to guide your decisions. And to our amazing listeners, thank you so much for joining us on the Deep Dive. If you enjoyed this episode, don't forget to like, share, and subscribe for more deep dives into the fascinating world of data science. Until next time, keep exploring, keep learning, and keep asking those deep questions.
All right, so today let's dive into something pretty cool. How we can use evidence and probabilities together to make smarter decisions. Think about like databases, the ones you work with every day. What if we could predict things from that? Like which customers might leave or who's going to be like super interested in our new product launch?
Yeah, that's really what we're talking about, is teaching computers to think like detectives. So they have to like weigh different pieces of evidence and then figure out what conclusion is most likely. Just like a, seasoned investigator.
That makes a lot of sense. What are some of the tools or like concepts that make this detective work possible?
So one of the most powerful tools is something called Bayes' rule. And I know it might sound a little intimidating at first, but it's actually based on a very natural way of thinking that we use all the time without even realizing it.
Oh, really? Give me an example.
Sure. Okay. So imagine you hear the doorbell ring. You don't immediately assume it's like your long-lost cousin from Australia, right? You probably think of other things first.
Right. It's probably the delivery guy because I'm expecting a package.
Exactly. You're subconsciously using Bayes' rule there. You have some initial beliefs based on your experience. Like delivery people ring doorbells more often than long-lost cousins. And then you update those beliefs based on new evidence. In this case, you're expecting a package.
So Bayes' rule is basically a way of formalizing this whole process of updating our beliefs when we get new information.
Exactly. And it's super useful in data science for all sorts of tasks. Like, think about email spam filters. They learn to identify spam by analyzing the words and phrases in spam messages. And as they analyze more and more emails, they get better and better at telling the difference between spam and real messages.
Oh, that's interesting. So how does Bayes' rule actually work in practice? So let's say we're trying to predict customer churn, which is, a big problem for lots of businesses.
Okay, so let's say you know that on average, about 5% of your customers churn each year. That's like your baseline probability. Now, you also observe that customers who haven't bought anything in the last 6 months are a lot more likely to churn. So this new information, their inactivity, becomes your evidence. And Bayes' rule lets you calculate the updated probability of a customer churning given that they haven't made a purchase in 6 months.
Okay. So we're kind of refining our initial guess.
Yeah.
Based on this new piece of information, right? And this new probability gives us a better picture of who might actually churn.
Exactly. And this can help us make decisions about things like which customers we should target with campaigns to try and retain them. But things can get tricky when we're dealing with tons of different variables and trying to figure out how they relate to each other. That's where conditional independence comes in.
Conditional independence. So the word conditional already kind of suggests that it's about specific conditions, right? Can you explain that?
Sure. Think about it this way. Let's say you're trying to predict if someone's going to like a certain movie. You might think about factors like their age, their gender, and what genres they prefer. Now, someone's age and gender might influence what movies they like independently of each other. But if you know what their favorite genre is, then those other two factors might not be so relevant anymore.
So if someone loves action movies, knowing their age and gender probably doesn't tell us that much more about whether they'll enjoy the next big action movie.
Exactly, because their love of action movies overrides those other factors. So in this case, age and gender are conditionally independent, given their preferred genre.
Ah, I see. So it's like certain pieces of evidence become more or less important depending on what else we know. Yeah. And how does this all relate to naive Bayes? I've heard that a lot in data science.
Right. Naive Bayes is a classification technique that uses this idea of conditional independence to make predictions. And the naive part comes from the fact that it sometimes assumes things are conditionally independent, even when they might not be completely true. It's a simplification, but it works really well a lot of the time.
So it's like we're making an educated guess based on the idea that certain things are independent, even if they might actually be related in the real world.
Yeah, a good way to put it. Imagine you're classifying news articles into categories like politics, sports, and entertainment. So a naive Bayes classifier might look at the individual words in an article. Words like election or parliament might each make it more likely that it's about politics. And the classifier combines those probabilities, assuming they're independent, to make a final decision.
Okay, so it's like putting together a puzzle where each piece is a bit of evidence, and we're trying to see if they all fit to make a picture. But how do we actually know which pieces are really important and which ones are just distractions?
That's a great question. And it leads us to this really important idea in data science called lift.
Okay, tell me about lift and how it helps us evaluate evidence.
So lift basically measures how much more likely an event is to happen, given a specific piece of evidence, compared to the baseline probability. To put it simply, it tells us how surprising or informative that piece of evidence actually is.
Yeah, so if we think back to our customer churn example, a high lift for no purchase in the last 6 months would mean that that's a really strong predictor of churn.
Right, so it means customers who haven't bought anything recently are way more likely to churn than the average customer. So that makes no recent purchase a really valuable thing to consider when we're building that churn prediction model.
Exactly. It's kind of like a detective focusing on the clues that are most likely to help them find the culprit. Now let's imagine we've actually built our model and it's predicting churn pretty well. How do we really know that it's reliable? That it's not just finding random patterns in the data? That's a good point.
Yeah.
We don't want to base our business decisions on something that's basically just flipping a coin, right?
Right. That's why we have to test and validate our models really thoroughly before we use them in the real world. One way to do that is holdout testing.
Holdout testing. I think I've heard of that before. Can you remind me how that works?
Sure. It's actually pretty simple. Imagine you're a teacher getting your students ready for a final exam. You wouldn't give them the actual exam questions to practice on, right?
Right. You'd give them similar problems to make sure they actually understand the concepts.
Exactly. It's the same with data models. So with holdout testing, we take a part of our data, maybe like 20%, and the model never sees it during training. This is what we call the holdout set. And once the model is trained on the other 80% of the data, we use the holdout set to see how it performs on examples it's never seen before.
So it's like giving our model a pop quiz to see if it can handle new data.
Exactly. This helps us make sure that our model isn't just memorizing the training data, but can actually make accurate predictions on new data. And we can actually go a step further with something called cross-validation.
Cross-validation is kind of like doing multiple holdout tests.
Yeah, exactly. So with cross-validation, we split our data into multiple folds, let's say 5 folds, and then we train and test the model 5 times, each time using a different fold as the holdout set.
So each fold gets its turn as the pop quiz.
Right. And this gives us a much more robust estimate of how well the model performs, because we're testing it on lots of different parts of the data.
That's clever. It's like getting a bunch of different expert opinions.
Yeah.
To be extra sure we're making the right call. But even with all this testing and validation, isn't it still possible for our model to be off or misleading?
Oh, of course. No model is perfect, and there are always going to be things to watch out for. But if we understand the principles of combining evidence, evaluating lift, and rigorously testing our models, we can definitely improve our chances of making good data-driven decisions.
Okay, that makes a lot of sense. So we've talked about all these individual concepts and techniques, but how does it all come together practically? How do businesses actually use these ideas to tackle real-world problems?
That's where analytical engineering comes in. It's all about designing and actually implementing data-driven solutions to specific needs that a business has.
Analytical engineering. So it's kind of like being an architect, but instead of buildings, you're designing systems that can find knowledge and insights hidden in data.
That's a great way to think about it. It all starts with really understanding the business problem we're trying to solve. Like, are we trying to reduce customer churn, optimize marketing campaigns, or maybe improve product recommendations? And once we've defined that problem, we can start thinking about what data we need, what techniques to use, and how to measure our results.
Okay, so let's say a company is dealing with that customer churn problem we talked about earlier. How would they approach it from this analytical engineering perspective?
The first thing they need to do is figure out what churn really means for them. Is it customers canceling subscriptions, not renewing contracts, or maybe just becoming inactive on their platform?
Right, because churn can mean different things depending on the business.
Exactly. Then they got to figure out what data they have that could be useful. Things like customer demographics, their purchase history, how they interact with the website, and their interactions with customer service, anything that could give us clues about why people are leaving.
So like gathering all the evidence a detective would use to understand the story behind the churn.
Right. Once we have the data, we can start exploring it, looking for any patterns and connections that could help us predict churn. We can use things like Bayes' rule, conditional independence, and lift analysis to figure out what factors are most strongly linked to churn.
And then use all that to build a model that tells us which customers are most likely to churn in the future.
Yeah, but analytical engineering goes beyond just building models. It's also about understanding the costs and benefits of different things we could do.
So it's not just about predicting churn, but actually making smart decisions about how to address it.
Yeah.
In a way that makes sense for the business.
Exactly. For instance, we might identify a group of high-risk customers who are very likely to churn and then target them with special offers, customized messages, or other things to try and keep them around.
That makes sense. It's about using the data to understand what's happening, but then also using that understanding to make better decisions and drive good outcomes.
Yeah, and that's the whole point of analytical engineering, to use data to create value for businesses and their customers.
Okay. This is all making a lot of sense now. But before we wrap up, is there anything else we should keep in mind when we're using data to make these decisions? Any potential traps to watch out for?
That's a great question, and it leads us to something really important. It's easy to think of data as this magic crystal ball that gives us all the answers, but really it's just a tool. And like any tool, you can use it well or you can use it badly.
So we shouldn't get carried away and think that data is some ultimate truth.
Exactly. We have to be a little skeptical and think critically about the data we're using. We got to understand the limitations, the assumptions we're making, and any biases that might be in there.
Yeah, that's true. Because data is collected and processed by people, and people have biases.
Right. Let's say we're trying to collect data about customer satisfaction through surveys. The way we design the survey questions and who we ask those questions to can really affect the results we get.
So it's not just about running the numbers and building models. It's also about understanding the context and the nuances of the data and where it might be flawed.
Absolutely. That's why it's so important to really grasp those data analysis techniques and principles. It's not just about the technical skills, it's about being able to look at the data critically, interpret what it's telling us, and then use that to make smart decisions.
So it's bigger than just data science as a technical field. It's about having this data-driven mindset and knowing how to use information to make better decisions.
Yeah, that's it. And that's a valuable skill to have in any job, really, whether you're leading a business, working in marketing, or even just trying to understand the world around you. Being able to think about data is essential.
Okay, so let's recap. We talked about how to combine evidence and probabilities with Bayes' rule, how to understand the connections between different variables using conditional independence and naive Bayes, and how to see how strong a piece of evidence is with this idea of lift.
We also talked about how important it is to really test our models thoroughly to make sure they're reliable and that they'll work with different data. And then there's the whole field of analytical engineering, which is all about building and using data-driven solutions to solve problems.
This deep dive has been so helpful. I feel like I've learned a lot about how to analyze data and make decisions.
I'm glad to hear that. And remember, we've only just scratched the surface here. There's a ton more to learn in the world of data.
Totally. If you liked this episode and learned something new, please share it. Don't forget to like and subscribe to The Deep Dive for more explorations of fascinating topics.
Keep asking questions and see what you can do with the power of data.
All right, let's talk about similarity. It's more than just things looking alike. It's pretty important in data science, as you know. You already know how important it is with relational databases. But imagine taking that same idea and using it to find like hidden patterns and make predictions. That's what we're going to be looking at today.
Yeah, it's really about connecting those dots in a way that helps us understand our data a lot better.
Exactly. So think about it like this.
Mm-hmm.
You're trying to figure out which of your customers are most likely to, leave and go to a competitor.
Mm-hmm.
Instead of just looking at each customer one by one, we can use similarity to find groups of customers that kind of act alike. And that can really help.
Yeah, and that's just, the tip of the iceberg.
Yeah.
We're also going to be looking at how this grouping by similarity can help us segment data, even when we don't have, a specific goal in mind.
Okay, so let's start with the basics. Why is similarity such a big deal in data science?
Well, it's more than just things looking the same, right?
Wow.
It's really about finding those meaningful relationships between data points, even in large data sets. Think about it like this. You use specific characteristics to identify things in a database, right?
Right.
Data science takes that idea and uses it to uncover hidden connections, which can help us understand our data a lot better.
Okay, so it's like we're taking what we know about databases
Yeah.
and using that to find insights we might have missed.
Precisely.
All right, so you mentioned nearest neighbor methods. What are those?
Imagine you have a new customer, right?
Yeah.
And you want to predict their behavior. Nearest neighbor methods find existing customers with similar traits and use their past actions to make a prediction. Like those recommendation systems that say, if you liked this, you might also like these. They use the same logic.
So it's like how Spotify suggests new music or how Netflix recommends movies based on what you've watched before.
Exactly.
That makes sense.
Yeah, let's take a simple example. Recommending whiskeys, right? Imagine we know certain characteristics about different whiskeys, like their color, their sweetness, their smoothness, smokiness, stuff like that.
So if someone enjoys like a smoky Islay Scotch, we could use this method to find other whiskeys with similar characteristics and recommend those.
Exactly.
But wouldn't we have too many options to choose from?
That's where the nearest part comes in, right? We focus on the most similar whiskeys, the ones closest in terms of those characteristics. It's like plotting different whiskeys on a map based on their features. Whiskeys closer together on this map are more similar in taste, and we can use math to figure out how close they are.
Okay, so that helps visualize it. Well, what if we're comparing different types of data, like a customer's income and their purchase history? Those seem hard to compare.
Yeah, that's a great point. Comparing different types of data can be tricky, but there are clever ways to handle these situations, and we can use different methods to measure similarity depending on the type of data that we're working with.
Okay, that's reassuring. Now, I'm curious about clustering. It sounds like we're just grouping similar data points together, even without a specific goal in mind.
Yeah, you got it. Clustering is all about finding hidden structures in your data. Groups that naturally exist. Think of it as letting the data speak for itself going back to our whiskey example, we could use clustering to group different whiskeys based on their characteristics, even if we don't know anything about, where they're from or anything like that.
So we could find a cluster of, like, smoky Islay scotches, a cluster of delicate Highland whiskeys, just by letting the data guide us.
Exactly.
But how do we actually create these clusters?
There are a few different ways to do it. Two common methods are hierarchical clustering and a k-means clustering. Hierarchical clustering is like building a family tree of relationships between data points. It creates this visual representation called a dendrogram, which looks like a branching tree. And you can then clip this tree at different points to create different levels of groups.
So if we clip it higher up, we get broader groups, and we clip it lower down, we get more specific groups.
Exactly.
I can see how that would be useful. What about k-means clustering?
So with k-means clustering, you start by deciding how many clusters you want to find. Let's say you want 3 clusters of whiskeys. The algorithm then uses special points called centroids, which are like average points within each cluster to group the data points. And it keeps adjusting these centroids until it finds the best way to group the data.
So that sounds a bit more complex than hierarchical clustering, but it also seems quite powerful. Now, once we've created these clusters, how do we know if they're actually meaningful? I mean, we need to make sure they're actually telling us something useful, right?
Absolutely. Evaluating clustering results is a bit different from evaluating, something like a prediction. It can involve a more exploratory approach where we use our knowledge of the data and the business context to see if the clusters make sense. It's not just about the numbers, it's about understanding what those clusters represent.
Okay, so it's a bit more subjective, but that makes sense given that we're often trying to find, hidden patterns in the data.
Yeah.
Are there any specific methods or techniques that can help us understand these clusters better?
Yeah, definitely. One way is to look at, typical members of each cluster, like finding the poster child for each group. In our whiskey example, it might be identifying, the best of its class whiskey within each cluster. Or imagine we're clustering news stories. We can use the headlines of those stories to represent large groups of similar articles.
Okay, so that's a great way to make those clusters more tangible. And instead of just seeing these abstract groups, we get concrete examples that help us understand what each cluster is all about. But I'm guessing there's even more to it than that.
Oh, absolutely. We can go deeper and use other techniques to analyze those clusters and uncover even more insights. But we'll save that for later.
Okay. Sounds good to me. Before we do that, I just want to remind everyone listening to like, share, and subscribe to The Deep Dive for more explorations into the world of data science. Now, what else can you tell us about similarity?
It's fascinating how these similarity concepts can actually be used to understand, why things are grouped together.
Okay, I'm intrigued. Tell me more.
So let's think about targeted online ads. You see them all the time, right?
Oh, definitely, yeah. Sometimes it feels like they're reading my mind.
Yeah, it's not mind reading. It's really about using data effectively.
Yeah.
Imagine you're an advertiser.
Yeah.
And you're trying to figure out who to show your ad to, right? You want to reach the people who are actually interested in what you're selling.
Right, makes sense. Otherwise, you're just wasting money.
Exactly. So advertisers use data about consumers, things like demographics, browsing history, purchase behavior, even social media activity, to build models that predict who is most likely to respond to an ad.
So it's kind of like those nearest neighbor methods we were talking about before. But instead of recommending whiskeys, we're recommending ads. Finding consumers who are similar to those who have clicked on similar ads before.
Exactly. That's a great way to put it. And to make those predictions even better, we can use a technique called Bayes' rule.
Bayes' rule? That sounds a bit intimidating.
It's really not that bad once you get the hang of it. Think of it like this. You see an ad for a new phone, right? Your initial reaction might be, I'm good with my current phone. But then you see the ad highlights features you actually care about, like a killer camera or amazing battery life, and suddenly you're much more interested.
Ah, I see. Okay, so the ad gives us new information. That changes our initial assessment.
Precisely. Bayes' rule lets us update our beliefs based on new evidence. In advertising, it helps calculate how likely someone is to click an ad based on all these different factors.
So if we know that people who visit certain websites or click certain links or like certain pages on social media are more likely to be interested in, let's say, hiking gear, We can use Bayes' rule to target those people with ads for hiking boots or something.
You got it. And there's a specific type of Bayes' rule that's really useful here called naive Bayes.
Naive Bayes, does that mean it's like too simple to be effective?
Not at all. The naive part comes from the assumption that different pieces of evidence are independent of each other. So, for example, it assumes, someone's browsing history doesn't influence their social media likes. In reality, there's probably some connection there. But this simplifying assumption makes the calculations a lot easier, while still being surprisingly accurate.
Interesting. So we're sacrificing a little bit of accuracy for a much simpler model. Seems like a good trade-off.
Often it is, yeah. And that balance between complexity and practicality comes up a lot in data science.
Okay, now you mentioned evidence lift earlier. What exactly is that?
Evidence lift tells us how much more likely something is to happen. Given a specific piece of evidence, let me give you an example. Let's say we're trying to predict if someone is a fan of, a particular band. Let's say the Beatles. So we know a certain percentage of people, like the Beatles, but then we learn that people who like, say, the Rolling Stones and the Kinks are much more likely to also be Beatles fans.
So liking those other bands is strong evidence that someone might also like the Beatles?
Exactly. That's evidence lift in action, and we can actually calculate how much more likely someone is to be a Beatles fan if they like those other bands.
I see. Okay. So evidence lift can help us prioritize the information that's most useful for making predictions.
It does. And we can use it for, all sorts of predictions like customer churn, fraud detection, even movie recommendations.
Okay. Now, going back to our whiskey example, you mentioned we could use clustering to group whiskeys. But what if we wanted to actually describe those groups? How could we do that?
That's where things get even more interesting. We can use a technique called supervised learning to train a model that predicts which cluster a whiskey belongs to based on its characteristics.
Wait, so we're using supervised learning to, understand the results of unsupervised learning?
Exactly. It might sound a bit counterintuitive, but it's a really powerful way to get a deeper understanding of those clusters. By training a supervised model, we can see which characteristics are most important for distinguishing the different groups. We can even, generate descriptions or headlines for each cluster.
So instead of just saying cluster A has these features, we could say something like cluster A represents rich, peaty, smoky whiskeys.
Exactly. We're turning abstract clusters into something more concrete and understandable.
Okay, this is really fascinating. So we can use similarity not just to group data, but to really understand what those groups mean.
Yeah, that's a great point. And it reminds us that just focusing solely on accuracy can sometimes lead us astray. There are other factors we need to consider when evaluating our models.
Like what?
Well, think about building a model to detect fraudulent credit card transactions, right?
Okay.
You might be able to get really high accuracy by flagging anything even slightly suspicious. But what if that means lots of legitimate customers get their cards declined?
Oh, that would be terrible. It'd be a huge inconvenience for customers, and it could really damage a company's reputation.
Exactly. It's not just about accuracy. It's about balancing that with the real world impact of our predictions.
Right. So in that case, maybe we'd want to focus on minimizing false positives, even if it means slightly lower overall accuracy.
You got it. The key takeaway here is that evaluating a model goes beyond just, looking at accuracy. We need to think about the specific goals of the problem we're trying to solve.
That's a great point. It seems like there's a lot more to data science than just building models and calculating accuracy.
Absolutely. There's a whole world of real-world applications and considerations that we need to keep in mind. And that brings us to the concept of analytical engineering.
Analytical engineering. What's that all about? So you're saying analytical engineering is about more than just the technical stuff, right? It's about connecting data science to real-world business problems.
Exactly. It's like being an architect. But instead of designing buildings, we're designing solutions using data.
Okay. I like that analogy. So just like a good architect considers, the purpose of a building, the available materials, the budget, all that stuff. A good analytical engineer considers the business objectives, the data at hand, and the available resources.
Precisely. And there are specific frameworks that can guide this process. One that's really useful is the concept of expected value.
Okay, what is expected value, and how does it apply here?
It's a way to quantify the potential benefits and costs of different actions. Let's go back to our churn prediction example, right?
Mhm.
Imagine you're a telecom company, and you're trying to reduce customer churn. You've got tons of data about your customers, demographics, usage patterns, billing history, all that stuff. But how do you translate that data into a concrete solution?
Right. That's where analytical engineering comes in. We need to figure out what kind of model to build, what data to use, and how to evaluate the results in a way that actually makes sense for the business.
Exactly. And an expected value can help us make smarter decisions. For example, we might calculate the expected value of offering a customer, a special promotion to try to convince them to stay. We would weigh the cost of that promotion against the potential revenue we could gain if they stay.
So we're not just looking at whether we can predict churn. We're looking at whether it's actually worth it to try to prevent it.
Exactly. And we can get even more sophisticated by factoring in the probabilities of different outcomes. Like, what's the probability a customer will churn if we don't offer them a promotion versus the probability they'll stay if we do?
So it becomes a kind of cost-benefit analysis, but with probabilities factored in. That's pretty powerful.
It is. And it can help companies figure out where to focus their efforts. Maybe it's more profitable to focus on certain types of customers who are more likely to respond to promotions.
Okay, so this analytical engineering approach is really starting to make sense. It's about making data science work for the business, not just existing in a vacuum.
That's a great way to put it. And speaking of business, another key aspect of data science is understanding the competitive landscape.
Right. Companies that are good at using data often have a real edge, don't they?
It's true. In today's world, being able to extract insights from data can really make or break a business. But it's not just about having data. It's about having the right people and processes in place to use it effectively.
I see what you mean. A company could have mountains of data, but if they don't have skilled data scientists, or a culture that values data-driven decisions, it's practically useless.
Exactly. It's like having a fancy kitchen but not knowing how to cook.
Yeah.
So companies need to build what we call data science capability, having the right people, tools, and mindset to actually leverage their data.
And that can look different for different companies, right?
Absolutely.
Some might have big centralized data science teams, while others might have data scientists embedded in different departments.
You got it. It all depends on the company's structure and goals.
Wow, this has been a really incredible deep dive. We've explored so much, from the fundamentals of similarity to its applications in prediction, clustering, and evaluation. We even talked about the bigger picture of how data science fits into the business world.
It's amazing how a concept that seems so simple, like similarity, can unlock so many possibilities.
It really is. And as always, there's so much more to learn and explore. But for now, we've reached the end of our deep dive. Don't forget to like, share, and subscribe to the deep dive for more fascinating journeys into the world of data science. Until next time. All right, so let's dive into this whole world of recommendation systems. Those algorithms that suggest what you might want to buy on Amazon or what to watch next on Netflix.
Yeah.
They're not magic.
No.
It's really clever data science at work. And today we're going to break down exactly how they work.
Okay.
Specifically, a technique called collaborative filtering.
All right.
Get ready to understand why it's such a powerful tool and how companies actually use it. And of course, the challenges in getting it right.
Absolutely.
So it's pretty amazing how these systems work, right?
Yeah, it is.
Can you give us a scenario?
Sure. Imagine you and thousands of others rate different whiskeys.
Okay.
This creates this massive web of preferences, right?
Yeah.
And data scientists can analyze this to find groups with similar tastes.
Okay.
That's essentially what collaborative filtering is. You're using patterns in everyone's choices to predict what you might like.
So if I rate a certain whiskey really highly and someone else with similar tastes does the same.
Exactly.
The system could then recommend other whiskeys that they enjoyed.
Precisely.
Yeah.
Yeah, it leverages those shared preferences to give you personalized suggestions.
Interesting.
It's like having a friend who knows your taste in whiskey, right?
Yeah.
And they recommend something new based on what other people like you enjoyed.
I like that.
Yeah.
And the same concept is used across platforms like Amazon and Netflix.
Okay, so that makes sense. It's like the system is finding a pattern in our collective choices.
Yeah.
But how do companies like Amazon and Netflix, how do they actually implement this?
Right.
I mean, their recommendation engine seems so sophisticated.
They are sophisticated. They use algorithms often based on what we call latent dimensions.
Latent dimension.
Yeah, you can think of them as these like hidden factors that influence our preferences. It's like
So instead of just recommending products based on basic categories,
Right.
it's identifying these deeper connections based on these hidden taste dimensions.
yeah,
right?
exactly. It's uncovering those unspoken preferences that kind of drive our choices.
Okay.
For instance, with movies, a latent dimension could be like dark humor or visually stunning cinematography.
Right.
So, it goes beyond just genre classifications to
Right.
capture those subtle elements that really resonate with viewers.
That's really incredible. It's
Yeah.
like the algorithm is peeling back the layers to understand what we really enjoy,
Mm-hmm.
but building a system that can accurately capture those subtle preferences, I mean, that must be incredibly challenging.
You're absolutely right. One major challenge lies in capturing the nuances of personal taste.
Yeah.
Everyone's preferences are unique, and they can evolve over time.
So how do these systems, how do they deal with the fact that our tastes aren't like static?
Right.
I mean, my favorite genre of movies might change.
Yeah. Yeah.
as I experience new things,
Yeah, that's a key challenge data scientists grapple with.
Yeah.
People's tastes are so dynamic, influenced by new experiences, trends,
Right.
even things like the weather.
Wow.
So a good recommendation system needs to be adaptable and adjust to these changes. It's a constant process of learning and refinement.
Yeah.
Yeah.
It's like the system needs to have a built-in sense of intuition
Uh-huh.
to keep up with our evolving preferences.
Exactly.
But, besides keeping up with our changing tastes,
Right.
what are some other difficulties in building a good recommendation system?
Well, one critical challenge is dealing with what we call data sparsity.
Data sparsity.
Yeah, imagine a brand new user on Netflix, right?
Oh.
They haven't rated any films yet. So the
Right.
system has very little information to work with.
Okay.
This is also known as the cold start problem,
Okay.
figuring out what to recommend when you have limited data on someone's preferences.
That makes sense. It's like trying to recommend a book to someone who's never read anything before.
Exactly.
Where do you even begin?
Right. And this problem becomes even more complex when you consider the vast number of users and items these platforms have.
Yeah.
You're dealing with a massive amount of data constantly changing.
It sounds like building these systems requires this delicate balance
Yeah.
of data analysis,
Right.
algorithmic design,
Yeah.
and an understanding of human behavior.
You hit the nail on the head.
Wow.
It's a fascinating field.
Yeah.
And there are constant innovations as data scientists strive to create systems that are more accurate, personalized, and relevant.
This has been really enlightening.
Good. Yeah.
We've learned how collaborative filtering uses our collective choices to make these personalized suggestions, and how companies like Amazon and Netflix utilize these systems.
Yeah.
And then we've explored the challenges
Right.
of creating systems that are adaptable
Yes.
and can handle the complexities of this data sparsity.
Yeah.
It's been a pleasure diving into these concepts with you,
Likewise.
and I hope our listeners have gained a deeper appreciation for the intricate workings of recommendation systems.
I hope so.
I'm sure they have.
Good.
But we're not done yet.
No, not at all.
So stay tuned as we delve even deeper into the world of recommendation systems, including how these algorithms learn and evolve. And don't forget to like, share, and subscribe
Yes.
for more deep dives into the world of data.
Absolutely. So we've talked about how these systems identify patterns
Right.
and adapt to evolving preferences. Now let's explore the heart of these recommendation systems.
Okay.
The algorithms.
Okay.
One way these algorithms learn is by finding informative attributes.
Informative attributes.
Yeah, the bits of data that are most helpful in predicting your preferences.
Okay, so it's not just about looking at what I've rated or purchased,
Right.
but about understanding which aspects of those choices
Exactly.
are most revealing about my tastes.
Exactly. It's about finding the signal in the noise. Right.
Okay.
So, for example, knowing you've watched a lot of action movies is helpful, but knowing you specifically enjoy action movies with strong female leads,
Right.
that's much more informative.
Okay.
That additional detail helps the system really refine its understanding of your preferences.
So it's like the algorithm is playing detective.
Yeah.
looking for those clues that reveal the underlying patterns
That's a great way to put it.
in our choices.
Yeah, and as the system gathers more data, it gets better and better
Right.
at identifying these key attributes
Okay.
and making more accurate predictions.
But with all this data crunching,
Yeah.
there's a potential danger, right?
Sure.
What about the risk of overfitting,
Yeah.
where the system becomes too focused on the data it's been trained on
Right.
and doesn't generalize well?
That's a crucial point. Overfitting is a constant challenge for data scientists. It's like studying for a test by only memorizing the answers to last year's exam.
Oh,
You might ace that specific test,
right.
but you won't truly understand the material,
Right.
and you won't perform well on a new exam.
So how do data scientists prevent this overfitting
Right.
from happening in recommendation systems?
Well, they have some clever techniques up their sleeve.
Okay.
One common approach is using what we call holdout data.
Holdout data.
Yeah, essentially a portion of the data set aside
Okay.
and not used to train the algorithm.
So it's like a test run for the algorithm,
Exactly.
making sure it can apply what it's learned to new situations.
Exactly. The holdout data acts as a reality check.
Uh-huh.
If the system performs well on this unseen data,
Right.
it's a good indication that it's not just memorizing patterns,
Okay.
but actually learning and generalizing.
That makes a lot of sense.
Yeah.
Are there other ways they combat overfitting?
Absolutely. Another powerful technique is called cross-validation.
Cross-validation.
Imagine dividing the data into multiple folds,
Okay.
like slices of a pie, right?
Yeah.
The algorithm is trained on some of these slices
Okay.
and tested on the remaining ones, rotating which slice is used for testing each time.
So it's like giving the system multiple practice tests
Exactly.
with different questions each time
Precisely.
to make sure it's truly learning the material.
Yeah, by averaging the results from these different tests,
Okay.
data scientists get a more robust measure of how well the algorithm is generalizing.
It seems like there's this constant push and pull
Yeah.
between learning from the data
Right.
and making sure the system doesn't become too specific
Right.
to the examples it's seeing.
Exactly. That's where the artistry and expertise of data scientists comes in.
Yeah.
They need to understand the data, choose the right algorithms,
Right.
and carefully tune and refine the models to create a system
Yeah.
that delivers accurate and meaningful recommendations.
It's truly remarkable how much goes into building these systems. We've covered collaborative filtering,
Mm-hmm.
latent dimensions,
Yeah.
the importance of finding informative attributes,
Right.
and these challenges of overfitting,
Absolutely.
all this complexity working behind the scenes
Yeah.
just to suggest what we might like.
It's a fascinating field.
It is.
And as technology evolves, these systems are becoming more sophisticated
Right.
and integrated into our lives.
Speaking of evolution, what are some trends or advancements on the horizon
Okay.
for recommendation systems? What's the future of personalized suggestions?
Well, one exciting trend is the move towards even more personalized and contextual recommendations.
Okay.
It's not just about what you've liked in the past,
Mm-hmm.
but also about your current situation, mood, and even location.
So instead of just recommending the same type of book I always buy,
Right.
it could take into account the fact that I'm going on vacation.
Exactly.
That it's a rainy day.
Precisely. Imagine a system that knows you're at a concert and suggests songs from the band you're seeing,
Wow.
or a travel app
Yeah.
that recommends cozy cafes
Oh,
because it's
yeah.
raining outside.
Okay.
That level of personalization is becoming increasingly possible.
That's incredible.
Yeah.
It's like having a digital concierge anticipating your needs based on your context.
Exactly.
What other advancements are you excited about?
Well, the integration of artificial intelligence,
Okay.
especially machine learning, is transforming recommendation systems. We're seeing algorithms that can learn from increasingly complex patterns in the data
Right.
and adapt recommendations in real time.
So it's not just about static rules anymore,
Right.
but about systems that are continuously evolving and learning
Exactly.
as we interact with them.
Yeah, and as these systems become more intelligent,
Uh-huh.
they can play a more active role in shaping our experiences,
Okay.
helping us discover new things
Right.
that we wouldn't have found on our own.
They're becoming more like partners in exploration.
Yeah.
Rather than just tools for fulfilling existing desires.
I like that.
But with all this advancement,
Mm-hmm.
we need to be mindful of potential downsides.
Absolutely. As these systems become more powerful,
Yeah.
we need to ensure they're used responsibly and ethically.
This has been a truly insightful conversation.
Good, good.
It's amazing how much complexity goes into something
I know.
as seemingly simple as a recommendation.
Yeah,
But that's the magic of data science, right?
it is.
Uncovering these hidden patterns.
Yeah.
And using them to create experiences that are both personalized and engaging.
I completely agree. And as these technologies continue to evolve, it's crucial to understand how they work
Yeah.
and the impact they have on our lives.
Well, before we wrap up our deep dive
Okay.
into this fascinating world of recommendation systems,
Yeah.
I'd love to hear your final thoughts
Sure.
on the future of these systems.
I think the future holds even more seamless integration of these recommendations into
Right.
our daily lives. Like, imagine smart homes that adjust temperature and lighting
Right.
based on your predicted preferences.
Wow.
Or cars that suggest routes and music based on your mood and destination.
That sounds like something straight out of a sci-fi movie.
It does, doesn't it?
It's incredible to think how personalized these systems could become.
Yeah.
But won't this level of integration raise some concerns about privacy and data security?
Sure.
And these systems rely so heavily on our personal information.
You raise a valid point.
Yeah.
As recommendation systems become more sophisticated and intertwined with our lives, protecting privacy and ensuring responsible data use,
Right.
it's going to be paramount.
Yeah.
Transparency and user control over data are going to be crucial for building trust and fostering ethical development.
That makes sense. It's like a balancing act between personalization
Yeah.
and safeguarding our privacy.
Uh-huh.
But aside from these concerns, are there any other challenges you foresee in the future of these systems?
One challenge will be ensuring diversity and preventing the creation of filter bubbles.
Double bubbles.
As these systems get better at predicting our preferences,
Yeah.
there's a risk they might only expose us to information and content that aligns with our existing views,
Right.
limiting our exposure to new perspectives and ideas.
So it's like getting stuck in an echo chamber
Exactly.
of our own tastes.
Yeah.
Which could actually hinder personal growth and limit our understanding of the world.
Exactly. Striking a balance between catering to individual preferences and encouraging exploration of diverse viewpoints.
Right.
That's going to be key to creating recommendation systems that are both engaging and enriching.
This has been a truly eye-opening deep dive
Yeah.
into this world of recommendation systems.
It has been, yeah.
We've uncovered how collaborative filtering and latent dimensions drive personalization. We explored the challenges of data sparsity and overfitting, and even pondered the future of these systems.
Absolutely.
It's been a real pleasure unraveling these complexities with you.
Likewise.
The ability of these systems to understand our preferences and predict our needs, it's truly remarkable.
It is.
Well, I'd say our mission to understand recommendation systems has been a success.
I agree.
And a huge thanks to our listeners for joining us on this journey.
Yes, thank you.
We hope you found it as insightful and thought-provoking as we did.
Absolutely. And if you'd like to explore this topic further, there are numerous resources available online.
Right.
And of course, stay tuned for more fascinating deep dives into the world of data.
And don't forget to like, share, and subscribe to The Deep Dive
Yes.
for more insightful explorations into the world of data and algorithms.
Absolutely.
Until next time. All right, so today we're diving into something that I think affects us all, really fraud detection. And I know you're an expert in this field.
I tried to be.
So I'm really curious to learn more about how data science is being used to combat fraud, especially in the financial world.
Right.
And I know our listeners are familiar with relational databases.
Okay.
So we can build on that knowledge
Sure.
to explore some really fascinating applications, I think.
Yeah, it's definitely a hot topic.
Right.
It's crucial these days.
Yeah. So how are banks using data science to detect fraud in the first place?
Well, you know how you see those ads online, like those targeted ads? Banks are doing something similar.
Okay.
They're trying to predict whether a transaction, is fraudulent or legitimate.
I was trying to figure out what's going to happen
Yeah,
before it does.
exactly.
Oh, wow.
And the challenge is
Yeah.
fraudulent transactions are pretty rare
Right.
compared to all the millions of legitimate ones happening. Right, yeah.
It's like finding what is it?
A needle in a haystack.
Beetle in a haystack, yeah.
That's a good analogy. So how do they even begin to tackle that problem?
Well, banks, luckily,
Yeah.
collect tons of data
Right.
on every transaction.
Okay.
The amount, the location, the time, even customer demographics.
Right.
All that's stored in their databases.
And I imagine that is really useful in identifying suspicious activity.
Absolutely.
Yeah.
It's all used to build what we call predictive models.
Okay.
Looking for patterns, anomalies, things that might indicate fraud.
Can you give an example of what kind of pattern might raise a red flag?
Okay, let's say your credit card is suddenly used
Okay.
for a large purchase in a country you've never even been to.
Oh, yeah.
That would be a pretty big indicator
right.
of fraud, right?
Yeah, that would be really suspicious.
Yeah.
So they're basically building this profile of what normal behavior looks like.
For each customer.
Right.
And then flagging anything that deviates from that.
Yeah.
Oh, that's interesting.
One way we do this is with supervised segmentation.
Okay.
Which is basically just grouping similar transactions together based on different factors, and anything outside those groups is flagged.
Oh, that's fascinating.
It's pretty cool, right?
How they can use data to pinpoint those unusual activities.
Yeah. One of the earliest examples of this is actually pretty interesting.
Oh.
Signet Bank, which became Capital One later on, back in the year 2000.
Wow, okay.
They were already using data-driven models
Wow.
to detect credit card fraud.
Yeah.
They were running, get this, 45,000 tests.
45,000.
45,000 tests to refine their methods.
Wow, they were really ahead of the curve.
They were.
When it came to data for fraud detection.
Yeah, it really shows how valuable it can be.
Okay, so we've talked about how banks use vast amounts of data to spot unusual patterns. But what are these anomaly detection techniques I keep hearing about?
Yeah.
How do those work?
So anomaly detection is all about finding those needles, those unusual events that don't fit the normal pattern.
Okay.
And you can think of each transaction like a data point
Okay.
in a massive relational database, like the ones you're familiar with.
Right, yeah.
So how do we identify the anomalies within all that data?
Yeah, how do they do that?
So imagine you're grouping these data points
Okay.
based on their features, okay?
Uh-huh.
This is called clustering. Transactions that have similar characteristics,
Yes.
like small, frequent purchases at the grocery store, those would form a cluster.
Okay.
Makes sense.
So far, so good.
Okay.
Yeah.
Now, the transactions that fall far outside these clusters,
Uh-huh.
those are flagged as potential anomalies.
Okay.
Like, imagine frequent small ATM withdrawals
Okay.
from your account in a different city.
Yeah.
That's a classic fraud indicator.
Right, because that would stand out as unusual compared to my normal activity.
Exactly.
Yeah.
And to do this, banks use really cool techniques.
Okay.
One of them is called Gaussian mixture models,
Gaussian mixture model.
or GMMs.
GMMs, okay.
They essentially learn the shape of normal behavior,
Okay.
and they flag anything that deviates significantly from that.
It's amazing how these models can just sift through mountains of data
Right.
and pick out those really unusual transactions.
It is pretty amazing.
Yeah, it highlights the power of data science
It does.
in this field.
And this is just the tip of the iceberg.
Really?
Yeah. There are even more advanced techniques being developed all the time.
Wow.
But before we get into those,
Okay.
let's look at some real-world examples
Okay.
of how AI is already being used to prevent fraud in action.
I'm excited.
Let's do it.
Mm-hmm.
So, welcome back to our deep dive into the world of fraud detection using data science.
I'm so curious to hear about those real-world applications you mentioned.
Yeah.
How AI is being used to stop fraud in action.
Well, one of the most exciting developments
Okay.
is real-time fraud detection.
Real time.
Wow.
So imagine this. You're at the store,
Mm-hmm.
about to buy something.
Yeah.
In milliseconds,
Milliseconds.
the system's analyzing your transaction,
Wow.
comparing it to your habits, location, even your recent online activity.
Wow. That's incredible.
Yeah,
It sounds really efficient.
it is.
But wouldn't that slow things down?
That's the cool thing about AI.
Okay.
It's lightning fast.
Oh, okay.
You wouldn't even notice a delay.
That's amazing.
He's pretty cool, right?
What else can AI systems do
Yeah.
that traditional methods couldn't?
One of the biggest advantages is adaptability.
Okay.
Fraudsters are always changing tactics.
Right.
Trying to stay ahead.
Yeah.
Rule-based systems struggle to keep up, but AI adapts much faster.
So it's like a constant arms race
Yeah, kind of.
between the AI and the fraudsters,
Yeah.
always trying to stay ahead.
But AI has a big advantage.
Okay.
It can analyze massive data sets,
Okay.
spot patterns humans would miss.
That's incredible.
It can even predict trends
Wow.
before they become widespread.
So it's like predicting the future.
Kinda, yeah.
How do they use AI to predict these trends?
One technique is link prediction.
Link prediction, okay.
It's from social networks.
Oh, interesting.
Imagine predicting who will become friends
Okay.
based on connections, interests.
Mm-hmm.
See where I'm going?
So they apply similar techniques to financial networks,
Exactly.
looking for suspicious connections
Right.
between accounts.
Yeah, like if several accounts
Okay.
that have never interacted
Right.
suddenly start transferring money,
Mm-hmm.
that could be coordinated fraud.
Right.
AI picks up on that.
It's like connecting the dots,
Yeah, that's a great analogy.
but on a grander scale.
Right, and AI takes it further.
Really?
Some companies are using it
Okay.
to analyze news stories
I'm sorry.
and social media posts to detect market manipulation.
Wow. That's incredible.
Imagine a company's stock price
Oh.
suddenly skyrockets.
Mm-hmm.
AI could detect a campaign of fake news and social media
Yeah.
to inflate the price.
It's like they're using AI to read the news
Right.
and predict the future.
Not quite predicting the future,
Okay.
but getting much better
Yeah.
at understanding the present
Okay.
and anticipating risks.
That's fascinating.
Yeah, it's a huge leap forward.
It seems like AI is pushing the boundaries
It is.
of what's possible in fraud detection.
Yeah,
But I imagine there are challenges
absolutely.
in building these systems.
One challenge is overfitting.
Overfitting. Okay.
That's when a model fits the data too well.
Okay.
It memorizes it
Oh, okay.
instead of learning the patterns.
So it's like a student
Yeah,
who memorizes all the answers for a test,
exactly.
but doesn't understand the material.
Right, and that model will do poorly
Right.
when faced with new data.
Okay.
It can't generalize.
I can see how that would be a problem,
Yeah,
especially in fraud detection,
right.
where you constantly need to adapt.
Right, so how do we prevent that?
Yeah, how do they do that?
One technique is cross-validation.
Cross-validation, okay.
Imagine you have a data set
Mm-hmm.
of 1,000 transactions.
Okay.
Instead of using 700 for training
Right.
and 300 for testing,
Yeah.
you divide it into 10 equal parts.
Okay.
You train on 9,
Hmm.
test on the remaining 1,
Okay.
and repeat 10 times.
So you're giving the model a chance to practice
Yeah,
on different parts of the data
exactly.
and then see how it performs
Right,
on data it hasn't seen before.
you got it.
That makes a lot of sense.
It helps avoid overfitting.
Okay.
It's a really useful technique.
It seems like data science is a powerful tool
It is.
for understanding the world,
Yeah,
especially for complex issues
right.
like fraud detection.
It's really helpful.
So far, we've focused on individual transactions
Mm.
and patterns of behavior. But are there ways to use data science
Yeah,
to identify broader connections
sure.
or associations
Yeah.
that might indicate fraud?
There are. One interesting concept is called lift.
Lift. Okay.
It's often used in association mining.
Okay.
Lift measures how much more likely
Mm-hmm.
two items are to occur together
Okay.
than by chance.
Okay.
It's used in market basket analysis,
Market basket analysis. Okay.
where retailers try to understand
Mm-hmm.
which products are bought together.
So like the classic example
Yeah.
of diapers and beer
Exactly.
being purchased together.
That's the one.
Yeah.
That information is valuable
Yep.
for retailers
Yeah.
to optimize placement and marketing.
Right. But how could that be applied to fraud detection?
That's a good question,
Yeah.
I think.
Yeah.
Well, if you could identify a transaction
Okay.
that's frequently associated with fraudulent accounts,
Yeah.
like let's say transferring money to a specific country
Okay.
is often linked to fraudulent accounts. By identifying those associations
Yeah.
with high lift,
Mm-hmm.
we can create rules or models
Okay.
to flag those transactions.
So it's like saying if we see this combination of events,
Right.
something fishy is going on.
That's a great way to put it.
Yeah.
It highlights how seemingly unrelated data
Mm.
can be connected
Yeah.
to reveal patterns and risks.
That's really interesting.
It is, but we've covered a lot today.
Yeah.
We'll continue our exploration in our next segment.
So we've been talking about lift
Right.
and how these seemingly unrelated events
Yeah.
can actually be strong indicators of potential fraud.
It's amazing what you can find
Yeah.
when you look at the data.
And that leads us to another interesting concept in data science,
Mm-hmm.
which is profiling.
Profiling, yeah.
I usually associate that with like psychology or criminal investigations.
Sure.
How does that apply to fraud detection?
So in data science,
Okay.
profiling means
Mm-hmm.
creating a representation
Okay.
of normal behavior
Okay.
based on the data.
Right.
Anything that deviates
Yeah.
raises a red flag.
So instead of focusing on specific rules or associations,
Right, yeah.
we're building a broader picture
Exactly.
of what's expected.
Yeah, imagine a bank wants to understand spending habits.
Okay.
They collect data on everything.
Uh-huh.
Transaction amounts,
Right.
merchant types, locations, times of day.
Yeah.
They build a profile
Okay.
of what typical spending looks like.
So if a customer
Yeah.
suddenly starts making purchases
Right.
that are way outside their normal profile,
Exactly.
that would be a cause for concern.
Big red flag, for
Right.
example. If
Good.
someone who usually makes small local purchases suddenly buys luxury goods
Right.
online
Yeah.
from another country,
Yeah. That seems suspicious.
that's a strong indication of fraud.
It's like a sudden change in behavior.
Yeah.
Something
Yeah.
just doesn't add up.
Right.
But how do we create these profiles?
So one common approach is to use statistical models,
Okay.
like Gaussian distributions.
Gaussian distributions.
These models describe the probability of different values
Okay.
based on the shape of the data.
So if most customers spend
Yeah,
between, say, $50 and $200 per week,
right.
that would be represented as a peak
Exactly.
of the Gaussian curve.
The peak in the curve, yeah.
And anything far from that peak,
Mm-hmm.
like a $10,000 purchase,
That's right.
would be a statistical anomaly
A big anomaly.
and more likely to be fraudulent.
Exactly. It's like identifying outliers.
Okay.
And there are even more sophisticated techniques,
Oh, really?
like Gaussian mixture models
Oh,
or
cool.
GMMs,
Uh-huh.
which can create profiles for different subgroups.
Oh, interesting.
So you could have one
Okay.
profile for frequent online shoppers
Right.
and another for occasional local shoppers.
Yeah, that makes sense.
Yeah, it allows for more nuanced and accurate detection.
This is all so fascinating.
It is cool stuff.
It seems like data science is
Yeah.
constantly pushing the boundaries
It is.
of what's possible
Mm.
in fraud detection.
It's a rapidly evolving field.
And the beauty of it
Yeah.
is that these same techniques
Right.
can be applied to so many problems, not just in finance.
We can use it for everything.
Wow.
Manufacturing, network traffic,
Yeah.
even social media behavior.
So the possibilities are really endless.
They really are.
Wow, this has been such an insightful deep dive.
Glad you enjoyed it.
I'm amazed by how data science
Yeah.
is being used to combat fraud.
It's a powerful tool.
Thank you so much
You're welcome.
for sharing your expertise.
Happy to do it.
And to our listeners,
Yes.
if you enjoyed this deep dive
Mm-hmm.
into the world of fraud detection
Yeah.
using data science,
Right.
please like, share, and subscribe
Yeah, we'd appreciate it.
to the deep dive
Definitely.
for more fascinating explorations of knowledge.
Always exploring.
We'll see you next time.
See you then.
All right, so today we're going to dive deep into representing and mining text.
Yeah,
And, you know, our listeners are already pretty familiar with relational databases,
absolutely.
but we're kind of taking it up a notch today to see how we can extract meaning from all this text data.
It's everywhere.
Yeah, exactly. It's everywhere these days.
So think about medical records, customer reviews.
Oh, yeah.
News articles. All of that is text.
Right.
But just throwing that into a database isn't going to give you much insight.
Okay.
The real magic happens when we can teach a computer to understand what that text actually means.
So how do we go about doing that?
That is a great question.
Yeah.
So how do we represent text in a way that computers can understand?
Yeah. Why is that so important for data mining?
Well, think about it like this.
Okay.
You're trying to bake a cake, right? But you have all these raw ingredients
Okay.
and no recipe, no instructions.
I see.
You need some sort of structured approach
Yeah.
to process those ingredients, that text data, so that you can actually analyze it and get something meaningful out of it.
So we need to give the computer a recipe.
That's a great way of putting it.
Yeah.
Yeah, a recipe for understanding language.
Okay. Okay.
One of the most basic techniques is called the bag of words approach.
Bag of words.
Yeah, have you heard of this?
I've heard of it, but I'm not really sure how it works.
Okay, so imagine you're making one of those word clouds,
Okay.
where the size of each word represents how often it appears in a text.
Okay, yeah, I've seen those.
So essentially what the bag of words approach does is it just counts how many times each word shows up without really worrying too much about the order they're in or the context.
So it's just a word frequency table
Pretty much.
for a document.
Yeah.
Yeah.
And it might seem a bit simplistic,
Right.
but it can actually be really powerful, especially for tasks like sentiment analysis. So imagine you want to analyze a bunch of customer reviews
Right.
and see if they're generally positive or negative. Bag of words can pick up on those vibes just by the frequency of certain words.
But couldn't that miss some nuance?
You're exactly right.
Yeah.
Like, for instance, if someone says, this movie's not bad,
Right.
that's not exactly a glowing review,
No, not at all.
even though it uses the word good.
Right, right.
So that's where TF-IDF comes in.
DCAF ideas.
Yeah, it stands for Term Frequency Inverse Document Frequency.
Okay, I'm going to need you to break that down for
Okay, sure.
Yeah.
So TF-IDF adds a layer of sophistication.
Okay.
It considers not just how often a word appears in a single document,
Right.
but also how rare that word is across a whole collection of documents.
Okay.
So let's say you're analyzing a bunch of news articles.
Okay.
The word "the" will probably appear a lot in each one, right?
Yeah, of course.
But it's not very helpful in understanding what makes each article unique.
Yeah, the is just a common word.
Exactly.
Doesn't tell us much about the topic.
But if you see a word like cryptocurrency appearing frequently
Okay.
in one article but rarely in others,
That's a good indicator that this particular article is probably about cryptocurrency.
So TF-IDF helps us identify those keywords.
Exactly.
So, yeah.
The words that really define the core topic or theme
Right.
of the document.
That's pretty clever.
Yeah.
So how do we actually use these TF-IDF values?
Think of them like a spotlight,
Okay,
highlighting the most important words.
I like that analogy.
Yeah.
Okay.
So you can use them to compare documents and see how similar they are thematically.
Okay.
This is really valuable for things like search engines
Oh.
or recommendation systems.
So if I search for, say, best biryani in Delhi,
Yeah.
a search engine using TF-IDF
Right.
would prioritize websites that have a high frequency of those words,
Yes.
but also consider how rare those words are across all websites.
Exactly.
Oh, okay.
It helps fine-tune the search.
That makes sense.
Yeah.
To get the most relevant results.
Right.
Cool.
But what if we want to go beyond just analyzing individual words?
Yeah, where do we go from there? Yeah, what if we want to understand the broader topics
Right.
covered in a collection of documents?
Okay.
That's where topic models come in.
Topic models.
Yeah.
Okay.
They take a step back
Right.
and they try to identify the underlying themes or topics
Okay.
that connect a group of documents.
Mhm.
So instead of just looking at the words themselves,
Right.
they look at how those words co-occur and cluster together.
Interesting. Can you give me an example of how that works?
Sure.
Yeah.
Imagine you have a collection of articles
Yeah.
about Indian cuisine.
Right.
Some articles might focus on specific dishes,
Like biryani.
like biryani, exactly.
But dosa crew.
Yeah.
Right.
Others might discuss regional cuisine.
Right. Like South Indian.
Yeah.
Okay.
Right.
Or Punjabi food.
So even though the word food might appear in all of them,
Right.
the underlying themes are different.
Exactly.
Okay.
A topic model would be able to analyze those patterns of words that appear together.
And cluster those articles into different topics.
Okay.
Like biryani recipes, South Indian cuisine, or Punjabi food.
So it's like grouping the articles together
Yeah.
based on their thematic similarity,
Exactly.
even if they don't use the same keywords.
You got it.
That's really interesting.
And this is incredibly valuable for things like document organization,
Oh, okay.
content recommendation, even understanding customer feedback on a larger scale.
Okay.
So we've gone from analyzing individual words to
Right.
understanding these broader themes.
Yeah, it's like zooming out
Yeah,
to get a bird's eye view of the information.
absolutely.
Wow.
So we've covered a lot here. Maybe we should pause and reflect.
Yeah, that's a great idea.
Yeah,
Let's take a quick break and come back with more on representing and mining text.
sounds good.
And hey, if you're finding this deep dive helpful, don't forget to like, share, and subscribe to the deep dive for more insightful explorations into the world of data science.
Absolutely.
We'll be right back.
All right. So welcome back to the deep dive.
Now that we've got a handle on the basics,
Yeah.
let's see how this knowledge can be applied to real-world problems.
Absolutely. That's the fun part.
Right, yeah.
So you mentioned earlier that topic models could be used to understand customer feedback.
Yeah, I'm really curious about that.
It's a really powerful application.
Yeah.
So imagine you're a company and you've just launched a new line of smartphones here in India.
Right.
You're getting tons of feedback online,
Oh, yeah.
reviews, social media posts, forum discussions.
A lot of data.
It's a goldmine of information.
Right.
But how do you make sense of it all?
You can't read everything,
Right. It would be impossible to read every single comment,
especially with the volume we're talking about.
especially if you're getting thousands or even millions of responses.
Exactly.
And that's where topic models come in.
Okay.
They can sift through all that text data
Right.
and automatically cluster feedback into different themes.
Oh.
So things like battery life, camera quality, price, design.
So you can see at a glance what people are talking about and how they feel about it.
Yeah, you get a clear overview of the main topics
Right.
and the sentiment around each one.
So instead of getting lost in a sea of individual comments,
Right.
you get a more structured understanding.
Exactly. You turn that raw data into actionable insights.
That's pretty powerful.
It is. And think about the implications
Yeah.
for product development.
Right.
Let's say you see a lot of negative feedback clustered around battery life. That's a clear signal
Yeah.
to focus your efforts on improving that aspect
Okay.
in the next iteration of your product.
So you're essentially using topic models
Right.
to drive product development.
Yeah, you're using data to make informed decisions.
That's really cool.
And it applies to so much more than just product development.
Oh, like what else?
Think about political campaigns analyzing social media sentiment.
To understand public opinion?
Exactly. Or news organizations using topic models to track trending news stories.
So it's really about understanding
Yeah.
what people are talking about.
It's like having a finger on the pulse of the conversation.
That's a great way to put it.
Yeah,
Okay, so we've talked a lot about the benefits,
right.
but are there any potential drawbacks?
Of course, there are always limitations.
Right.
One thing to keep in mind is that these methods rely on identifying patterns in language.
Okay.
But language is complex.
Yeah, for sure.
And sometimes those patterns can be misleading.
Like, for instance, if someone's being sarcastic.
Exactly. A bag of words approach wouldn't be able to detect that.
Right. It would just see the words,
It would just see the word.
not the intent.
Exactly.
Okay.
So it's important to remember that these are just tools
Mm-hmm.
and they need to be used thoughtfully.
Right, with the human eye.
Exactly. Always consider the context.
Yeah.
And don't blindly trust the output, any algorithm.
So it's like any powerful tool. It could be used for good or for bad.
That's a great analogy.
Yeah.
It depends on the intention and the skill of the user.
Right, right.
It's important to understand the limitations
Yeah.
and use it responsibly.
This has been fascinating.
It's a really interesting field.
It is.
Yeah.
So we've gone from the fundamentals of representing text
Yeah.
to exploring its real-world applications.
Right.
And even some of the potential pitfalls.
We've covered a lot of ground.
We have.
Yeah.
Do you have any final thoughts you'd like to share?
Well, I think it's important to emphasize that this is a rapidly evolving field.
It really is. It's amazing to think about all the things that we can do with this.
Oh, yeah, for sure.
So we talked about, understanding customer feedback,
Right.
tracking trends, but what about some of the more cutting-edge stuff?
Yeah, the really exciting stuff.
Yeah, where's this field headed?
Well, one area that's really exploding right now is the use of text mining in AI.
AI, okay.
Yeah, particularly in natural language processing.
NLP, I've heard that term a lot lately.
It's everywhere these days.
Yeah.
So in the simplest terms,
Okay.
NLP is all about enabling computers to understand and process human language.
So when I ask Siri for directions
Right.
or get a quick translation on Google Translate,
That's NLP.
that's NLP in action.
Exactly.
Yeah.
And text mining plays a key role in this by providing the tools and techniques for extracting meaning from all that text data.
So it's like the foundation
Kind of, yeah.
Yeah.
It's the raw material.
upon which these smarter AI systems are being built.
That's a great way of putting it.
Okay.
And as those techniques continue to evolve, we can expect even more sophisticated AI applications
Right.
that can understand and interact with us in a more human-like way.
That is exciting.
Yeah, it is really cool.
But with all this talk about AI,
Yeah,
it's easy to get carried away with the hype.
it's true.
Are there any limitations we should be aware of?
Absolutely.
Yeah.
One of the biggest challenges in NLP is dealing with ambiguity. The complexity of human language.
Right, like sarcasm.
Sarcasm, exactly.
Okay.
Cultural references, all that stuff.
Yeah?
Those are all things that can really trip up even the most advanced algorithms.
So even though we're making a lot of progress,
Yeah,
we're still a ways away from AI that can truly understand us.
I think that's right.
Yeah.
It's important to remember that language is more than just a collection of words. It's a reflection of our thoughts, our emotions.
Our culture.
Exactly. Capturing all of that nuance in an algorithm is a really complex task.
So we should be excited,
Definitely.
but also realistic about the limitations.
Yeah, a healthy dose of skepticism is always good.
Right.
Approach the technology critically.
This has been an incredible deep dive.
It has, yeah.
We've gone from the basics of representing text to exploring these cutting-edge AI applications.
It's amazing how far the field has come.
It is, and it seems like it's just getting started.
Oh yeah, the future's wide open.
Well, on that note, I want to thank you for joining us on this deep dive into the world of representing and mining text.
It's been a pleasure.
If you're listening out there and you're feeling inspired to dive deeper into this field, don't hesitate. There are tons of resources available online, and the possibilities are truly endless. And hey, if you found this deep dive insightful, don't forget to like, share, and subscribe to The Deep Dive for more fascinating explorations of data science. Until next time. Welcome back, everyone, to The Deep Dive. This time, we're going to be diving into decision analytic thinking.
It's super relevant, especially for those of you familiar with relational databases.
You've probably come across data-driven decisions in business a lot.
Whether that's marketing campaigns or even something as simple as credit card offers.
Right. And the cool thing is, you don't need to be some kind of data wizard to understand the basics.
Even a little understanding can help you evaluate projects, see where things might go wrong, and look deeper than just the surface-level solutions.
So let's get to the heart of it. Today, we're talking about expected value.
It helps you make sense of possible outcomes when you're making decisions in situations where things aren't certain.
Okay, so it's like a framework for dealing with uncertainty.
Exactly. Think of it as a way to measure uncertainty and assess potential risks and rewards.
Instead of just going with your gut feeling.
Exactly. And it's used all the time in the real world. Well, companies like Capital One use powerful analytics to decide who gets those credit card offers. Expected value plays a huge role there.
That's interesting. So is it better to be right most of the time?
Or is it more about avoiding those big, expensive mistakes?
That's a great question.
We're trying to figure that out today.
Okay, let's say we're trying to group customers based on how likely they are to cancel a service, what we call churn.
Yeah?
There are two main ways to do this.
Mm-hmm.
Supervised and unsupervised learning.
Right. With supervised learning, you've got what we call labeled data.
Meaning?
It means you already know which customers churned and which ones didn't.
Ah, I see.
The algorithm then uses this labeled data to learn how to predict churn for new customers.
So it's like giving the algorithm a cheat sheet.
Yeah, kinda.
But what about unsupervised learning?
That's like exploring a new city without a map.
Ugh.
You don't have any labeled data. The algorithm has to find patterns and group customers based on similarities in their behavior.
So it's like letting the data tell its own story.
Exactly. But the problem is, real-world problems are usually messy. They don't come all neat and organized, ready for analysis.
That makes sense. So how do we deal with that messiness?
Well, that's where the CRISP-Dean process comes in. Think of it as a structured approach or roadmap to tackling data-driven problems.
Okay, so it's like a set of steps to follow.
It all starts with understanding what the business is all about and then understanding the data itself. Those initial steps are crucial.
What if we've got loads and loads of data? How do we figure out what's actually important? It's like trying to find a needle in a haystack.
That's where we use informative variables. Think about predicting customer churn again. You might have a ton of information about each customer.
Not all of it will be equally useful, right?
Exactly. Informative variables are like signals amidst all the noise. They tell you something meaningful.
So how do we actually measure how informative a variable is?
There are specific ways to do that. Two key ideas are entropy and information gain.
Those sound pretty technical.
Well, imagine trying to figure out which mushrooms are safe to eat based on how they look. Their color, their stem shape.
I can see where this is going.
Entropy measures how random things are.
Okay.
If you have a basket full of different mushrooms, entropy is high. But if you sort them into edible and poisonous piles, entropy decreases.
So it's like going from chaos to order.
Precisely. Information gain tells you how much that sorting reduces the randomness.
Gotcha.
We measure how much each characteristic of a mushroom tells us about whether we can eat it or not.
So the higher the information gain, the more useful the characteristic.
That's the idea.
All right, let's say we've built a model. How can we be sure it's actually any good?
One thing to watch out for is overfitting.
What's that?
It's like the model has simply memorized the answers from the data it's seen before. It can't actually solve new problems. Imagine a churn prediction model that's just memorized past customer behavior. It might look amazing on the training data, but it'll completely fail when faced with new customers.
So it's like a perfect model that's actually a scam.
That's a good way to put it.
So how do we avoid falling for that scam?
We have to test our models on data they've never seen before. This helps us make sure they can handle new situations. One common technique is using what we call holdout data.
And what is that?
It's like splitting a deck of cards when you're trying to test out a card trick. You train your model on one part of the data and you test it on a separate part it's never seen before.
Ah, I see. So it's like having a control group in a science experiment.
Exactly.
But isn't accuracy the be-all and end-all? If the model is accurate, we're good, right?
Not necessarily. We also have to think about the costs of different kinds of errors.
What do you mean?
Well, imagine a model that's great at identifying people who are going to default on their loans,
Okay.
but it also mistakenly flags a lot of good customers as risky. The cost of those false positives can be really high.
So it's not just about being right. It's about understanding the consequences of being wrong.
Exactly. And that's where expected value comes back into play.
Right. We talked about it at the beginning.
It's not just about evaluating models. It's also about making smart decisions when you're facing uncertainty.
I'm starting to see the connections here.
It's about weighing the potential costs and benefits so you can make informed choices.
Okay, so let's go back to those credit card offers.
Yeah.
How does expected value actually guide decision-making in that situation?
Companies like Capital One use these models to try to figure out how likely it is that a customer will respond to a credit card offer.
And how much money they might make from that customer.
Right. But they also look at how much it costs to actually send out those offers, things like postage, marketing materials, and all that.
Makes sense.
By looking at all those factors, they can target their offers to customers who have the highest expected value.
So it's like they're playing a strategic game, trying to make the most profitable moves based on the information they have.
That's a great way to think about it.
And this is relevant for businesses everywhere, right? I mean, our listeners in India, they face similar challenges.
Absolutely. Understanding expected value can be a really powerful tool when you're making strategic decisions.
This is all starting to click. But before we wrap up this part of our deep dive, let's shift gears a bit and talk about how to actually design a solution for a business problem using this expected value framework.
Sounds good. Well, the first step is kind of breaking the problem down, into smaller, more manageable pieces.
Okay, so make it less overwhelming.
Exactly. You got to figure out what decisions need to be made.
And what might happen as a result of each decision.
Right. Like, what are the potential outcomes?
And then how likely is each outcome to actually happen?
Right. That's where things like historical data and predictive models come in. They're super helpful for estimating those probabilities.
So we're using data to make educated guesses about the future.
Exactly.
But why is it so important to really think about the costs associated with each outcome?
Well, costs can really change the whole value of your solution. Think about it. You could have two marketing campaigns that get similar responses. But if one is way more expensive to run, it's not as good, right?
Even if it seems fancier on the surface.
Exactly. The one that costs less will probably have a higher expected value.
It's not just about getting people to buy. It's about making sure it makes sense for the business financially.
That's the key. By factoring in costs, you're making smarter decisions. You're choosing solutions that are likely to give you the best overall results, not just in terms of outcomes, but also in terms of profitability.
This is giving me a whole new perspective on data-driven decision-making. It's not just about building complex models.
It's about really understanding the business, figuring out how to handle all that uncertainty, and considering both the good and the bad that can happen. It's about making choices that make sense.
So how does this expected value thing actually help us break down a problem, like really decompose it?
Okay, so imagine you're a marketing manager, maybe for a company here in India,
Right.
and you're launching a brand new smartphone. Expected value can be a really powerful tool for you in this situation. It can help you make sure the launch is a success.
Okay, I'm intrigued. Tell me more.
First things first, you got to know what you're trying to achieve. What are your goals for this launch?
I mean, obviously, we want to sell a ton of phones.
Sure, but is that the only goal?
Well, we want to make a big splash in the Indian market.
Oh.
Really increase awareness of our brand?
Okay, great. So you've got your objectives. Now let's break it down.
Break it down.
Yeah, what are the big choices you need to make to reach those sales and awareness goals?
Well, we need to figure out who we're targeting.
Yeah.
Like, who's going to buy this phone?
Right. And then,
How much should it cost?
Yeah.
What's the best price?
okay, good. What else?
How are we going to reach those people? What marketing channels will work best?
Okay, excellent. Anything else?
Maybe some special promotions to get people excited?
You got it. You've identified the key decision points. Now, for each of these decisions, we got to ask, what are the different things that could happen, and how much value is tied to each of those outcomes?
So like with pricing, we could price it really low to try and reach a wider audience. Or we could go for a higher price to make it seem more exclusive.
Exactly. And what would likely happen with each of those strategies? How would it impact your sales, your revenue, your profit? Think about all those things.
If we go low, we might sell more phones, but we won't make as much profit on each one. If we go high, we might sell fewer phones.
But you'd make more money on each sale.
Right. So we need to estimate the likelihood of each of those outcomes. What are the chances of selling a certain number of phones at each price point?
That's where historical data and market research come in handy. You can look at how similar products have performed in the past, check out what your competitors are doing, see what customers are saying. That gives you a sense of the potential demand.
So we're using data to make informed predictions about what might happen in the future.
Exactly. And you can even build predictive models to estimate those probabilities with even more accuracy.
But what about those promotional offers we were talking about? I mean, those could really sway people to buy.
Totally. Promotional offers are like another layer of complexity, but our expected value framework can handle it.
Okay, good.
You need to think about how much those offers will cost you and how much they'll actually boost sales.
So we need to figure out the expected value of each offer, taking into account both the potential increase in sales and the cost of running the promotion.
Exactly. It's all about finding the sweet spot, the point where the bump in sales from the promotion is bigger than the cost of running it.
This is like running simulations in our heads, playing out different marketing decisions and their possible consequences, and using expected value as our guide.
That's a great way to put it. By quantifying those potential outcomes, you're making better choices. You're choosing the path that's most likely to get you to your sales and awareness goals.
I like it. It's like we're turning marketing into a strategy game, using data and expected value to make the best moves.
I like that analogy.
So how does this all relate to analytical engineering? It sounds super technical.
Well, analytical engineering is about designing the whole solution to a business problem.
From start to finish.
Yeah, taking into account all the data, all the tools, all the techniques that are out there.
So it's like being an architect, but for data-driven solutions.
Yeah, exactly. You got to think big picture.
Consider all the moving parts.
And expected value plays a key role in that whole design process.
How so?
Well, it helps you evaluate all the different options.
See which one's most likely to deliver the best value. It's not just about building fancy models. It's about actually solving real-world problems with data science, making a real difference in the business. This is all making a lot of sense. But sometimes I think we get caught up in finding the perfect solution. And we forget about how much it'll actually cost to put that solution into practice.
Oh, yeah. That happens all the time. You can have the best churn prediction model in the world, but if it needs a massive investment in technology and specialized people,
And that cost outweighs the benefits.
it might not be the right solution for the business.
So we need to be practical about the cost of the solution itself, like a cost-benefit analysis for our data-driven solutions.
Exactly. You have to weigh those potential benefits, like the improvements you're hoping to achieve, against the costs of making it all happen. You got to make sure the investment is worth it.
Wow, this deep dive has been awesome.
Glad you're enjoying it.
I feel a lot more prepared to tackle data-driven problems now. It's not just about having technical skills. It's about having a new way of thinking.
It's about using data to make better decisions.
And the best part is, you don't need a PhD to understand it.
Right. Expected value, breaking down problems, weighing costs and benefits. Anyone working with data can use these ideas. What's amazing is that these simple ideas can have such a big impact.
Yeah. It's about knowing what questions to ask, understanding what data can and can't tell you, and just thinking critically. This has been an amazing deep dive. I feel like we've gone way beyond just data and algorithms.
We've explored a whole new way of thinking about business problems.
It's about moving from gut feelings to data-driven insights, using a framework to make smarter choices when things are uncertain.
Exactly. And you don't have to be a data scientist to use these concepts.
Anyone working with data can benefit from this. Expected value, breaking down problems, thinking about costs and benefits, it's all super useful.
It's incredible how these simple ideas can make such a big impact on decision-making.
It's all about asking the right questions, understanding what data can and can't tell you, and thinking critically. This deep dive has really opened my eyes. Decision analytic thinking is so much more than just the technical stuff.
It's a whole new mindset, a whole new way of approaching problems.
And making decisions. It can transform businesses.
Absolutely. It's been great chatting about this with you. Remember, data is a powerful tool, but it's up to us to use it wisely. Think about the impact it can have.
On that note, we've come to the end of our deep dive into decision analytic thinking. We hope you've enjoyed this journey into the world of data-driven decision-making. As always, we encourage you to try these concepts out in your own work.
Yeah.
Challenge those assumptions, and never stop exploring the exciting world of data.
Keep asking those tough questions, look for insightful answers, and use data to make a real difference.
And don't forget to like, share, and subscribe to The Deep Dive for more fascinating explorations into the world of data.
See you next time.
Until then, happy analyzing. All right, so you've been working with relational databases, right? And you're pretty familiar with data science, especially predictive modeling. But have you ever wondered what else is out there? What other cool things can you do with data science?
Well, it's easy to get caught up in just trying to predict the future, but data science has so much more to offer.
Oh yeah, for sure. Like what kind of things are we talking about?
Think about it like this. You can actually discover hidden relationships in data.
Okay, so like what does that even mean? Hidden relationship.
I mean, like uncovering links between things that you wouldn't normally think are connected. Like, imagine finding out that, say, people who buy beer are also more likely to buy lottery tickets.
Wow, okay. That's pretty random. But what's the point of even knowing that?
What's fascinating is how you can use that knowledge. Like, a supermarket could use that information to strategically place those items together, right? Maybe even boost their sales.
Oh, I see. Okay, that makes sense. So it's not just about, like, making predictions. It's also about understanding the data in a different way.
Exactly. And we can also use data science to find groups of similar things. It's kind of like sorting your spice rack, but instead of spaces, we're grouping customers by their buying habits, or movies by their genre, or even musicians by their style.
Right. So instead of asking, like, what movie will this person watch next?
Yeah.
We're asking what kind of movie watcher is this person.
Precisely.
Cool.
So what else?
Well, there's also understanding typical behavior. Imagine you could know what normal web traffic looks like for your website.
Okay, yeah.
That would help you quickly spot any unusual spikes or dips that could signal either a problem or a big opportunity.
Yeah, so it's like having a baseline. You know what to expect, so then you can see when something's off.
Exactly.
Okay, I'm starting to get the bigger picture here. But how do we actually go about finding these hidden relationships in all this data?
Well, one really powerful technique is called association rule mining.
Association rule mining. Okay. What is that? So, think of it like this. You analyze a huge data set of, let's say, transactions from a supermarket. You then look for items that frequently appear together in the same shopping basket.
Oh, so that's how they do those people who bought this also bought that recommendations.
You got it.
That's so cool. I always wondered how they figured that out.
And it's not just for online shopping either. Association rule mining has tons of applications like healthcare, finance, even social media.
Wow. Okay, so it's pretty versatile. But can you give me an example? Like, how does it actually work in practice?
Sure. Imagine we have data from a grocery store, right? So you look at all the receipts, and you notice that people who buy bread often buy butter, too.
Yeah, that makes sense.
Association rule mining helps you quantify that relationship. It basically tells you how often those two items appear together and how strong that connection really is.
So it's not just about noticing the pattern, it's about measuring it.
Exactly, because that helps you distinguish between just random coincidence and, an actual meaningful relationship. Like bread and butter, that's a strong association. Bread and toothpaste, probably not so much.
Right, so you know it's worth paying attention to. Makes sense.
And these relationships are represented as rules like if bread, then butter, meaning if someone buys bread, they're also likely to buy butter.
So we're using data to uncover these if-then relationships between items.
Right.
Okay. But how do we know which rules are actually important, like which ones are worth focusing on?
That's where things get a little more interesting. So association rule mining looks at two main factors, support and confidence. Support basically tells you how often that combination appears in the data.
Yeah.
And confidence tells you how likely it is that if someone buys one item, they'll also buy the other one.
Got it. So a rule with high support and high confidence, that's a valuable insight, right?
Absolutely. It means it's happening a lot, and it's a strong connection.
This is fascinating. I'm already thinking about how this could apply to, like, so many different things.
Yeah, exactly. And that's the great thing about association rule mining. It can be used in all sorts of domains. You can extract some really valuable insights from all kinds of data.
Okay, so we've been talking about uncovering all these, like, hidden relationships, right?
Mm-hmm.
But what about when you just have way too much data? It's like, how do you even begin to make sense of it all?
Yeah. Data can be overwhelming for sure. It's like having this huge library with millions of books, but no way to organize it.
Exactly.
That's where data reduction techniques come in. They help us simplify all that data without losing the important stuff.
Okay, that makes sense. So, like, what are some examples of these techniques?
Well, one technique is called latent information mining.
Latent information mining. I've never heard of that.
So imagine you're analyzing data from, say, a movie streaming service. You have all this info about users' ratings for different movies. But there's just so much data, it's hard to see the forest for the trees, you know? Latent information mining helps uncover those hidden patterns in the data. It reveals underlying factors that are driving those ratings.
So instead of just seeing a bunch of ratings, we're trying to understand, like, the why behind them.
Exactly. For example, latent information mining might reveal that a big factor in people's movie preferences is this, like, distinction between lighthearted and serious films.
Oh, interesting. So even though lighthearted versus serious isn't something that's, like, explicitly in the data, the algorithm can figure that out based on the ratings.
That's right. It's picking up on those hidden dimensions, and that can be really valuable for making recommendations. Like, even if someone hasn't specifically rated any lighthearted movies, the system can still recommend them if their watching history suggests they generally prefer that kind of film.
That's pretty cool. It reminds me of how, like, music streaming services recommend songs. It's like they know my taste even better than I do sometimes.
Yeah, it's the same idea.
But how do they actually use that latent information to make those recommendations?
Well, once those hidden dimensions are identified, they can be used to create a profile for each user and each item, right? So, like, your profile might indicate a strong preference for lighthearted movies, and then a particular movie might have a high score on that lighthearted dimension, and the recommendation system then uses those profiles to match users with items that they're likely to enjoy.
So it's like a matchmaking service, but for data.
Exactly.
I love that.
Yeah.
But it's not just for entertainment, right?
Yeah.
I bet you could use this for other stuff too.
Oh, absolutely. Latent information mining can be used in healthcare, for example, grouping patients with similar symptoms.
Oh, wow.
Or in marketing to segment customers based on their preferences. It has all sorts of applications.
Okay. So we've talked about uncovering hidden relationships and simplifying complex data. But what about when we actually want to improve the accuracy of our predictions?
That's where ensemble methods come into play.
Ensemble methods.
Yeah, think of it like this. Instead of relying on just one expert, you consult a whole panel of specialists, each one with their own perspective and expertise.
Okay, interesting. So instead of building one prediction model, we build multiple models and then combine their predictions.
Precisely. And by combining those diverse perspectives, we often get a much more accurate and reliable prediction.
Okay, I'm starting to see why that would work. But why does this approach actually improve accuracy?
Well, each individual model might have its own strengths and weaknesses, right? And each one might be prone to certain types of errors.
Right.
By combining multiple models, we're smoothing out those individual quirks. We arrive at a more balanced and reliable prediction.
So it's like that wisdom of the crowd idea, but applied to data science?
Yep.
Like we're leveraging the collective intelligence of all those models.
Exactly. And there are different ways to actually combine those models. Like, one approach is to simply average their predictions. Another approach is to assign weights to each model based on their performance. You give more weight to the models that have been more accurate in the past.
So it's not just treating every model equally, it's taking into account their track record.
Exactly. And that weighting scheme can really enhance the overall accuracy of the whole ensemble.
This is all making a lot of sense, but can you give me like a real world example of how this is actually being used?
Sure. Let's say you're working for a bank and you need to build a model to detect fraudulent credit card transactions.
Okay, yeah.
You could build multiple models, each one focusing on different aspects of the transaction data. Like one model might analyze spending patterns, another might look for unusual locations, and yet another might focus on the time of day the transaction occurred.
So each model is like a different detective investigating the same crime.
Exactly. And by combining those models, you create this much more robust fraud detection system, one that's less likely to be fooled by, clever fraudsters.
That's really interesting. It's like we've unlocked a whole new level of sophistication in our data science toolkit.
And this is just the tip of the iceberg. Ensemble methods are being used in all sorts of fields.
Really?
Yeah, like medical diagnosis, weather forecasting, and they're constantly pushing the boundaries of what's possible with predictive modeling.
It's amazing how far data science has come. We've gone from simple predictions to uncovering hidden patterns, simplifying complex data, and even boosting the accuracy of our models.
It's a really exciting field, and it's constantly evolving. Who knows what new techniques of applications we'll have in the years to come?
I can't wait to find out. But before we get too far ahead of ourselves, let's recap what we've learned today. We started by exploring those data science tasks that go beyond just predictive modeling, like uncovering hidden relationships and simplifying all that complex data. Right, so we talked about using association rule mining to find those if-then relationships. And then we got into latent information mining, which helps us take all that complex data and make it simpler by finding those hidden dimensions that drive behavior.
Yeah, and to finish up, we covered ensemble methods. It's like having that panel of experts, right? You combine all those models together to get a more accurate prediction. Like getting a second, third, and even fourth opinion to make sure you're making the best decision possible.
This whole deep dive has been so insightful. I'm looking at data science in a whole new way now. It's not just about predicting the future. It's about understanding what's happening now and making smarter decisions, no matter what field you're in.
Exactly. Whether you're talking about figuring out the best product placement in a supermarket, or personalizing those recommendations on a streaming service, or even catching fraudulent transactions, data science is becoming super important for tackling those real-world problems.
And the coolest part is, it feels like we're just getting started. There's still so much more to explore and discover in data science.
Oh, for sure. New techniques and applications are popping up all the time. It's one of those fields that's always pushing the limits of what's possible.
It's really inspiring to think about how data science can shape the future, But for those of us who aren't actual data scientists, how can we stay in the loop and keep learning about all these advancements?
That's a great question. There are actually a ton of resources available online. You can check out blogs, podcasts. There are even online courses that can help you stay up to date with everything that's happening in data science.
So even if we're not the ones crunching the numbers, we can still understand the impact data science has on our lives.
Absolutely. Being data literate is becoming more and more crucial in today's world, Everything is so data-driven. Even just understanding the basics of data science can help you make better choices in both your personal and professional life.
Well, this deep dive has definitely motivated me to keep learning. It's amazing to see how data science can uncover all those hidden patterns, help us make better decisions, and even solve some of the world's biggest problems.
It's been great exploring all of this with you. And I encourage everyone listening to keep digging deeper into the world of data science. You never know what you might find.
Well, that wraps up our deep dive into this amazing world beyond predictive modeling. We hope you enjoyed it and that you learned something new along the way.
And hey, if you liked what you heard today, don't forget to like, share, and subscribe to The Deep Dive for more awesome explorations into all kinds of knowledge and discoveries. See you next time.
Welcome back to The Deep Dive, where we like to say, the more you know, the better.
That's right.
And today we are diving into ethical considerations of data science.
Very relevant, especially in a tech-savvy nation like India.
Absolutely, yeah. We'll skip over all the jargon since we know, your way around relational databases already.
Yeah.
We're going to get right to the heart of how data privacy is really impacting businesses and consumers.
One of the things that's interesting is that data science is no longer this kind of back office function.
Mm-hmm.
It's actually giving companies a strategic advantage,
Right.
Especially in sectors like finance and telecommunications.
Okay.
So, that's where we're seeing a lot of the explosive growth here in India.
Yeah, that's right. And I think a perfect example of that is Amazon. Their recommendation engine is like a classic example of data science in action.
Absolutely.
It's really driving the e-commerce boom. But then it also starts to raise questions about how our data is being used.
Exactly. And, it's not just about personalized recommendations.
Okay.
I mean, think about banks using data to identify the best customers for a product or a service. So this data-driven decision-making can lead to massive growth.
Oh, yeah.
We've seen Capital One, for example. They reduced their charge-off rates significantly
Wow.
by just using data analysis.
That's a really powerful example. I'm curious of all this talk about AI going wrong and algorithms making mistakes.
Right.
Where do ethical considerations actually fit into the whole data modeling process?
Well, that's a really good point and a crucial question.
Okay.
A systematic approach like the CRISP-NIM framework, it really emphasizes careful problem analysis and evaluation. So it's not just about applying algorithms blindly.
Right.
You have to understand the problem you're trying to solve and the potential consequences.
I see. So while CRISP-BM does seem like a very comprehensive framework, how do companies then make sure they don't fall into this trap of biased data? Especially, in the Indian context where we have so many different demographics, socioeconomic factors.
That's where the ethical considerations really come in. Take predictive modeling, for example.
Okay.
It's like building a model that estimates an unknown value, right? So predicting whether a customer is going to churn, whether there's going to be some fraud.
I see. But isn't relying solely on predictive models, isn't that a little bit risky? Especially in a dynamic market like India?
Right.
What if the model itself perpetuates some kind of existing bias?
That's a really key point.
Okay.
The choice of variables and the data that's used to train the model,
Right.
They have huge implications.
Yeah.
For instance, if a model's predicting loan approvals,
Okay.
but it relies heavily on historical data that reflects past biases, it could unfairly disadvantage certain groups.
So it's not just about the model's accuracy.
Right.
It's also about the fairness.
Yeah.
And its potential impact on these different communities.
Absolutely. You're spot on.
Okay.
And this is where really understanding the nuances of model building becomes so critical. For example, the concept of overfitting.
Okay.
Where a model performs really well on the training data, but fails to generalize to new data. That can have serious ethical consequences.
I see what you mean. So a model that is overfit to a particular data set could make inaccurate predictions.
Absolutely.
About individuals or groups it hasn't encountered before.
Right.
And that could lead to potentially unfair outcomes.
Precisely. And this is especially relevant in sensitive areas like credit scoring or fraud detection.
Right.
With inaccurate predictions can have a significant impact.
Yeah.
On people's lives. Techniques like cross-validation, they're essential.
Okay.
To ensure that a model generalizes well.
Okay.
And it doesn't perpetuate existing inequalities.
Yeah. Now, we've talked a lot about predicting outcomes. But what about understanding broader patterns in the data?
Yeah.
I'm thinking about things like market segmentation, hugely important.
Right.
Especially in a diverse market like India.
Absolutely. That's where clustering techniques come in.
Okay.
So, these techniques group similar objects together based on their characteristics.
Okay.
So imagine being able to tailor marketing campaigns to specific customer segments.
Right.
Based on their preferences and needs.
That sounds incredibly powerful. Could you give us maybe an example of how clustering might be used ethically in the Indian context?
Sure. Take the example of healthcare.
Okay.
So clustering algorithms, they could be used to identify patterns in patient data, which could help predict disease outbreaks or even personalized treatment plans. But it's crucial to make sure that these models don't inadvertently discriminate against certain patient groups,
right?
Based on factors like socioeconomic status or geographic location.
So while clustering has this huge potential for good, we really have to make sure that it's implemented responsibly.
Absolutely.
And that it doesn't perpetuate existing healthcare disparities.
And this brings us to another key aspect of ethical data science, and that's evaluating model performance.
Okay.
It's not enough to just look at the overall accuracy, especially when you're dealing with imbalanced data sets.
Can you explain what you mean by imbalanced data sets?
Yeah.
And how does this relate to the ethical considerations?
So imagine you're building a model to detect fraudulent transactions.
Okay.
Right? In most cases, fraudulent transactions are a tiny fraction of the overall data.
Right.
So a model that simply predicts no fraud for every transaction could achieve very high accuracy, but it would be completely useless in identifying actual fraud.
So in this case, a high accuracy rate doesn't actually reflect the model's true effectiveness.
Exactly.
We really need to go beyond just accuracy
Yeah.
to understand how well it's actually performing across those different categories.
And that's where tools like the confusion matrix, they come in.
Yeah.
You know, it helps to visualize the different types of errors the model makes.
Okay.
Like false positives, false negatives.
Okay.
Which is crucial in understanding the ethical implications
I see.
of model performance.
I'm starting to see how all of these technical aspects are really deeply intertwined with the ethical considerations. It's not just about building accurate models.
It's about ensuring that they are fair, unbiased, and used responsibly.
Yeah. And this is especially important here in India.
Absolutely.
Where data is really playing such an important role in shaping our society and our economy.
That's precisely the point. Data science has immense potential to solve these complex problems, drive innovation.
Right.
But it's crucial to wield this power responsibly and ethically.
Yeah.
Especially here in India, where data is playing an increasingly important role in shaping our society and economy.
That's a great point. It feels like we're at a crossroads here in India where data science is transforming so many industries.
Yeah.
But we're also really grappling with how to use this technology responsibly.
You hit the nail on the head.
Yeah.
India's rapid digital growth presents immense opportunities, but also complex challenges when it comes to data privacy. We have a massive population, a booming e-commerce sector, and a constantly evolving regulatory landscape.
Yeah, and it's exciting to see how data can be used for social good, like you were talking about, financial inclusion,
Absolutely.
personalized healthcare.
Yeah.
But then I also worry about the potential for data breaches, misuse of personal information, especially in a country as digitally connected as India.
That's a valid concern.
Right.
The more data we collect, the more vulnerable we become.
Yeah.
That's why responsible data governance is crucial. Companies operating in India, they need to be mindful of cultural sensitivities, data privacy expectations, and of course the evolving legal framework.
Speaking of the legal framework, how is the Indian government addressing these data privacy concerns?
Well,
I know there's been a lot of talk about a new data protection law.
Yes.
Is that in the works?
The Personal Data Protection Bill, it's still under discussion.
Right.
But it aims to create this comprehensive framework for data protection. It's similar to GDPR in Europe. It emphasizes principles like data minimization, purpose limitation, and consent. So essentially setting ground rules for how data can be collected, used, and protected.
So it's kind of like giving individuals more control over their own data.
Exactly.
And then also holding companies accountable for how they use it.
Absolutely. And, these regulations are crucial for building consumer trust and fostering a responsible data ecosystem in India.
Yeah.
It's about finding that balance between innovation and protecting individual rights.
It sounds like a pretty complex balancing act.
It is.
How are companies in India actually navigating these challenges in practice? Are there any concrete examples of ethical data handling that you can share?
Absolutely.
Okay.
Many companies are adopting privacy-enhancing technologies, like differential privacy, which allows them to extract insights from data without compromising individual privacy.
I see.
It's like being able to analyze trends without actually seeing the individual data points.
Right.
They're also investing in robust data security measures and implementing data anonymization techniques to protect sensitive information.
So it's encouraging to hear that there are companies that are actually taking these steps.
Yeah.
It seems like the awareness of ethical data practices is growing, both among companies and consumers.
Absolutely.
Yeah.
And, this awareness is being driven by several factors.
Okay.
We're seeing more consumer advocacy groups raising concerns about data privacy, regulatory pressure from the government, and I think a growing understanding among businesses that data misuse can lead to reputational and financial damage.
It makes sense, that companies would start to realize that protecting consumer data, it's not just an ethical imperative,
Right.
but also just good business practice.
It is.
Builds that trust and loyalty in the long run.
Precisely. And, this shift in mindset is essential
Yeah.
for the healthy development of India's digital economy.
Okay, so what can individuals do to protect their own data privacy
Yeah.
in this increasingly data-driven world?
Well,
It feels like we're constantly sharing information online these days.
you're right. Awareness is key.
Okay.
Individuals need to understand their data rights.
Mm-hmm.
Be cautious about sharing personal information online.
Right.
And carefully review privacy policies before using any apps or services.
Yeah.
It's about being an informed consumer in the data world,
Mm-hmm.
knowing your rights and making conscious choices about your data.
That's great advice. And it's empowering to know that we have a role to play
Yeah,
in protecting our own privacy.
absolutely.
We don't have to passively hand over our data.
Right.
We can ask questions.
Uh-huh.
We could demand transparency
Yeah.
and make informed choices.
Taking an active role in protecting your own privacy is crucial in today's digital landscape.
This conversation has been incredibly insightful.
Oh, thank you.
It's clear that these ethical considerations surrounding data science,
Yeah.
they're complex and multifaceted, especially, in a rapidly developing country like India.
Absolutely.
As we wrap up this deep dive, what final thought would you leave our listeners with?
Well, I think data science is a powerful tool with the potential to transform industries and improve lives.
Right.
But as with any powerful tool,
Mm-hmm.
it's crucial to use it responsibly and ethically.
Yeah.
So let's strive to build a future
Oh,
where data empowers us
right.
without compromising our privacy or our values.
Well said. Thank you for sharing your expertise with us
It's been a pleasure.
and guiding us through this important topic.
My pleasure.
I'm sure our listeners have learned a lot,
I hope so.
just as I have. So for our listeners who want to kind of delve deeper into this topic, where would you suggest they start?
Well, I think a great starting point would be to actually research the Personal Data Protection Bill here in India.
Okay.
Understanding its key provisions and its potential impact will give you a really good grasp of the evolving data privacy landscape.
That's a great suggestion. And beyond regulations, what broader trends in ethical data science should we be paying attention to?
Keep an eye on the development and adoption of privacy-enhancing technologies.
Okay.
Things like federated learning, where models are trained on decentralized data without compromising individual privacy.
Right.
Or homomorphic encryption, which allows computations on encrypted data without decrypting it.
Uh-huh.
Those are gaining traction and hold immense potential.
So it's really about finding these innovative solutions that prioritize privacy from the ground up,
Exactly.
rather than treating it as an afterthought.
You got it. It's not just about complying with regulations, but embedding ethical considerations into the very fabric of data science practices.
This deep dive has been truly eye-opening. It's clear that the ethical considerations of data science aren't just a technical issue, but a societal one with far-reaching implications, especially here in India.
I completely agree. As data science continues to evolve, these open and honest conversations about its ethical implications are crucial. We need diverse perspectives, ethicists, policymakers, technologists, and the public to shape a future where data benefits humanity without compromising our values.
Thank you for guiding us through this complex and important topic. You've given us a lot to think about.
It was my pleasure. Remember, knowledge is power, but ethical knowledge is transformative power.
And that's a wrap for today's deep dive into the ethical considerations of data science. Don't forget to like, share, and subscribe to The Deep Dive for more insightful explorations into the world of information. Until next time, keep diving deep. All right, let's jump right in today. We're doing a deep dive into how data science can give businesses a real advantage, especially for everyone out there who knows their way around a database.
Yeah, that's a great point. We'll be talking about those who work with databases and how data science is something they can really leverage.
Exactly. We're going to be talking about how big companies like Google and Amazon use data to kind of, dominate their markets.
Right.
And more importantly, how you, even with a smaller business, can actually use data science to grow.
Yeah, that's what's so fascinating about this.
Right.
These big companies, they've figured out how to use data to kind of create a secret weapon for themselves.
Like a superpower almost.
It is. And they figured out data isn't just storing information. It's about unlocking these insights that can almost predict what a customer wants before they even know it.
It's like they can see the future of their business.
Yeah, exactly.
How do they do that? I mean, We all use Google, we all use Amazon, but what's actually happening behind the scenes?
Well, think about it this way. Every time you search on Google, it's not just giving you a list of websites. It's actually taking your search terms, what you've clicked on before, maybe even where you're located, and it's tailoring those results specifically for you.
So it's like Google's learning my preferences, trying to anticipate what I'm looking for. That's kind of spooky,
It is a little bit,
but also kind of cool.
but also pretty cool. Yeah, it's all about personalization. And Amazon does a very similar thing, right? They track your purchase history, what you've looked at, even what other people who bought similar items also bought, and then use that to recommend things to you.
So it's not just about having a lot of data. It's about knowing how to use it to understand customer behavior.
Exactly, yeah.
But does that really make that much of a difference?
Oh, the results speak for themselves. Data-driven companies, they're often much more profitable because they can make smarter decisions. They know who to target with their marketing, how to price their products, even, how to keep customers from going to the competition.
Yeah, that makes a lot of sense. But all this analysis, I'm guessing it takes a lot of resources, right? Something that smaller businesses might not have.
Well, that's the great thing about data science today. It's not just for those big players anymore. Even a small business generates tons of valuable data.
What do you mean? Like what kind of data?
Think about sales records, website visits, customer feedback.
So even my local chai stall could be sitting on a gold mine of data.
Oh, absolutely. Imagine if they track which chai flavors are popular at different times of day, or if certain snacks are always bought together. That kind of insight, that could help them optimize their menu, boost their sales.
I'm starting to see the potential here. But how does a small business owner who might not be a tech expert even begin to make sense of all this data?
Well, you don't need to be a data scientist to get started. There are plenty of affordable, easy-to-use tools out there that can help you analyze your data, find those meaningful patterns.
So it's about taking that first step and starting to see your business through kind of a data lens.
Yeah. And you'll be amazed at the insights you uncover. Even simple things like identifying your most loyal customers or understanding which marketing campaigns are working best.
Right.
Those things can make a huge difference.
It's really eye-opening. I'm starting to see how data science is kind of leveling the playing field, giving small businesses a fighting chance.
Yeah. In the digital age, data is power, and now, that power is within everyone's reach.
This is fascinating. I'm already thinking about how I can apply these ideas. But before we get too carried away, let's take a step back and talk about how this systematic approach to data actually works. It can't all be magic, can it?
Well, you're right. There is a method to the madness.
Yeah.
Data science uses frameworks like the CRISP-DM to guide the process of extracting knowledge from data. It makes sure we're doing things in a structured way.
CRISP-DM. That sounds a bit technical. Break it down for me.
Sure.
And for our listeners who might not be familiar with it.
So think of CRISP-DM like a recipe.
Okay, I like that.
With 6 key ingredients.
Okay. First, you have to understand what you're trying to cook up, like your business problem.
Right.
Then you gather all your ingredients. In this case, your data.
So we're talking about identifying what questions we want to answer and then collecting the data that might hold those answers.
Exactly. And then the next steps involve prepping your ingredients, like, cleaning and preparing that data so it's ready for analysis.
So it's like getting everything ready to actually start cooking.
Yeah. Then comes the exciting part, the actual cooking, or in this case, modeling.
Ah, the modeling stage. So this is where we use algorithms and statistical techniques to find patterns and relationships within the data, right?
You got it. But before we serve up our insights, we have to do a little taste test. This means evaluating the model, making sure it's accurate and reliable.
So ensuring that our insights are actually valuable.
Exactly. And the final step is to present our culinary masterpiece, or in this case, to deploy that model and actually use the insights to improve the business. So it's not just about building a model. It's about putting it into action and using those insights to drive real change.
Precisely. CRISP-DM gives us that structure. We get the most from our data and solve real business problems.
CRISP-DM. I'm adding that to my recipe. But how does this all play out in a real-world scenario?
Okay, well, let's bring it back to our local Kirana store owner getting ready for Diwali.
Okay.
They want to make sure they have enough of the right products in stock, right? So they don't miss out on sales.
Okay, yeah, that's a crucial time for them. Lots of potential customers, lots of competition.
Exactly. So using CRISP-DM, they'd first identify that problem. predicting demand for Diwali products, then gather their data, which might include past sales records, customer demographics, even local festival trends.
So they're looking for any information that could help them understand what people are likely to buy during Diwali.
That's right. They would then clean and prepare this data, maybe removing any irrelevant information or addressing any inconsistencies.
Making sure the data is as accurate as possible.
Yeah.
Yes. Next comes that modeling stage. They might use a forecasting algorithm, for instance, to predict which products will be in high demand based on those past sales and current trends.
So they're using the past to predict the future.
Exactly. Then they would want to evaluate the accuracy of the model, perhaps by testing it on a small set of data to see how well it predicts actual sales.
Okay.
And finally, they deploy the model using those insights to adjust their inventory and stock up on the products that are likely to be most popular during Diwali.
Wow, that's really putting data science into action. They're not just guessing, they're making data-driven decisions to maximize their profits during Diwali.
That's the power of it. It's about taking a structured approach, ensuring you're getting the most out of your data and using it to actually achieve your business goals.
I'm starting to see how data science is more than just a buzzword. It's a powerful tool that can help businesses of all sizes make better decisions, thrive in a competitive market. But before we go any further, let's take a quick break.
Sounds good.
And when we come back, we'll dive deeper into how even small businesses can leverage data science for growth. We'll explore the tools and techniques that are available, as well as the challenges and opportunities that data science presents. So stay tuned.
Right.
Don't forget to like, share, and subscribe for more deep dives into the fascinating world of data. We'll be right back after this short break. Welcome back. Before the break, we were talking about, a Kirana store owner using data science to get ready for Diwali.
Yeah.
And that example, I think, really shows how even small businesses can really benefit from making these data-driven decisions.
It really clicked for me how they could use that, past sales data to predict what their customers will want.
Yeah.
But what about businesses that don't have, years of sales records? Can they still use data science effectively? Absolutely. You don't need a massive database to get started. Even a small amount of data can be incredibly insightful. Let's say, you just opened a new chai stall. Instead of waiting months to gather sales data, you could use data about your local area.
Oh, okay. What kind of data are we talking about here?
Well, think about demographics, right? Like the age groups in your neighborhood, average income levels, even things like weather patterns. You can find a lot of this data publicly available.
I see. So you could use that to, tailor your menu to the local tastes, or maybe offer iced chai on hotter days.
Exactly. You could even, tap into social media data to see what people in your area are saying about, chai or snacks, what their preferences are.
That's a clever way to stay ahead of the trends.
Yeah.
So you don't necessarily need your own data to start using data science.
Right.
But once you do have data, what are some of the tools that small businesses can use?
Well, the great thing is there are a ton of affordable and user-friendly tools available now, spreadsheet software, which many businesses already use, that can actually do basic data analysis. And then there are free open source tools like R and Python that offer more advanced capabilities.
Hold on. R and Python. Those sound pretty technical. Are you saying that, like, a chai stall owner needs to learn to code?
No, not necessarily. There are actually user-friendly platforms built on top of these languages that make data analysis a lot easier. They often have, these drag-and-drop interfaces and pre-built functions that make it easy to create charts, identify trends, generate reports, all without writing a single line of code.
That's a relief. So there are options out there that don't require a degree in computer science.
Yeah.
But let's say you're a small business owner, you've gathered some data, you've even found a tool that you're comfortable with. Where do you even start? It still feels overwhelming.
Right. You're right. It can be. That's why it's important to start with a clear goal in mind. What specific question are you trying to answer?
Okay. So if I'm that chai stall owner, my question might be, what's the best way to increase sales during the evening rush?
Exactly. Then you can look at your data to see if there are any patterns, any insights that might help you answer that question. Maybe you notice that sales spike on evenings when it's raining, so you decide to offer a discount on rainy days. Or perhaps you find that people who buy samosas often also order masala chai, so you create a combo deal.
Right. It's about spotting those hidden connections and using them to your advantage. I'm really starting to see how data can be like a secret weapon for small businesses.
Yeah.
But with all this talk about tools and techniques, let's not forget the human element. How do you balance data-driven decisions with good old-fashioned intuition?
That's a great point. Data science should be seen as a tool to augment human intuition, not replace it. You know your business better than anyone, and your experience is valuable.
So it's about using data to inform your decisions, but not letting it dictate them completely.
Exactly. Data can provide insights that you might not have seen otherwise, but it's up to you to interpret those insights and make that final call based on your knowledge and your understanding of your business.
So it's about finding that sweet spot between data and intuition.
Right.
But as a small business owner, you're often wearing multiple hats. You're the CEO, the marketer, or the salesperson all rolled into one. How can you possibly find the time for data analysis?
You don't need to dedicate hours every day to data analysis, to see results. Even setting aside 30 minutes a week to just look at your data can be incredibly valuable.
So it's about making data analysis a part of your routine, not a separate chore.
Exactly. You can even start with just one specific area of your business, like marketing or inventory management. And then as you get more comfortable, you can gradually expand those data analysis efforts.
It's about taking small steps and building momentum.
Right.
But what about the cost? We've talked about free and affordable tools, but surely there are other expenses involved in using data science.
Well, the truth is the cost of not using data science can be far greater than the cost of implementing it.
Oh, and how so?
Well, think about, lost sales from not understanding those customer preferences or inefficiencies in your operations that are costing you money.
I see what you mean. It's an investment that can pay off in the long run by making your business more efficient, more profitable.
Precisely. And there are plenty of resources available to help small businesses get started with data science. There are online courses, workshops, even government initiatives that provide support and guidance.
So there's really no excuse not to dive into the world of data.
Yeah.
It's accessible, it's affordable, and most importantly, incredibly valuable for businesses of all sizes. But before we get too carried away with all the amazing things that data science can do, let's take a moment to talk about some of the potential pitfalls. Data can be powerful, but it can also be misleading if not used carefully, right?
That's absolutely right. One of the biggest challenges in data science is something called overfitting.
Overfitting. That sounds ominous. What exactly does that mean?
So imagine you're trying to teach a child how to recognize different types of animals based on pictures.
Okay.
You show them pictures of, dogs and cats and birds and so on, and they start to learn those patterns.
Okay, I can see where you're going with this.
Now imagine that you only show them pictures of golden retrievers when you're teaching them about dogs. They might learn to identify golden retrievers perfectly. But what happens when they see a dachshund for the first time?
They might not recognize it as a dog because it doesn't fit the pattern they've learned.
Exactly. That's what overfitting is. It's when your model learns the specifics of the data you've given it so well that it can't generalize to new unseen data.
So it's like studying for a test by memorizing the answers instead of understanding the concepts.
Yeah.
You might ace the test, but you won't be able to apply that knowledge in the real world.
That's a great analogy. In data science, overfitting can lead to inaccurate predictions and poor decision making.
Okay, that makes sense. But how do you avoid falling into the overfitting trap?
Well, there are a number of techniques that data scientists use to prevent this. One is called holdout evaluation.
Holdout evaluation. Okay, I'm intrigued.
It's actually a very simple concept. Imagine you're practicing for a cricket match. You don't just bat in the nets, right? You also play practice matches to test your skills in a real game situation.
Yeah, that's true. Practice matches help you see how you perform, under pressure.
Exactly. Holdout evaluation is like a practice match for your data model. You split your data into two sets, a training set and a test set. You use the training set to build your model, and then you use the test set, which the model has never seen before, to evaluate its performance.
Oh, so it's like seeing how well your batting skills translate to a real match.
Precisely. If your model performs well on both the training set and the test set, then you can be more confident that it's not overfit and that it can generalize to new data.
This is fascinating. It's like having a safety net to catch potential problems before they turn into disasters.
Yeah.
But holdout evaluation is just one technique, right?
Yeah.
What are some other ways to prevent overfitting?
Well, another common technique is called cross-validation, and it's similar to holdout evaluation, but instead of just splitting the data once, you split it multiple times and train multiple models. This helps to ensure that your model is robust and not overly sensitive to the specific way that the data was split.
Oh, so it's like playing multiple practice matches against different teams to get a more well-rounded assessment of your skills.
Exactly. And there are other techniques like regularization, which adds a penalty to complexity, encouraging simpler models that are less prone to overfitting. It's all about finding that right balance between complexity and simplicity, creating a model that's powerful enough to capture the patterns in the data, but not so complex that it gets lost in the noise.
I'm starting to see the data science is more than just crunching numbers. It's about understanding the nuances of the data and making these strategic decisions to ensure your model is reliable and accurate.
Yeah, that's a great observation. Data science is a combination of art and science.
Uh-huh.
It requires technical skills, but it also requires, critical thinking, creativity, and a deep understanding of the problem that you're trying to solve.
This has been an incredible journey into the world of data science. We've covered so much ground, from the power of data-driven decision-making to the importance of understanding and mitigating overfitting. But we're just getting started. Welcome back to the Deep Dive. Before the break, we were getting into the nitty-gritty of data science, even touching on some of the challenges like overfitting.
Right.
It's amazing how much goes into building a reliable model.
Yeah, it really highlights how data science is a process, not a magic button,
Right.
There's a lot of careful consideration and technique involved.
Speaking of technique, you mentioned earlier that people who work with relational databases, already have a head start in data science. Can you expand on that a bit?
Sure. So if you're comfortable with SQL queries, you're already familiar with structuring data, filtering it, extracting information, and those are foundational skills in data science.
So the skills you use to manage and query a database are directly applicable to analyzing data for insights.
Exactly, yeah. And in fact, many of the tools and techniques that are used in data science actually build upon those SQL foundations. For instance, that chai stall owner who wants to see if samosa buyers also prefer masala chai, that's a question they could answer with a well-crafted SQL query on their sales data.
Oh, wow. I hadn't thought of it that way. It's like those SQL skills are a secret decoder ring for the world of data science.
Yeah, that's a great way to put it. And as you delve deeper into data science, you'll find that many of the concepts like joining tables or grouping data, they have direct parallels in more advanced analytical techniques.
That's really encouraging for anyone who's already comfortable with databases. It's like they're already on the path to becoming, data savvy.
Right.
This is really exciting. But let's bring it back to the big picture for a second. We've talked about Google, Amazon, even chai stalls using data science. Where do you see all this heading in the future?
The future of data science is incredibly bright. As more and more data becomes available and as those tools and techniques become even more powerful, we're going to see data science transforming industries in ways we can't even imagine yet.
So it's not just about, optimizing a menu or predicting Diwali sales anymore. It's about solving bigger, more complex problems.
Yeah, absolutely. Imagine using data science to personalize healthcare treatments. Or to develop smarter transportation systems, or to create more sustainable energy solutions. The possibilities are really endless.
It's almost like data science is a superpower that we're only just beginning to understand. But with great power comes great responsibility, right?
That's a crucial point. As data science becomes more powerful, it's essential that we use it ethically and responsibly. We need to ensure that the models we build are fair, unbiased, and transparent.
So it's not just about the technical skills, it's about the ethics behind how we use those skills.
Yeah.
It's about using data science to make the world a better place, not just to boost profits.
Yeah, exactly. The future of data science really depends on our ability to balance the power of these technologies with a strong sense of ethical responsibility.
This has been an incredible deep dive into the world of data science. I feel like I've learned so much about how data can be used to drive business success, from multinational corporations to local chai stalls. It's clear that data is no longer just a technical concern. It's a strategic asset that every business needs to leverage.
It's been a pleasure exploring this fascinating topic with you.
Likewise.
The key takeaways, remember, are to start small, be curious, and don't be afraid to experiment. The world of data science is waiting to be explored.
And for those of you listening, if you're intrigued by what you've heard today, don't forget to like, share, and subscribe to The Deep Dive for more explorations into the fascinating world of data. Until next time, keep diving. Welcome back to The Deep Dive. Today, we're going to be diving into a topic that's super important for succeeding in business these days. Data literacy.
Right.
We'll be exploring why it's so essential for leaders to grasp data science principles.
Yeah, and especially if you're already familiar with relational databases, this is going to be really interesting.
I cannot wait.
It's fascinating to see how data is completely transforming the business world. Like companies that were once small players,
Right.
they're now giants. And a lot of that comes down to them embracing data early on.
Oh, absolutely. So it's not just about having data. It's about understanding what to do with it. Like Capital One, right?
Yeah.
They started out as this small bank.
Yeah.
But they used data to become a major player in the credit card game.
Exactly. That's a prime example. They basically use data to understand their customers
Right.
better than anyone else. And that gave them a huge edge.
Yeah.
Data science is really all about extracting knowledge from that raw data, finding the patterns, the trends, and using that information to solve business problems.
That's like those ads you see online, right? They're like eerily tailored to your interests.
Yeah.
They're using your data to figure out what you're most likely to buy.
Oh, yeah, absolutely. Like here in India, finance and telecom industries are already using this stuff for a competitive advantage. Big time.
Yeah, that makes sense. But for someone who's already used to working with databases, how is data science different?
Well, with databases, you're often organizing and retrieving specific pieces of information, right? But data science takes it a step further.
Yeah.
It's about using that information to build models that can predict future outcomes.
So like predicting which customers are most likely to switch to a competitor?
Yeah.
Yeah.
Precisely.
That is incredibly valuable.
It is. It really is. And that's a perfect example of what we call supervised learning.
Okay.
So in supervised learning, you're using data where the outcome is already known. So like in your example, past customer churn to predict future churn.
Okay. So you're basically teaching a computer to recognize patterns.
You got it.
By feeding it information.
Yeah.
About the customers who've already left.
Exactly.
And it learns.
Yep.
What kind of behaviors or characteristics might signal that someone's thinking about jumping ship?
Yeah. And the best part is, once you have that model, you can use it to proactively address potential churn, like offering targeted discounts or maybe reaching out to understand their concerns before they actually leave.
It's amazing. Like a crystal ball.
In a way, yeah.
But instead of magic, it's data.
Yeah. And you know what? The applications go way beyond churn.
Oh, really?
You can use it for targeted marketing, identifying fraud, even optimizing pricing.
So this could obviously get very complex.
Oh, yeah.
How do you know if the model is actually doing a good job?
That's a great question. And that's where understanding model accuracy comes in. It's a balancing act between how well the model fits the data and how complex it is.
So a more complex model isn't always better?
Not necessarily, no. If it's too complex, it might just memorize the data you use to train it instead of learning the underlying patterns.
Right.
We call that overfitting.
So it's like a student who memorizes the textbook.
Yeah.
But doesn't actually understand the concepts.
Exactly.
So when they get a slightly different question, they're lost.
Totally. It's all about finding that sweet spot.
Yeah.
The right level of complexity.
Right.
To make accurate predictions without overfitting.
It sounds like that's where the expertise of a data scientist comes in.
Oh, absolutely. Absolutely. But even if you're not building the models yourself, understanding these concepts is crucial for leaders.
Okay.
It's about being able to ask the right questions and evaluate the results that you're being given.
So let's say I'm presented with this model.
Yeah.
To predict churn.
Okay.
what are the key data skills I need to even understand what's going on?
So one important concept is what we call information gain.
Okay.
And it helps us measure how much a particular variable tells us about our target outcome.
So in our churn example,
Yeah.
would that be like knowing how much a customer's age?
Exactly.
Which, our example, tells us about their likelihood of leaving.
Exactly.
Got it.
It helps us understand which pieces of data are actually valuable for making those predictions.
Okay. Yeah.
And once you know which variables are informative,
Yeah.
you can use visualization tools.
Visualization tools
Yeah.
like graphs and charts and things.
Exactly.
Right.
Things like profit curves
Okay.
and ROC graphs. They can help you assess and compare different models without getting lost in the technical weeds.
Right.
They give you this clear visual representation of how well a model is actually performing.
Oh, even if I don't understand the math behind it, I can still see if it's working or not.
Exactly.
Yeah.
Yeah. And you know what?
Yeah.
These tools, they're becoming so user-friendly.
This is all super fascinating, but I have to admit it still seems a little daunting. What's the most important takeaway for business leaders who might be feeling a bit overwhelmed?
The most important takeaway is you don't need to become a data scientist yourself.
Okay, good.
But understanding the fundamentals of data science, it's no longer optional.
Right.
It's becoming as essential as understanding finance or marketing.
So it's about being data literate.
Exactly. And that means being able to think critically about data, ask the right questions, and evaluate the potential of data-driven solutions.
This has been incredibly insightful. It really highlights how data literacy can empower leaders to make better, more informed decisions.
It does. It really does. And for leaders in India who are often already familiar with relational databases,
Right.
this is like a natural next step for them,
Building on that foundation you already have.
Exactly.
Yeah.
And as the use of data just keeps growing, those who embrace data literacy are going to have a significant advantage.
That's a great point. And remember, folks, we're just scratching the surface here.
Oh, yeah.
There's a whole universe of data science out there waiting to be explored.
Absolutely.
Exciting.
It is exciting. And who knows, maybe one day you'll be leading the charge in your own organization, using data to solve problems and create a brighter future.
That's a great note to end on. Thanks for joining us today
It was my pleasure.
for another geek dive into the world of knowledge.
Absolutely.
And don't forget to like, share, and subscribe to The Deep Dive for more fascinating insights delivered right to your ears.
Yeah.
We'll see you next time for another exciting exploration.
See you then. It really is. And the great thing is, you don't have to become a data scientist overnight. You can start by just shifting your mindset,
Okay.
Start asking questions about your business. That can be answered with data.
That's a great starting point. I think a lot of people get overwhelmed with just the sheer volume of data out there. So focusing on the questions that matter most seems like a good way to cut through all that.
Exactly. And don't be afraid to seek out some resources,
Yeah.
Learn more. There are tons of great courses and books, online communities, all dedicated to data science.
All about continuous learning.
Absolutely. And as you learn more, you'll be better equipped to really lead your organization in this data-driven world.
For those of us listening who are thinking, this all sounds great, but how do I actually apply this in my business? Where do we go from here?
That's where the rubber meets the road, right? So start by identifying a specific problem or opportunity in your business.
Okay. So let's say I'm running a manufacturing company.
Okay.
And I'm noticing increasing delays in our production line. Could data help me with that?
Absolutely. So you could collect data on all sorts of factors that impact production.
Okay.
Right, like machine downtime, material availability, even worker shift patterns.
Okay.
And then you could use all that data to identify any bottlenecks and inefficiencies.
So instead of just guessing what's causing the delays, I could have actual data to pinpoint those problem areas.
Precisely. And once you know where those problems are, you can start developing solutions.
Okay.
Maybe it's investing in new equipment, optimizing your supply chain, even adjusting work schedules.
It's about making data-driven decisions instead of relying on that gut feeling
Exactly.
or guesswork.
And those data-driven decisions are often way more effective and efficient.
I can see how this could apply to a ton of different areas of business,
Oh, yeah.
from marketing and sales
Yeah.
to operations and finance.
Absolutely. The key is to start thinking about how data can be used to address those specific challenges and opportunities within your organization.
It's not about seeing data as something intimidating, but more as like a powerful tool that can help us achieve our goals.
That's a great way to put it. And for leaders in India, who are often already pretty comfortable working with data and relational databases,
Yeah.
this is like a natural evolution for them.
It's like taking the skills you already have and applying them to a whole new level of problem solving.
Exactly. And as the world just becomes increasingly data-driven,
Right.
those who embrace this approach, they're going to be the ones that thrive.
This has been an incredibly eye-opening conversation. It's clear that data literacy is no longer like a nice to have. It's a must-have.
It is.
For any leader who wants to stay ahead of the curve.
I completely agree. It's about empowering leaders to make smarter decisions, solve those complex problems, and ultimately drive their businesses forward.
Well said. And remember, folks, this is just the beginning. There's a whole world of data out there waiting to be explored. Don't be afraid to dive in and see what insights you can uncover.
That's right. And as you just gain more experience with data, you'll be amazed at the possibilities it unlocks.
So to wrap things up, what's one key piece of advice you would give to leaders who are just starting their journey towards data literacy? What's that first step?
The first step is simply to start, Don't let that perceived complexity of data science hold you back.
Start small, ask questions, and don't be afraid to experiment.
Exactly. And remember, there are tons of resources out there to help you along the way.
That's great advice. Start small, keep learning, and embrace the power of data.
Absolutely.
It's been a pleasure having you.
It's been a pleasure joining you today for this deep dive.
This has really been a fascinating deep dive.
It has.
We've talked a lot about using data to predict things,
Yeah.
like customer churn, but it feels like there's so much more to explore
Oh, there is.
in the world of data science.
Absolutely. We've mainly focused on supervised learning, where you have that specific outcome in mind, but then there's also unsupervised learning, where you're letting the data itself reveal those patterns.
That sounds intriguing. Can you give me an example of how that would work in a business?
Sure. Think about customer segmentation.
Okay.
You could use unsupervised learning to group customers based on their buying behaviors or their demographics. So instead of trying to predict a specific outcome, you're uncovering those natural groupings
Okay.
within your customer base.
So it's like the data is telling you, hey, you actually have 3 distinct types of customers here.
Exactly. And that knowledge is gold.
Yeah.
You can tailor your marketing messages, product offerings, even customer service approaches to better suit each group.
It's like data-driven personalization.
Precisely. And that's just one example.
Wow.
Unsupervised learning can also be used for things like anomaly detection,
Okay.
spotting unusual patterns in the data that might indicate fraud or system errors.
It sounds like both supervised and unsupervised learning
Uh-huh.
can be powerful tools.
They are. And the key is understanding which tool is right for the job, which goes back to the importance of data literacy for those leaders.
It's about having that knowledge to ask the right questions and then evaluate those solutions presented to you.
Exactly. It's really all about building that data-driven culture
Yeah.
within your organization. It's encouraging everyone to see data as this asset
Right.
and to think critically about how they can use it.
It's not just about having a few data scientists on staff. It's about empowering everyone to use it effectively.
Exactly. That's where data-driven leadership comes in. Leaders need to set the tone
Right.
and create that environment where data is embraced and used responsibly.
So data literacy for leaders
Yeah.
isn't just about understanding the technical stuff. It's about leadership as well.
Oh, it absolutely is. It's about understanding the potential of data, recognizing its limitations, and using it ethically to move your business forward.
This has been such a valuable deep dive.
It has.
I think for anyone listening, especially business leaders in India, who are already so comfortable with data in relational databases,
Yeah.
this really highlights the importance of taking that next step
It does.
towards data literacy.
I couldn't agree more. It's about embracing that power of data
Right.
to make better decisions, solve those complex problems,
Yeah.
and shape a brighter future for your organization.
On that note, we've reached the end of another deep dive. Thanks for joining us on this exploration of data literacy.
It's been a pleasure.
And for all of you listening, don't forget to like, share, and subscribe to The Deep Dive for more fascinating journeys into the world of knowledge. Until next time, keep exploring.